the
graduation
engineers that go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best batch. Kaba Biotech is already research in the region by providing quality products to researchers. To many more years in Kaba Biotech, your African genomics.
Okay. Sawa.
Science is our passion and business, and so we strive for perfection. But it does not end there. At Kaba Biotech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology.
Yes, true.
Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with
with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good Initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of AfricaBP emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When AfricaBP officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, AfricaBP became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At AfricaBP, we use a variety of Zymo kits for DNA or RNA isolation, as they're not only simple and reliable, but effective and efficient, making your experiments hassle-free.
AfricaBP has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. AfricaBP has promoted research in the region by providing quality products to researchers. To many more years in AfricaBP, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At Ingaba Biotech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good Initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of AfricaBP emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When AfricaBP officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, AfricaBP became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At AfricaBP, we use a variety of Zymo kits for DNA or RNA isolation, as they are not only simple and reliable, but effective and efficient, making your experiments hassle-free.
AfricaBP has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. AfricaBP has promoted research in the region by providing quality products to researchers. To many more years in AfricaBP, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At AfricaBP BioTech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DMB-Seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good Initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of AfricaBP emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When AfricaBP officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, AfricaBP became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At AfricaBP, we use a variety of Zymer kits for DNA or RNA isolation, as they are not only simple and reliable, but effective and efficient, making your experiments hassle-free.
AfricaBP has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. AfricaBP has promoted research in the region by providing quality products to researchers. To many more years in AfricaBP, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At AfricaBP, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology.
Welcome to ILRI and welcome to the 4th Africa BioGenome Project workshop. To those who are physically in the room, welcome to our beautiful campus here at ILRI. To those joining us online, welcome to this remarkable event. This is one of a series of workshops that have been organized by the Africa BioGenome Project. The first one was in South Africa at the University of UNISA. The second one was in North Africa in Morocco. And we had a third one in West Africa. The Africa BioGenome Project is a project or a community that seeks to bring together scientists, to bring together researchers and build the capacity of researchers on the continent who have the skills and capabilities for addressing key challenges in biodiversity conservation and also sustainable use. With all the global challenges facing the planet, it is becoming very clear that preserving or conserving biodiversity will be very key, and it will require scientists or people who have the knowledge and know-how to be able to manipulate genomes and understand them. And that is where the Africa BioGenome Project comes in. We're trying to harness the power of collaboration. We're trying to also bring together a community, a very powerful community in terms of the human capacity as well as infrastructure on the continent for people who can address and tackle these challenges in biodiversity loss. So welcome. I'd like to acknowledge the team that has worked behind tirelessly to bring this event together. It has been a very a big way of demonstrating team effort, combining people who are in the UK, people who are here on the continent, here in East Africa, and all our partners across the continent. So we would really like to we hope that for the next 2 days and also the next 3 days during the practical workshops, you'll be able to learn. You'll be also be able to have people that you can work with so that this work or this important work of preserving and conserving biodiversity can continue. We're hoping that through these workshops or through these training workshops, we can all learn from each other. We can all build this community of Africa biogenomes and be able to do the sequencing, not only the sequencing, but we also be able to know the bioinformatics and all the support that is required to be able to manipulate our genomes. So I would like to welcome you once again and also thank our sponsors and our exhibitors who have contributed immensely, not only through their knowledge, but also financially to make an event as big as this possible. And to the students, to the researchers, to the academics, and all the partners and stakeholders that form the AfricaBP community, I would like to welcome you and hope that we can pave the way of the next generation of scientists who have the skills and capabilities to be able to address challenges associated with biodiversity loss. So welcome to Nairobi, welcome to IRI, and welcome to this workshop. To hear more about the Africa BioGenome Project, what we have accomplished so far, I would like to introduce Prof. Anne Muigai from the University of Jomo Kenyatta University, who has been very instrumental. I think most of you or people who are here in this community know she has been very, very instrumental in championing the Africa BioGenome, and also bringing people together so that we can work together and harness the power of collaboration. So with that, welcome, Prof. Anne.
So thank you very much, Catherine, and thank you for the hard work that you have put in to make this workshop commence successfully. My name is Professor Anne Mwigai. I'm a professor of genetics, a professor of Jomo Kenyatta University of Agriculture and Technology, but currently working as the Deputy Vice Chancellor at National Defense University, Kenya, which is based in Nakuru. The African BioGenome Project, I'm sure most of you know about it. And at the end of these 2 days, we are going to encourage all of us who are here physically and those who are also present online to be able to register and join this great movement that we have begun. So what is the African BioGenome Project? The African BioGenome Project is a project that was established in 2021. 2 years before that, from as early as 2019, consultations were happening to be able to find out what can we as scientists, African scientists based here on the African continent, and those who are also based in diaspora, be able to do concerning conservation of our biodiversity and bringing genomics and bioinformatics closer to the people. So one of the greatest things that we have observed is that when sequencing efforts were beginning, most of the sequencing efforts were being undertaken outside the continent. And the effect of that was that the capacity that was being developed was mainly being developed outside. And any technological advancements that were being made in terms of reagents, in terms of equipment, in terms of everything was actually being left overseas. So what happens was that any African who was being trained and being developed and being capacity built in terms of these technologies found it difficult to come back home, because there was no institution, or there were very, very few opportunities to absorb that kind of a capacity, which was very modern and very state-of-the-art. And that sort of like facilitated the establishment of a very, very strong core of African scientists who were based in diaspora. But the other side of the coin was that it was difficult. It was difficult for these technologies and these advancements to continue happening at the same pace here on the continent. And this is the conversation we want to bring to the table. How can we all get involved, and how can we build, if it is infrastructure that is not available on the African continent, how can we bring this infrastructure here so that we can be able to build those African and public, national, international institutions to be able to absorb and to be able to have those technologies and capacity we're talking about. If it is the people, the infrastructure, the human resource, then if we have the infrastructure, we can be able to talk about what skills do these people need for us to be able to retain this person here. Because when we have a significant number of technologists, genomicists, bioinformaticians, equipment developers on the continent, then we can begin to say we can sequence back home. And this is what the core of African BioGenome Project is, to be able to use the capacity which is present, whether it is not on the continent, it is there, to be able to ensure that the genomics capacity building, the bioinformatics capacity building is present, so that now we ourselves as Africans and as African institutions can play our part when it comes to conservation of biodiversity. It will be very, very difficult to do that if we have to send samples to Korea. It will be very, very difficult to do that if we have to ship samples to South America to be able to do that, because that is where that specific equipment is being found. So we want to do that. And we published a paper in Nature putting out our goals, which basically are to ensure that we are at the core of any new initiative that is coming to sequence. So we want to coordinate. So you who is working on some bacteria, or you're working on fish, or you're working on cattle, you're working in plants, will be able to come to us and we coordinate the sequencing. Because again, if we don't have coordinated efforts towards the sequencing efforts, then we will not have whole genome sequencing. You realize that many plants, many animals have been sequenced and resequenced because you're doing short reads, you're doing, just specific genes, you're doing just segments of that particular genome. And this is another challenge that we have faced, that a lot of resources have gone into sequencing efforts, but perhaps there's very little to show for it. So if African BioGenome can come and help coordinate that effort, so whatever it is that you are interested in, whatever it is that you are sequencing is able to be sequenced once, then at least we will have a pool of data from which we can begin from. We also want to be advising any new sequencing effort that is happening to ensure that whatever it is that you're working on, it only happens once. And then the other challenge that we have also seen is that deployment of genomic data is usually outside the continent. So you go out, you sequence whatever it is, and it is stored in databases which are not accessible to us now when we come back home. So that is what we also want to do, to build capacity and infrastructure within institutions that are based in Africa so that we can be able to store this data here. So that 5 years down the road, somebody will be able to say that, oh, I remember that this livestock species was sequenced, or I remember that this tree was sequenced, and the data is in a database, maybe in a national institution in Jomo Kenyatta, in ILRI, in wherever it is, but it's actually based on the African continent. So these are our objectives. And it is a very, very ambitious project to be able to say that you want to sequence 100,000 genomes in 10 years. And the sequencing effort has begun. It has begun. We already have our genome sequencing here, and we will have some of our technology providers who are partners of African BioGenome Project being able to show us. The other downside of it is, as the sequencing effort has happened, we realized that we are going to be generating about 203,000 gigabases of DNA sequence data. Who is going to analyze all this? Who is going to be able to annotate this? Are we going to now turn back to, some development partners that we have partnered with to say that we now need assistance to be able to analyze and annotate this data? And this is exactly now why we needed to establish the African BioGenome Open Institute, because through this institute, we are going to do hands-on training when it comes to genomics, hands-on training in bioinformatics, to be able to anticipate the required capacity that we will need to be able to actually analyze that particular data. And I'm so happy that the uptake towards our conferences has been absolutely tremendous. You will see in the program that we will share that in this, which is our fourth project, up to date, we will be able to see how many of us will be able to attend this conference. But up to date, up to the counting the 3 workshops that have already been held, we've been able to train 4,000 Africans, 4,000 Africans. And over 300 of these have gone on to be trained on hands-on lab bioinformatics, genomics training. So it has begun, and we've been able to do this in 12 months. So we are very, very optimistic that by the time we are getting to the 2.5-year point of our project, we will have already a significant number of us Africans on the ground who are able to analyze, to annotate, and to be able to say what this genomic data means. But then you have to ask yourself, okay, so why? And the whys are that data is the next, development goal for everybody. The data is the one that will answer questions with regard to how will we be able to address climate change? How will we be able to address food security? How will we be able to mitigate the next disaster that will come? If we are able to harness the power of data, this data will already hold the answers for us. This is not the first pandemic that has happened in history, but this is perhaps the first pandemic where a lot of data has been calculated, and therefore it will be able to mitigate against the next pandemic. This is not the first environmental catastrophe for the globe. It is not. This is the one that we are experiencing now that we are here. And now we will have the data to help us mitigate against those effects. So we'll be able to harness genes for adaptability, for high production, all those things that we've been able to talk about over the last 10 years. Now we can be able to harness data for it. And this is the goal. And we are asking African institutions to partner with us to be able to play their part in being able to protect and conserve and preserve our African continent for the next future. So join us. You can join as an individual, you can join as a project, you can join as an institution, you can have institutional partnerships. And we are open to all these partnerships because it is this project, unlike many others that have happened where they're closed and they can have a minimum number, it is open because you are the one who has the questions that we will be able to utilize on the ground to be able to answer. And that is what the African BioGenome Project is about. Later on today, we will be able to share some slides on this, and we will be able to address this aspect a bit further. But now I would like to take this opportunity. It is my distinguished to be able to introduce Professor Apollinaire Jikeng. Professor Research Institute. He's one of the founders, together with Dr. Thangod, whom you will see in the project, the founders of this project, and would be very, very interested in hearing exactly how did this idea come on board? How did you what made you conceptualize this particular concept? The International Livestock Research Institute is an institutional partner of the African BioGenome Project, and is the host of this particular project. We want to thank ILRI for partnering with us, for believing in the vision of the African BioGenome. I am their servant. I work for the African BioGenome at the request of all the partners, and for also availing your staff to be able to help us and partner with us at no charge to be able to bring this great vision forward. Professor, thank you very much and welcome to the forum.
Good morning, everyone. My apologies, I'm running slightly late. The week that just ended has been extremely busy for things happening here and also at COP28, the Climate Change Summit. So it gives me great pleasure to welcome you here, and we're really honored that you could make time to be with us, and greetings to those online. And I stand here really in celebration because there are a few things that we've learned. Professor Mugai mentioned there are a few things that we've learned when this whole process started. One is, Oliver, good morning. One is when you have a good idea, stick to it. Even if you take it for funding to a funding agency and they reject it, don't drop the idea, keep it up. Secondly, when you have a good idea, partner with the right people. So this idea, I should say, didn't come from me. It came from Thangod. I was at the time at the University of Edinburgh. He wanted to collaborate with us. And he had this idea that we could sequence and we could do bioinformatics, we could do all kinds of things to accelerate agriculture in Africa, biodiversity preservation and things like that. We put a lot of effort into the proposal, but UKRI, UK Research and Innovation Funding Agency, through competitive process, our grant wasn't accepted. I told Thangod, this is a very good idea. Let's get to the right people, the people who we believe can help us move this idea. Prof. Mugai here is one of those. Isidore Waga, who was at the time a fellow in my group, the Roslin Institute, is one of those. Catherine Ziomo here joined the pack, Christian Kiambo, and many others. Just to cite people in this room here, and then we turn to institutions that do the sequencing like Oliver. We had done previous business and we trusted each other and say, you know, there's something we can do here. And we got the idea on the road. And for those who have interacted with, thank God, he's full of energy and he's very resilient and stuff like that. We started with our first online conference chaired by Prof. Mugai. Catherine played a critical role there, and many others. We took the show to the road, so to speak. And the idea kept gaining momentum. Why did that get the idea got so much momentum? For two main reasons. One, it was a good idea with the right people. Secondly, the gap. We need to do this in Africa. We're probably the only part of the world with so much biodiversity. And it's so important that we understand that biodiversity, we characterize it, we think about ways of how we can apply it. And at the onset of this project, we talked about sequencing, not just sequencing for the sake of it, but sequencing to accelerate so many processes, including plant breeding, animal breeding, and all kinds of things. So we are here today. I think the idea stands strong, even if any of us early in the room is no longer interested, no longer available, this idea will continue. And you have joined the bandwagon. Maybe for some of you, you are attending this engagement under AfricaBP for the first time. For many, you're returning and stuff like that, but we are in this together. I think it's important for us to see, you know, the challenges are so big, massive, that one institution cannot do it. One organization, one country cannot do it. We have to come together and bring multidisciplinary teams. Some will be social scientists, some will be in ethics and law, others will be technology and stuff like that. And maybe the private sector on how to commercialize some of the innovations that will come out of this project. So Prof. Mugai mentioned a number that, you know, just got me really even more excited, you know, training 4,000 people. Not all 4,000 people are going to focus on this. Some will be appointed ministers and directors and will no longer have time to do this. But from such a large number, we'll retain a sizable number to continue to do this, to drive things through our own universities and research institutions and stuff like that. So the story of AfricaBP is a story of, you know, homegrown research, trying to, you know, identify some of the opportunities and challenges that we face and see how as scientists or the scientific community, we can come together, you know, to try and harness those. So it gives me, again, pleasure to be hosting you here today. This started, I wasn't at this institution. I came back here 8 months ago to lead ILRI. Unfortunately, when you're building a bridge, build as if you'll come back to cross it. You know, when I had invited Catherine, Christian, and colleagues here to join this, I didn't even know that I'll end up here, even hosting you. So really, really important that in our career, when you're bringing collaborators, think about collaborating in the long haul. And indeed, this is a great organization. I did my PhD here. This is my third time coming back here. I came here as a PhD student, then as a senior scientist, then now as Director General. And, you know, I'm standing here just to commit from our institution that we'll do this together. We're in need of it. You know, for those who will take the visit of our facilities, you'll see an excellent genomics platform and people who are here linked to bioinformatics and the whole data management and data analysis that we have here. And we would like to continue to do this with you. So this week is going to be very busy. We had similar engagements in South Africa and things like that. But at the end of this week, become an ambassador of AfricaBP. You know, use this as a framework to think about your own research, to think about how you can shape things wherever you are and the science that you like to do moving forward. And we engage with others. This is a simply put, a community of practice. Community of people who are concerned about biodiversity in Africa and how we could use it, you know, to address some of the challenges that we are facing. providing means for resilience to our communities that are even more vulnerable at the moment will come from, some of the genetic diversity that we have across various kingdoms in Africa, whether it's in farm animals and crops. I think this is that's the commitment and some of the opportunities that we can create for our communities. So enjoy your time here at ILRI. Take time to, I'm sure many of you are meeting here face to face for the first time. Build the relationships that will help you become trusted collaborators. And that will really help us keep the show of AfricaBP on the road. On this, I want to thank the funders. When we started this, I had to use some of my research money, to get things going. I want to thank the Bill and Melinda Gates Foundation for accepting that we could use this and UKRI to do that. More importantly, the University of Edinburgh for allowing us to, to drive this. Of course, the university where Prof. Muigai was, committing yourself to be co-chair of this and being always on the call, comes at a cost. You're not doing certain things for which you're actually paid to do. We thank your organization for doing that. We thank the International Livestock Research Institute. We also thank Inkaba and many of the technology companies that joined things earlier. And in individual, we'll keep the show on the road, and anything that I can do personally and from the institution standpoint to accelerate this, I will not hesitate. Thank you so much.
Let's give Professor Apollinaire a round of applause. Not only was he a believer of the project, but he's also our advisor. He's our to-go-to person when we are bringing out initiatives, and he will always say, this one is dead on arrival, but this one, go for it. And he's always there asking, and what happened to that idea that I told you was good, because maybe you're getting overwhelmed by, office work. And thank you for keeping us going, and for your years of experience really has been able to give us the advice that we needed. And without that energy, we would not be here. We also have to thank Dr. Thangod Ebeneza, an African Nigerian who is all the way in the UK, but has been the driving force and the energy, the person with the energy behind the engine to drive this project forward. His ideas and his resilience has gotten us this far. We would like to take a photo, but before we do that, we would like to recognize the nations that are here, the African nations, because this is an African project, and we do understand that we will have people from all over. So, and that's why we went regional. So we had a workshop like Dr. Catherine has mentioned in Western Africa to be able to facilitate access. One of the things at the core of our hearts as African BioGenome Project is to bring the technology home, to make it accessible to people wherever they are. So this is an East and Central African workshop, and we would like to recognize the people from the different regions of East and Central Africa. So do we have people from Ethiopia? Yes, please stand up and let's give you a round of applause for traveling all the way. Thank you very much. Thank you, recognize you. Anyone else from north of the countries north of Kenya, Eritrea? Do we have Somalia, Eritrea? Burundi, welcome, welcome. Welcome and thank you for traveling. Yes. DRC, so we have Central Africa physically present. Central African Republic, welcome. From Congo, we have people from Congo Republic. Any of our neighbors, Uganda? Yes. Uganda is in the house. Anyone from Tanzania? We need one person from Tanzania. So I'm going to pull somebody from your offices. And that means the whole of East Africa is physically represented. I'm sure online we have very, very many more people. So what we will do now is that we're going to go to the front of the building, take a photograph with Prof and all of us to be able to remember this day. And then we will take a short coffee break. I know some of you are here very early. We'll take coffee and then we'll proceed with our program. So those of you who are online, we can return here at 10:00 hours Nairobi time in 30 minutes. Thank you all. And we can just find our way out through this exit or that one. And then let's meet at the front of the building. Thank you very much.
You're part of the conference.
Stop sharing your screen. Could you please stop sharing your screen? Otherwise, could you please stop sharing your screen, please? Hello. Hi, Anne.
So good morning and welcome back. I would like now to take us through the vision of African BioGenome Project, especially with regard to the Open Institute for Genomics and Bioinformatics. In my opening remarks and during the welcoming ceremony, we did mention a little bit about this, and I just want to take us through a few slides that will be able to take us through this further. So the African BioGenome Project has 3 goals: to coordinate all non-human genome sequencing initiatives. And the reason behind this is because we recognize there are already human genome sequencing initiatives in Africa. There's no need to duplicate this. So anything that is non-human genome related, we are going to be there to coordinate it and also act as a forum for all sequencing and bioinformatics initiatives that are not in the non-human space. But having said this, we are collaborating very, very closely because you realize that post-sequencing, the analytics, the bioinformatics is very similar, including with the human genome space. We also want to initiate, develop, and support any initiative that will speak towards the sequencing and bioinformatics towards the non-human genome sequencing efforts, with a goal of sequencing over 100,000 genomes in the next 10 years. And then we want to ensure that this sequencing data is stored at least on the African continent, or at least accessible for post-sequencing efforts that will be there. So this project will cover all eukaryotic lineages. We envisage working with vertebrates, we work with invertebrates. We also want to work with eukaryotic genomes, bacterial eukaryotic genomes. We think that there are other people who are in the space of the human genome sequencing efforts, and there are others who are talking about viruses and disease vectors and things like that. So we don't want to duplicate again. We want to work in this particular area where we will talk about these categories of species. What do we envisage? We have seen very, very strong collaborations between African institutions and non-African institutions, mainly those who are based in Europe, in America, and overseas, out of Africa. But within the continent, even within your country, if I talk about the collaborations within our country, Kenya, we are very, very weak. And I think by strengthening these African institutions, we will be able to even leverage more on whatever funding we want to get, whatever collaborations we want to get. So we want to build and increase collaborations between institutions that are regional and also within the institutions that are within countries. And this will be able to help us deploy genomic resources in a better fashion. We also want to inform and drive policy so that some of the things that we will observe from the scientific point, we are able to inform any of the policymakers that come on board. I talked about the inauguration of AfricaBP. It was inaugurated in September 2020, in June 2021. That is when the first group of people came and said, you know, we have launched the African BioGenome Project. But the project was already in existence in various forms from 2019. During the 2019 to 2021 phase, it was a conceptualization, bringing people on board, bringing ideas on board. But we had our inaugural meeting in June 2021, and between June 2021 and September 2021, we launched the pilot project. So we moved on up to March 2022, where consultations were beginning. We began talking to some of the policymakers in AU, in NEPAD. We formed regional coordinators. We also were able to speak to funders. And basically, we were selling our dream, selling our goal, selling our vision of African BioGenome Project. And then in March 2022, we launched the pilot project. And this pilot project will happen in 3 phases. The first 2 years of the pilot project, between April 2022 and April 2024, March 2024, which is just around the corner, It was actually the establishment of the pilot project. And in this particular phase, we were envisaging beginning the sequencing efforts, which they have already begun. I'm happy to say, as we begin to close this phase and move on to the next, we have been able to standardize, optimize, and be able to identify where the species we want to sequence are located. From April 2022, for the next 4 years up to March 2028, this will be our first phase. Because we've done the groundwork and we've been able to optimize all our processes, this will see us move into full large-scale production, and we envisage sequencing over 2,500 genomes in this particular area. And we've categorized them. You know, we have plants, we have invertebrates, amphibians, reptiles, mammals. How will we get these organisms? It is from you. If you're sequencing frogs and you want, to answer a particular question, come partner with us. And then together we will be able to do together, we will get the funding together. Not that we don't have the funding, but together with us, with your idea, we will be able to commence the sequencing effort, and you'll go on and answer the research questions that you've already developed from your project. So these species are species that speak to us. Either they're endangered, or they will be a source of answering questions on climate change, or they will they have genes of interest that will answer questions on food security. Their conservation efforts, maybe like now we're conserving indigenous livestock in Africa. This is what we want. We want to be able to address questions, but also look at species that are specifically related to Africa in one way or another. And then after the first phase, the next 4 years will be phase 2, where we will now be looking to complete these sequencing phases, reassess what needs to happen, and then post that, what happens after March 2023, now we'll be doing whole high throughput sequencing of the genomes that will be identified. We have 4 programs to address the AfricaBP grant challenges. The first one is the AfricaBP genome conservation of nature. This one is focusing mainly on sequencing efforts directed towards live animals, and specifically any livestock or animal species. It's being coordinated by University of South Africa. Funding has been obtained from the Rockefeller Foundation. We have our partners, PacBio, who are here with us, who have partnered and commenced the sequencing efforts, and also the South African Biodiversity Institute, who have also provided the material. The other grand challenge is the genomes for grassroots conservation. And in this particular one, we are targeting plants, all plant species that are endemic and of interest to Africa. And here again, our partners in this are University of South Africa, the Beijing Genomic Institute, who we have partnered with because they have a project towards sequencing some of the species, and some of them are endemic to Africa. The South African Medical Research Council, the University of Cape Town, and the South African National Biodiversity Institute. The third grand challenge is the AfricaBP Community of Practice Roundtable on Biodiversity Genomics. This one is to be able to enable Africa BioGenome Project fully embrace and work within the access and benefit sharing post 2022 biodiversity framework. So whatever we do, we want to follow the laws and the legislation that has been put forward, the Nagoya Protocol, the ABS, and we want to understand what it means for us, and we want to capacity build. We have realized that there are different laws in different regions, and we need to be able to have a conversation of what does this mean for us? How can we harmonize, and how can we be able to bring this forward? And then the fourth one is what we are concerned with today, the African Open Institute for Genomics and Bioinformatics, which is going to be our training arm. This is a so-called academy where we will conduct workshops, capacity building, and talk about access, bringing access of genomics and bioinformatics closer to people. So we will generate an estimated 203,000 gigabases of DNA sequences. The aim is to analyze this on the continent, and the gaps are the people to be able to analyze this. And this is what the African Open Institute is addressing, starting from the basic level all the way, hopefully, to advanced level where we'll be able to have the hands and the people who will be able to analyze these genomes on the continent. As it was mentioned by Catherine earlier, this is the 4th workshop that we have held in 2023. The last one was in South Africa. We had another one in Morocco in October, and we had one in Western Africa at the beginning of the year in February. And basically, we want to go where you are and be able to bring this training. And then, you see, we don't want to have like a top-down approach. We want to be able to understand what are the gaps, what are the needs, and what do you need? What do you need to be capacity built on? And that is where we will come in as African BioGenome Project. So these workshops are openly accessible. Not only are they physical, but they're also online to be able to enhance accessibility. And we have held them across the board. And again, we want to partner with African institutions. So we hope that we can have satellite workshops in different institutions, again, with an aim of making this knowledge accessible to many, many more people. We have a website, the African BioGenome Project. I want to encourage you all to make a visit and see what we are speaking about. And thank you very much. And before we open the floor for questions, which we will have at the end of this, I would like to invite Dr. Thank God Ebenezer, who is online, to make a presentation and perhaps tell us where our sequencing efforts have reached and what our hope and future looks like. Dr. Thank God, if you're online, you can go ahead. Thank you.
Thank you very much, Professor Anne Mugai. And thanks everyone for coming to the 4th regional workshop of the African BioGenome Project. And I'm really, really pleased to see hundreds of scientists attending both online and in person. So Professor Anne has said quite a lot about the project. So I'm just going to maybe say other, support what she said so far. Before that, I would like to thank Professor Apolline Jean Keng. So I don't know if he's still in the room, but perhaps he has also maybe gone to somewhere else. I would like to thank him for his support for the project in terms of counsel and mentorship. And if it weren't for him, it would have been a bit challenging, in terms of the decision to continue with AfricaBP. It would have gone a bit differently. So today, by the end of the year, we would have trained on hands-on practicals, genomics, bioinformatics, and molecular biology. Would have trained up to 360 African scientists, and would have gathered and built awareness and training for around up to 4,000. So that wouldn't have particularly happened. And also, in addition to other things we've done. So, for instance, we've sequenced over a dozen African species on the ground in Africa. And the idea is to actually analyze these genomes on the ground. So from next year, we'll be having more momentum that we go into that in terms of the assembly. When I came up with the idea for sequencing, on the ground, mainly large scale sequencing, one of the challenge has been, will Africa be able to do this? And I actually encouraged everyone to actually sequence on the ground. So over some time, I realized that this is possible. You will just have to actually put in everything we've got into it. So the next challenge now has been the analysis. So we will need people who will be able to analyze this data on the ground, and the people will be attached to, for instance, academic institutions, research centers, and other places in Africa. So, but at the heart of AfricaBP is capacity building, knowledge exchange, project-based capacity building. And as Professor Anne Mugai mentioned, this is the platform or the program by which we do this. We started in Nigeria, in West Africa, and then moved to South Africa, Southern Africa, and then moved to Morocco, North Africa, and then moved to, we're here now in Nairobi, Kenya. And two things have actually come out from this workshop. The first mainly has been 2 fellowships, or perhaps 1 fellowship which we've launched, and that will see around 30 to 35 African scientists trained in terms of comprehensive training. They will spend about a month in a world-class laboratory in Morocco to actually sequence African species. And the idea is to have more and more of this project-based training, whereby scientists will, spend some time in a genome center in Africa and then sequence some species. So we're also hoping that over the next coming weeks, we'll be launching the second fellowship, and that will see us build leaders in biodiversity genomics across the continent. And that will focus on nominations from participating AfricaBP institutions, particularly. So I also just want to just share the slide on where we are in terms of the participating countries, and just to tell us that we've actually had some very wild coverage. So I'm just gonna see if I can share my screen. Mainly looking at where people have applied to. So this is just, can everyone see my screen, please? So this kind of shows where where all of the registered attendees for the 2023 workshop have come from, where we have at least 1 participant. And as you can see here, we only have we covered the whole of the continent so far. And in total, we had 75 countries across the world. And from Africa, of the 55 African countries, we had around 53 who are actually represented in all of the workshops, essentially. And as Professor Apollonia mentioned earlier, of this number, we expect that a few of them will actually carry the message and the vision of the AfricaBP. And in the next coming months, also we'll be making a proposal for the continent. And that proposal is one of the things I feel will help in terms of maximizing the benefit. And that is for the continent to be able to have its own infrastructure for storage of genomics data. So one of the things is going to be mainly focused on biodiversity genomics data, and for food and agriculture, and also for biodiversity. So it's going to be focused on sequence data for the continent. And we're also putting all of this in a paper, which hopefully over the next coming months will be ready for submission as well. So with this, I would like to thank all of us. And if anyone do have any interest in order to support the AfricaBP Fellowship Program, mainly on the continent, please do reach out to Catherine or Anne. Thank you so much.
So thank you very much, Dr. Thangod. Dr. Thangod, I hope you took a good look at him. He's the brains behind this brilliant idea of African BioGenome Project. And I must thank him for pushing me to accept to become the chair, because I felt, a bit overwhelmed by the task, and I'm so happy that I made that decision to join us. So you have heard about the fellowships, because it's not enough just for us to have these workshops. We have to think about the next step. How are we going to be able to go in depth into the real, capacity building in terms of training and genomics? And that is why the fellowships have been held. We are very, very fortunate to have partners who have come on board and have partnered with us and have provided the funding. And what will happen, we want it to be a very open process, and the institutions that are partners of African BioGenome Project will be able to nominate suitable candidates. So please follow us. We have our Twitter handles. If you go onto X, I think it's called now, do a search for African BioGenome Project, go onto LinkedIn. You'll find us there also as African BioGenome Project. We are also on Instagram. Yeah, sorry. We are also on Instagram, and you will be able to see the announcement. So if your institution is a partner of African BioGenome Project, they will be able to nominate candidates, and through a competitive process, we'll be able to have between 30 to 35 African scientists spending a month in Morocco. We are also partnering with institutions in the US and in the Europe, where these fellows, the fellows, African BioGenome fellows, will be able to spend another month overseas in one of these institutions. So just follow us and we'll be able to see on our pages when that announcement will come out, and make sure that your institution is a partner, because these are the places we'll be able to consider. So I'd like to now move on with the program. And our next speaker is Fatou Badian. Sorry if I've pronounced it wrong. She's a Senior Program Officer in Science, Innovation, Translation, and Entrepreneurship at Science for Africa Foundation. Fatou is a PhD holder, currently the Senior Program Officer at SFA. SFA is our institutional anchoring, it's our anchor institution. They're the ones who are providing the leadership and the anchor institutions for us. When she was a graduate student, Dr. Fatou was recognized by Henry J. Legislative Fellowships in the Eagleton Institute of Politics. With this fellowship, she worked at the State House on a variety of projects, and this was in Trenton, New Jersey. She's a graduate of Rutgers, which is a renowned university in the US, and she regularly presents at career development workshops, and she mentors many graduate and postdocs. So Dr. Fatou has also lectured at the Graduate School of University of Delaware, and during her free time, she hosts a podcast, and it's very interesting for you to know that she's the chair of the African BioGenome Communications and Public Affairs Subcommittee. And thank you very much, Fatou, and the floor is yours. Thank you. Let's give her a round of applause as she comes up.
Am I able to control or do I? Okay, great. Okay, great. Thank you, everyone. And thank you, Anne, for that lovely introduction. And thank you also, thank God. I'm sorry I couldn't see you in person today, but I feel like we spent a lot of time together virtually. As was said, my name is Fatou Badian, and I am a Senior Program Officer with the Science for Africa Foundation. And today I will be speaking with you about the science strategy and funding landscape for biodiversity genomics across Africa. All right, so to begin, just to give a brief background on the Science for Africa Foundation, for those who are unfamiliar, we are a Pan-African nonprofit public charity organization, and we were created to strengthen, support, and promote science and innovation across Africa. So we believe that science and innovation are central to delivering sustainable development for our continent. Our mission is to catalyze and strengthen Africa's science and innovation ecosystems, as well as to respond to sustainable development challenges and positively impact lives. And all of this is driven by our mission to be a leader in strengthening African science for a better future globally. So when we think about the role of the Science for Africa Foundation, and we are looking at Africa's genomics context, we're looking at this in sort of two main streams. So we understand that currently, there's a big gap in the understanding of disease etiology in diverse African populations. And this is not only with regards to humans and the impacts on human health, but also with regards to agriculture. So if we look at a more concrete example, we see that we have over 3,000 ethnicities in Africa, and there's a big inequality in how this these ethnicities and this diversity is represented with regards to genomics data and how that would apply for human health. And the same is also true when we think of agriculture and looking at orphan crops, as well as looking at the impacts of climate change on crop resilience, and also just advancing agricultural technologies in general. So as the Science for Africa Foundation, these are some of the examples that we have over the past few years where we've leveraged genomics to reach some of our goals. So we've used genomics to track the evolution of the COVID-19 virus across the continent to better understand the evolving pandemic. We've also supported the H3 Africa initiative, and I'll speak to that a little bit more. We also are looking at new partners and thinking about the future and looking at the EU-Africa Precision Medicine Collaboration. We also are looking to partner with industry and different ways that we can really advance genomics across the continent. So there is a missing link that we see when we think about genomics in Africa, and I explained that just previously, but what does all of this mean? So we need a better understanding of disease etiology, not just with regards to human health, but also with regards to agriculture. And that will lead to advancements in early detection and diagnosis, as well as advancements in agricultural technologies. And all of this is really tied into the One Health approach, in understanding how our human health is also tied into our agricultural advancements. So where will the solution come from when we're thinking about this gap? So going back to the work of the Science for Africa Foundation, we have several areas of science focus that we leverage in order to drive some of the opportunities and solutions for some of these gaps that we see. So we focus on discovery and basic sciences, translational sciences, and implementation, thank you, and policy sciences. And when we think about, discovery and basic sciences, that's really where I see the role of the African BioGenome Project. And as was mentioned previously by Anne, I chair the communications work with a really outstanding and phenomenal team that is able to communicate all of the advancements that AfricaBP is able to create with regards to advancing genomics. And through that communications strategy, we're also able to find, new partners, new collaborators, as well as just present our work to the larger scientific community. Under our areas of scientific focus, we also focus on 3 thematic areas. So health, climate and environment, and agriculture. With regards to health, we are supporting programs to reduce the health burden and to really promote work that's at the intersection of health, food, and nutrition, energy, climate change, environment, political economy, and public policy. And then with regards to climate and environment, we are promoting African scientific leadership with regards to the climate and environment space so that we can make sure that there is accessible evidence, especially for regional governments, to promote the vision of Africa with regards to climate change in these larger global discussions. And then with regards to agriculture, we leverage science and innovation to support researchers in uncovering innovative techniques to really optimize agricultural output, as well as resilience and adaptation. So our core business models is kind of how do we do the work to meet these goals? So we organize convenings to bring together multiple people, not only researchers, but also funders, policymakers, and even the media when we think along the lines of science communication. We design programs bringing together a lot of really smart people to think about how can we address these problems, specifically designing programs to support science, translation, and innovation across the continent. With regards to funding, we really advocate and speak on behalf of our scientists to guide funders on where it is best for them to invest their resources. And then we also have oversight to ensure that the money that is being brought in and is delivered to programs is spent effectively and efficiently and for impact. So from science to impact is our main slogan, and we are able to really create impact in our work through these different strategic objectives. So we support science leadership and career development, very similarly to the program that Thank God mentioned with regards to fellowships. We also support science, innovation, translation, and entrepreneurship, not only thinking about the science that's occurring in the lab, but how all of that can be translated to impacts in the marketplace or the broader community. And we also believe in strengthening the science ecosystem. So again, understanding that all of the research that takes place is not in a vacuum, but we also need to think about what are the other supportive mechanisms that need to be in place for researchers to deliver top quality, quantity, and impactful research. So that was kind of the big background on the Science for Africa Foundation. So now I'm going to go into highlighting a little bit more of our work that has supported genomics across Africa. So when we think about some of our priority areas for genomics research, all of this is really part of a pipeline. So we want to make sure that we are aligning with global priorities and strategies, right? None of this is occurring in a vacuum. And there are larger global partners that are all playing a role in advancing genomics. And we know that there's been a huge gap with regards to the representation of data coming from Africa with regards to some of these broader conversations. So we want to make sure that the data that is presented here is also included in a lot of those global priorities so that we can have advancements for everyone. We're also interested in supporting evolutionary biology and biodiversity loss, understanding how, with regards to agriculture, a better understanding of the genomics of plants will lead to advancements in this as well, especially when we consider the impacts of climate change and what that means for agriculture. We want to make sure to have coalitions in genetics and genomics. So again, understanding that it's not only one organization or one institution that is really going to drive all of the change that we see, but understanding how we can use networks and collaborations and partnerships to really advance our goals. And all of this feeds into the One Health approach and how environment, climate, food systems, and health are all interrelated. So when we think about, our main focus areas for advancing genomics in Africa, we also want to think about what are some of the key partnerships that we're interested in, looking not only in terms of partnerships with regards to, who are some of the thought leaders that we can work with in advancing our work, but also with regards to funding. So we look at governments, Pan-African organizations, as well as pharma and biotech. And so when we think about governments, some example initiatives are, to advocate for personalized medicine and genetic services, and understanding how governments can develop policies to have that as part of the public health infrastructure to really create impacts for communities. When we think about Pan-African organizations, that's not only Africa CDC and genomics institutions, also H3 Africa Lab and Networks, any organizations that are interested in population studies, and even industry. And industry points to pharma and biotech and really increasing the interest in scaling up a lot of the translational genomics work that we're doing in Africa, and making sure that we have input from these industries as well. So now I'm going to go into a little bit more on what is a concrete example of genomics research that we have supported and initiatives that we have supported, and sort of what that means for the future of this work. So I mentioned H3 Africa, which is one of the initiatives that we've supported over the past 10 years. And this has been a really strong inter and intra-African as well as global collaboration. And this works off of a successful hub and spoke model where we take strongly resourced institutions and pair them with other regional or local institutions so that we really have buy-in from a lot of different stakeholders. And all of this leads to advancements for future projects. So we know that there is enormous potential from this work. And we have seen that with H3 Africa and what they've been able to accomplish. So one of the major benchmarks is through whole genome sequencing. They've been able to sequence about 426 continental Africans, representing over 50 ethno-linguistic groups. And this has led to the discovery of some pretty novel variants, such as genes involved in viral immunity, DNA repair, and metabolism. One second. And so now at this stage of the work that we have done with H3 Africa, we're also at a pivotal question. You know, how can we take this genomics work that has been accomplished and really tie that to the next stage? So tie that to linkages in phenotype. And if we're able to do that, you know, then we can also layer on top of that demography, behavior, environment, and other important phenotypic measures that would then give us a broader understanding of that data that was generated. And then if we look even further, you know, we can pair that with longitudinal cohort studies where over time we're able to trace, you know, the different genomic outputs from different studies. And that can really lead to strong data collection for potential early interventions to reduce healthcare costs. So when we're thinking about also ways to get government involvement in this work. But there are some barriers, you know, that we have to consider. We have low representation, as I mentioned before, of Africans in wide-ranging GWAS studies. You know, so if we look here at the statistic, about 86% of GWAS studies represent European ancestry, and that's a really stark gap. So how can we address some of that? Well, we need to really invest in infrastructure, and this can include anything along the lines of genomic centers of excellence, as well as looking at one of our programs, which is the Deltas program that again focuses on the hub and spoke model, which has been a very successful model that we've used in utilizing collaborations as a way of really developing research infrastructure across the continent. And once we have these barriers addressed, this infrastructure built, then we can look even further to the future on additional applications of this work. So, you know, generating polygenetic risk scores that could enable precision medicine, for example, when we are looking at patients, among other strategies. We could also look at potential genetic services. You know, right now we have a gap in sort of skilled medical geneticists. There's limitation in the infrastructure and some political support and public awareness, but this is really where the future of medicine is going. We can also look at the development of electronic health records and how can genomic data really accompany clinical care that is offered. We can also look at advancements in point of care because it's now possible to develop some of these less expensive methodologies on the ground here in Africa. And so all of that can take place here in-house. And then, you know, lastly, even a little bit further down the line, we also have an interest in entrepreneurship. So if we're not having buy-in from the big pharma companies, what are some incentives that we can put into place in driving entrepreneurial biotech sector here in Africa to realize some of this potential? So I'll leave you here on the last slide with some of our achievements and lessons learned. And I also, again, want to really emphasize, you know, the work of the African BioGenome Project, I think cannot be understated. It's really going to be one of the steps forward in, I think, what is going to be an amazing journey into seeing what we can develop with regards to genomics in Africa. And I'm really excited to be a part of this initiative and this work, and really wonderful and tremendous to see all of you here as well. So thank you.
So another round of applause for Dr. Fatu. We will hold your questions. Please note your questions, hold them, and we will be able to ask them, including those who are online, as at the end of this particular session. Our next speaker is Dr. Kasun Tesfaye from Bio and Emerging Technology Institute, Ethiopia. He'll be presenting to us online. Dr. Kasun Tesfaye is currently the Director General of the Bio and Emerging Technology Institute, which was formerly known as the Ethiopian Biotechnology Institute. And this is part of the ministry. Sorry, a minute. The Ministry of Innovation and Technology, Ethiopia. So Dr. Tesfaye's main focus is food and crop improvement using conventional and molecular breeding approaches. And this is in an effort to contribute to the current food security. He's a crop breeder and he's a crop breeder, worked as a university staff, and now is the Director General. He has made several contributions in crop varietal release to smallholder farmers in Ethiopia, and also contributes towards the capacity building of national agricultural research staff and beyond. More recently, he was involved in building bioeconomic research and development in Ethiopia and beyond, with a particular focus on the Eastern African region. He's an excellent leader with rich experience and wide networks, and he has published widely and supervised over 50 master's and PhD theses. So Dr. Tesfaye, you're welcome to proceed. Let us know whether we can share the presentation on our end.
Yeah. Thank you very much, Prof.
Do you want us to share the presentation, or you?
I would like to. No, I would like to share the presentation from my side, so that. Okay.
Thank you. Go ahead.
Share screen. Okay, so yeah, is that okay? Can I continue?
Yes, we can see you. I mean, we can see and hear you well, and we can see your presentation. Please continue.
Yeah, thank you very much, Prof, for your clear, brief introduction. Good morning, everyone. I would first like to thank the organizer for providing me this opportunity to speak on delivering Ethiopian biotechnology strategies through Ethiopia's involvement in African BioGenome Project. So this is the outline of my talk. So I'll briefly give you a little bit of highlight on how we started biotech R&D in Ethiopia, and then the current state of biotechnology research in Ethiopia, and of course the key component of the talk, the 10 years biotechnology national roadmap and the establishment of associated institutions, and also relevant document associated to the roadmaps. And I'll also mention how the partnership can really exploit in terms of addressing some of the strategic point that the nation put forward. And of course, some effort in characterizing Ethiopian crop diversity and also livestock and poultry species. And I'll finalize my talk after briefly mentioning gaps on the above study and also where we need to focus as a country and also as a project. Just to mention a few things about the start of biotech in Ethiopia. Well, biotech currently started back in mid-1980s through a collaborative research project between Swedish University and Addis Ababa University. And through that project funded by SIDA SAREC, few staff were trained and a modest facility acquired. And this basically helped to lay foundation of biotech in Ethiopia. But it was lagging behind activities of modern biotechnology, including recombinant DNA technologies. These are some of the area where most of the research has been going on, like plant tissue culture, disease-free planting material production, dissemination, PCR-based genetic analysis, plant viral disease diagnostics, PCR methods used to identify pathogens in various crops, QTL mapping, which was very common in crops, molecular characterization of bovine using various type of genes, and of course, fine mapping of livestock breeds using different genes. Very recently, the last 5 years, we have seen a key progress in new technologies like genetic transformation of cotton and also insect, gene editing on Brassica carinata. This is also a collaborative project with Swedish University. Gene editing, a collaborative project between EIR and also Danforth Plant Science Center in the US. And another model project, a collaborative project between Ethiopian institution and Kenyatta University, sorghum, Striga Smart Sorghum, which is a sorghum gene editing. These are basically in progress right now. In terms of institutions, I mean, we have around 15 institutions. A majority of them, they are public institutes, mainly focusing on agriculture, forest, and environmental research, on biotech and health biotechnology, whereby research institutes like AHRI, PHI, NVI, and others involved. In terms of private company, majority of the private company, they are involved in tissue culture. The big one is Megale Tissue Culture Center, was established back in 2006. This is the largest tissue culture facility with a capacity of more than 40 million seedlings per year. And Dase Tissue Culture, and again, a big one, whereby with a capacity of having more than 20 million seedling per annum. And Bahadar Tissue Culture, VCI, Waginos, Nagasha Biotech, more, these are on agriculture. Merck ET, molecular diagnostic, this is the only health diagnostic lab with a capacity of doing genotyping, giving genotyping services. In terms of biotech education, I mean, as oldest and largest university, AAU was the first to start training on biotechnology, followed by University of Gondar. And currently, more than 13 higher learning institutions are offering biotech undergrad training. And also more than 6 universities offering a master's program. And of course, 4 universities are currently providing a PhD courses in biotech. In terms of conducive environment, I mean, I believe that biotech has received a strong governmental support and commitment. And of course, the past grand plan, like Growth Transformation Plan 1 and 2, clearly stated the importance of science technology, including biotech, and also our education program, development program also and the recent homegrown economic reform and Digital Ethiopia 2025 has been clearly stated that the importance of science and technology, including biotech, to transform the countries. So as a result of this, back in 2014, the government established a ministerial steering committee and also established Biotech National Task Force with 6 experts drawn from various institutions. And this group basically led the development of national biotech roadmaps for 10 years. The roadmaps basically has one document with Ethiopian Biotech Research and Development Roadmap, and to address or to achieve this particular roadmap, the task force also developed Ethiopian Human Resource Development Roadmap, or the human resource needed to achieve the roadmap. And of course, various kind of roadmaps like agriculture biotech roadmaps, health biotech roadmaps, industrial and environmental roadmaps has been prepared to be implemented by various research and development institutions, and of course, higher learning institutions are also part of this effort. So as a follow-up of the roadmap, we have also developed a national plan. So to achieve the roadmap, we need to modify the curriculum we have. So the National Biotech Curriculum Review and Development has been conducted. So we have a document on this, and the lab infrastructure needed to achieve the roadmaps has also put in place. And of course, we have once we put in place human resource and laboratory infrastructure, safety and regulatory is also key. And of course, with this, one can come up with a product, so that marketing is also an important component of this activity. And of course, as you all agree with me, biotech is misinformed and sometimes disinformed. So awareness raising among the public is also an important activity. So this document has like 5 various sub-documents with detailed strategy. So to supplement this, we have also developed a national biotech research programs for 10 years. Agriculture, health, industry, environment, and biosafety and IPR are some of the components of the national biotech research program. So every institutions and universities are expected to pick a project from this particular program, so that we can move in the same direction to achieve the roadmap. So to implement and lead the national biotech R&D activity, the government established the then Ethiopian Biotechnology Institute and then council with ministerial council regulation with duty and responsibility mainly to involve in policy, strategy, directives, guideline formulation in biotechnology, and of course conduct research and do a capacity building, and also coordinate and create partnership and collaboration with local and international institutions. So later on, the Ethiopian Biotechnology Institute was renamed as Bio and Emerging Technology Institute back in 2021, because the government recognized the importance of emerging technology to address the development challenge we have. So under the Bio and Emerging Technology Institute, we have 2 main centers, like Biotechnology Center, whereby we have all the traditional biotechnology directorates, and also Emerging Technology Center, where we have a research team on nanotechnology, material science, system and computational intelligence, and reverse engineering. And of course, commercialization is also part of the research activity we have. So as you all agree with me, I mean, biodiversity is key to biotechnology, and the East and Central Africa, and in general, and Ethiopia in particular, is endowed with a huge biodiversity, and the country is also known as origin diversity of many crops, and we also have several unique habitats. And the flora of Ethiopia is also estimated to be like more than 7,000 species. of which 12% are considered to be endemic. And also, we host two of the biodiversity hotspots of the world, the Eastern Afro Mountain and the Horn of Africa hotspots. So to make use of the biodiversity we have, and as clearly indicated on the roadmaps, we need to understand, conserve, and utilize biodiversity for sustainable agriculture and industrialization, and also to protect our environment. So this clearly showed that there is a need to coordinated effort on genomics and bioinformatics research to really uncover the resource we have for sustainable use. So when you see this, then you can see the clear alignment between the nation's initiatives and also the major goals of the African BioGenome Project. So there is a clear overlap of the mandate of the institute and also higher learning institution in Ethiopia with that of the African BP goals. This is therefore an opportunity to work with African BP to address important development issue in Ethiopia. Just to mention effort that has been made to characterize the Ethiopian crop diversity and then identify some of the gaps. I mean, these are the crops, a list of crops and the marker used. And as you can see, there are some endemic crops and also somehow neglected by scientific community, like Brassica carinata, Unsat, the Ethiopian oil crops, Gizotia, Hygienia abyssinica, which is tree crops, but quality timber, and also like finger millet, mustard. All these are characterized using all this kind of markers. So you can see from RAPD to latest sequence-based markers. There are also efforts in terms of doing disease diagnostics using various kind of markers. Fungus, viruses, and bacteria have been genotyped, and diagnostic markers are used to address some of the crop challenge. In terms of QTL, I mean, several crops and several traits have been QTL mapped by some of them by Ethiopian researchers, some by researcher abroad. And of course, one of my PhD students also did QTL analysis on Septoria, and others also did QTL analysis on stem rust and QTL map on TEF, and of course, association mapping on wheat has been carried out by researchers from Ethiopia. And JOAS also carried out on durum wheat, and large-scale genome-wide association has been conducted by collaborative efforts between Purdue University and the Ethiopian Sorghum National Program. Some more plants genotyped, especially the Unsat, the Ethiopian indigenous crop, using different platforms, as you can see here. In terms of whole genome sequencing, I mean, you can still see like if activity has been done by a group of scientists from US, but I couldn't really find a single Ethiopian or African author in this particular work. And here also genome and transcriptome sequence by a team of researchers from the Ethiopian Agriculture Research Institute and also Bern University of Switzerland. And on Unsat, the Unsat draft genome has been released by a group of researchers from UK, and also two Ethiopian researchers has been involved there. And this one is also genome sequence data on 17 accession of Unsat ventricosum has been carried out by one of my PhD students in close collaboration with UK institutions. On coffee, well, Ethiopia is origin of coffee, and this is basically how coffee is spread to the rest of the world, and this is the forest coffee we have in the southwest part of the country. And here, one of my PhD students did this particular work in collaboration with Chinese researchers, and here also It's a collaborative project between French and Italian researchers, but I couldn't find a single Ethiopian or African author or co-author. Here, Brassica carinata or Ethiopian cabbage study, but here I couldn't also find any partnership collaboration with Ethiopian researchers and scientists. This is also work on finger millet. I believe this is a model project whereby capacity building of master's and PhD student involved as part of this particular project, and also collaborators from US, EU, Asia, and ICRISAT or CGR system has been involved in doing this particular analysis. So I believe, collaboration partnership should be rearranged in this way. So we have a capacity building and also involve an institution in Africa. African Yam Project, another interesting project. This is a joint effort by African scientists. And I'm really glad and excited to see a majority of almost all the researchers are the African researchers representing various institutions in Africa. This is also a project I'm involved from Ethiopia. This is a fall army full genome sequence whereby we managed to identify resistance gene or resistant to pesticide gene. This is a collaborative project between Ethiopia and other African institutions with BGI in China. So when we come to the livestock and poultry session, most of the activities were focused on assessing intra and interbreed genetic diversity and population structure analysis, selection signature analysis, characterization of candidate genes using different genotyping markers, including mitochondrial DNA, microsatellites, SNPs, chips, whole genome sequencing, and there are also a few GWAS studies as well. So this clearly shows that the whole genome sequencing of Ethiopian livestock and poultry genetic resources, as you can see here from the authors, the contribution of early is and also Veka is immense. And here also the species, and these are different platforms, clearly shows the devs, and these are the authors. So you can see the role of CG system and partnership collaboration with the national institutions. Cattle, you can see the authors here and the publication. And again, cattle, most of the characterization carried out on cattle. On sheep, you still can find few study. Goat, again, few study. As you know, this particular project was carried out, led by Early, with the involvement of Professor Cloner and others. And on poultry, again, Early led activity, but involved various PhD students from Ethiopia and also part of Africa. So where is the gap? So that is an important message I would like to deliver. So most of these activities are really quite interesting in terms of uncovering the genetic composition and characterizing the genetic resource we have. But most of the activities are very fragmented and student thesis based. And they are not well connected to local institution. And of course, they are not well integrated for a practical application of marker-assisted selection and also genomic selection in livestock improvement program or in plant improvement program. So most of the databases are also kept outside Ethiopia or outside the continent. And there is also a clear lack of own database for biological resources. This is what we have been discussing in the project as well, in African BioMaps project. And brain drain problem of retaining competent researchers and scientists and academic staff is also really a challenge. And some of them, they got an opportunity in a project and do their PhD and then stay abroad. So that's because there is no infrastructure back home to really maintain them. And hence, we need to address this gap in African BioGenome Project and use omics tool to explore the untapped genetic potential of plant, microbes, livestock, genetic resources for sustainable development and contribute to bioeconomy. We have where to focus with African BP project. So we need to do more characterization, cattle breeds, honeybees, equines, and camels. And of course, in terms of plant genetic resource, so we need to attain high quality chromosome whole genome assembly and annotation of Ethiopian indigenous crops, and also short read, long read sequence technology to explore the genomic diversity of crop species is like a key things that we should proceed. Just a few to mention few, the Ethiopian chickpea, or locally known as the cocoa, which is PCM sativum vara abyssinicum. This is a highly threatened and endangered crop. And Ethiopian cardamom corona, this is also another spices. Ethiopian oil crops, Gizota abyssinica. And of course, we need also an improved version of insect ventricosum genome sequence and bioinformatics analysis. And of course, Ethiopian coffee with the known Ethiopian cultivar. Root crops like Anjote, Coccinia abyssinica is another, and there are also several forage crops that needs a touch of genomics and bioinformatics. So that is all I have. Amasagganallo, Asante Sana. Thank you very much.
Thank you very much, Dr. Tesfaye. An excellent presentation on how partnerships can help us lead some of the projects that we are having online and in the country. So I would like to now invite Dr. Fatu forward, and we can be able to interact for the next 10 or so minutes with Dr. Fatu and Dr. Tesfaye, who is here with us still online. Please remain online. Dr. Tesfaye, there's already a question for you as Dr. Fatu comes ahead. What are the strategies to effectively engage private partners in agriculture and biotech? Dr. Tesfaye?
Yeah. Thank you very much. I mean, that is interesting. I mean, that's a bit of a challenge in Ethiopia. I mean, as have presented, and most of the private sector, they are basically involved in tissue culture or service provision. So, and also in terms of infrastructure, we have in Addis or in Ethiopia, it's not the one up to state of the art. So that has been really a challenge, but we are basically open for a partnership with the private sector. And we also believe that without private partnership or without the involvement of the private sector, biotech would not really move further like what we have started now. So we are open to any kind of partnership, and we believe in the involvement of the private sector. But with the current context, we don't really have a lot of private sector involved in biotechnology and also in agriculture. So that's I have. Thank you.
Thank you very much. I invite a question from the floor. Anyone who has a question for Dr. Fatu? Yes, I have a hand there. You have a mic, just press. Let me wait for another hand. Yes, so we'll take those two questions. Go ahead.
Okay, my question is for Tesfaye.
Perhaps you can tell us your name and which institution and country you come from. Thank you.
Okay. I'm Benison Mwiti Chabari from Kenyatta University. My question is to Tesfaye. I've seen has worked with the plants, especially the sorghum.
Yeah.
So my question is, Ethiopia is like the birthplace of sorghum. and still striga look like originate from around Ethiopia, Sudan. So my question is, I think there is a quite number of wild types of sorghum from Ethiopia. Sorry, have you considered the, have you considered doing maybe pangenomics on sorghum? Maybe the wild relatives may have quite useful genes that can be introduced into the sorghum that are susceptible to striga and the other diseases.
Yeah, thank you. Thank you very much for your excellent question. Yes, I mean, in Ethiopia, we have a very strong national sorghum research program, and they have the national sorghum research program has really tried a lot in terms of developing a resistant sorghum cultivar against the striga. And they have also tried to really do a crossing with a wild relative. And as you know, wild crossing or wide crossing has its own problem, because you just transfer useful gene and then others. So until now, we couldn't really come up with very good sorghum genotypes in terms of resisting the both striga asiatica and also striga hermontica. That's really a challenge, and that's mainly the reason why we switched to gene editing sorghum, so that would solve some of the problem, because the gene editing is going on the known cultivar or on the preferred farmers cultivar, so that would solve and address the major challenge that our farmers is having with striga. Thank you.
Thank you very much. And
okay, good morning, everyone. My name is Vanessa Natasha from Cambridge Samrid A. So my question is to Dr. Fatu. I have two questions, actually. You said the whole aspect of the biodiversity, the BP project and Science for Africa is to target One Health. Now, where does antimicrobial resistance fit in all this?
Great. Thank you for your question. With regards to antimicrobial resistance, I didn't cover that so much within my talk for today, because that wasn't really the main focus, but I think that's a very valid point as well. We know that antimicrobial resistance is increasing. We have had some conversations with some groups that are starting to look at what are some new methods, that we can use to really target this, looking at phages and sort of other natural, predators of bacteria, so that, as sort of antibiotics and other things that, we manufacture kind of lose their function, we're able to still have some other processes that can work. So I think that's a good point. And I would say that shouldn't be lost at all in this conversation. So thank you.
And I think also coming from the fact that the whole point of this project is you're looking for approaches that will cut across agriculture, and in all these areas we're using antimicrobials. So, and another question is, you also mentioned something about poor representation of Africans in GOS studies. So is there like a goal to sort of curate a database that could actually ensure that the DNA or the genomic coverage of Africans would be increased, so that when, for example, at the end of the day, we're moving to bioinformatics and machine learning, when we want to predict, for example, a vaccine against infections, could we actually have the data to actually test this vaccine against the African genomes or African sequences that are available?
No, I think, again, that's also a very good point. You know, when we're looking at infrastructure, it's not just, you know, what is happening in the labs, but also looking more broadly at where can this data be housed. And so just a reminder again, you know, with Science for Africa Foundation, we don't do the work ourselves, but we support researchers, right, who are looking into these different initiatives. So again, I think that's also like a really valid point as we look to what is going to be the future of this. How do we build that infrastructure and how do we support that for the long term, especially because we want all of these things to be sustainable and not just something, you know, that you have for 5 or 10 years and then it kind of falls apart.
Okay, great. Thank you.
Yeah, thank you.
Hi, my name is Njeri from Kenyatta University training. I'm teaching research and referral hospital. And my question really is for Fatu, Dr. Fatu. You spoke about the Deltas program and the hub and spoke model that you have to build a research infrastructure. How do local institutions engage with you so that we can access some of this assistance?
That's a great question. I would encourage everyone to look at our website. We have constant calls. Most of them are thematic for sort of, you know, different areas that we want to focus in. So we recently had one for AI and health, and there was a call just released yesterday on climate and health, and that's probably the best way to engage with us. Most of those calls are focused for African researchers who have associations on the continent with African institutions. So that's really our priority. Another program that we are a part of that also often has calls similar to Delta's is the Grand Challenges program, which is supported primarily by the Bill and Melinda Gates Foundation. And I think those are probably the two best avenues, I would say, for engaging with us. You can try to reach out to us, but sometimes, you know, responses can be a little bit slow. So if it's something that's associated with a direct program that we have, that's usually the best way to go. So thank you. And we encourage you all to apply, please.
So we'll take a question from Christian, and then I have some questions from the online participants.
Yeah, thank you very much, Prof. I'm Christian Tiambo. I'm scientist at ILRI. And my question is to Dr. Tesfaye. Yeah, I really appreciated his initiative to scan the genomic environment, all the work done in ADES using genetic resources. But we also noticed there are a good number of documents or publications done without the contribution of national scientists. That is something coming strong. And that is also why we are here today, to make sure that we contribute to such initiative. So I really want to understand from Dr. Tesfaye, how does this happen? And as a regulator, how can you educate us on that aspect of research done using local material without local scientists involved? So thank you.
And that's an excellent question, and we can tie it with one that has been asked online. And this one has been asked that we have seen very, very many good publications between Africans and collaborating scientists who are out of Africa. Can we have more joint Africa to Africa projects? And how can we secure sufficient funding to ensure that we can do it in-house? Thank you, Dr. Tesfaye.
Yeah. Sorry, Professor Ann, maybe because my question related to this as well, so I don't know if you give me the opportunity to ask, and then Dr. Tesfaye would just answer all of them at once. Is that
yes,
okay, Professor Ann?
Please go ahead. Yes.
Yeah, so Dr. Tesfaye, I think what your presentation, I've been sitting here listening to what you've given. I mean, you kind of have the AfricaBP, you know, all of the things we are talking about in your presentation, and I was even thinking you could, you know, potentially again make it available to Anne or Katrina or myself. So, but two things. One of them relates to the question Christian asked: publication. I think it's a big challenge on the continent. I have seen it each time. I also see it. You know, I signed up to Google Scholar and I get all of these things and I look at it. I look the project is done in Africa or with Africa samples, and I tell you, 9 out of 10 times I don't see an African author. So when you have that slide, I was thinking to myself, this is one of the reasons. It's not the main reasons why we set up AfricaBP, but it's one of the things that AfricaBP will help solve. And that is one. So it would be nice, just as Dr. Christian mentioned, can you let us know? Because I want to hear, AfricaBP has been run on the grassroots, true grassroots. It's basically run from bottom-up approach. Someone told me the other day, or asked me the other day, thank God, how did you guys get lots of African scientists signing up? I said, it's simple. It's run through a bottom-up approach and not a top-down approach. And the way it's run is that we speak to African organizations, institutions on the ground, you know, to know what is happening, how we can make this, how we can correct this. So, and I grew up in Africa. You know, I work with African scientists through AfricaBP. We published 2 Nature papers. I don't know, Professor Ann did mention that. In those Nature papers, we have African authors fully. So if, as Africans in AfricaBP, we publish a paper about Africa and we include African authors, then how do we encourage non-African scientists to do the same? So it would be nice, please spend the next few minutes expanding on this issue. And this issue touched at the heart of so many things within the continent. And this is one of the things AfricaBP will help solve. And if anyone listening to my voice today, if you lead an organization in Africa, in the institution, then this is one way you can help to correct that. You know, getting involved in AfricaBP over the next few months, you know, once we assemble our genomes, the idea is that it's going to be driven by the African people. And believe it or not, affiliations in papers has a direct correlation to the career progression, whether in getting funding or, you know, advancing the research. So I would like Professor Dr. Tesfaye to kind of expand more on this. And secondly, I would like to see the gaps you highlighted. If you just put up the slide, please, your last slide, because again, I was staring at those gaps and all the things you have there actually resonates with me, essentially. So if you just put it up, please.
Okay. And as Dr. Tesfaye does that, there's a question that has come online, and I think it very connects this particular question to Dr. Fatu, and it says that Africans are poor authors and they are poor communicators. Kindly comment.
Okay, yeah. So I think with this one, yeah. So it would be helpful. Again, this connects to the question Dr. Christian mentioned, asked earlier. Can you also let us know how can we connect the project better to local institutions? So we've started to do that. I know we've been doing that quite well within the project. For instance, as you can see, in this workshop, basically, majority of the speakers are African scientists, affiliated African institutions. That is what we've done in other places. With the fellowships that are coming also, we ensure that the nominations, I don't know if you heard the opening remarks, the nomination will happen through African institutions. And we also ensure that the sequencing and everything happens on the ground. But we'd like to hear more from you, how we can better do this, especially within the project. And I also see you talked about lack of its own database and the data kept outside Ethiopia or Africa. So if you listen to my comment earlier on, just after Professor Ann talked, is that one of the proposals I'm thinking about over the next coming months, hopefully in 2024, is that for the continent to have its own database for biodiversity and agricultural sequence data, essentially. So that could be similar. That could again be connected to the International Nucleotide Sequence Database Consortium. You know, something similar whereby you could also say, okay, this is what you're going to have on the continent. It could be in a distributed format. So these are some discussions and proposals that I'm thinking about. So it would be nice for you to also expand on this. And ultimately, I know how this connects to the brain drain and also potentially the brain gain, you know, within the project.
Yeah, thank you very much. I mean, all the points and the questions are quite interesting, and I think that's mainly the reason why we joined the African BioGenome Project. I mean, partnership is important and also key for a knowledge-based activity like genomics and bioinformatics. So without partnership, without partnership, we can't really go and reach anywhere. So we need partnership and collaboration at local level, at national level, because in various universities and research institutes, there are people sitting here and there, some having a good skill in bioinformatics, some in genomics, and some of them, they have a very good infrastructure in terms of bioinformatics and genomics. So we need to make sure that at national level, the institutions on biotech, they are well integrated and well interconnected. The next layer is like a regional partnership and collaboration. And that is what the African BioGenome Project is doing. So some of the things, I mean, some of the facilities and some of the skills, you can't really find it locally. So then the regional partnership and collaboration becomes valid and important. So all things are really boils down to integration, partnership, and collaboration, and how we can strengthen the partnership collaboration within African institution and within African scientists. So through that system, we can, I think, address the challenge we have. I mean, as I've already presented, if you further go to those publications, you'll find a PhD student at the back. So, and also a project not well connected to the local institution. So if the project or if the particular activity is not connected to national institutions, the data is not really used in the breeding program or improvement program or conservation program that the nation has. So that is the key challenge we have. And that is where we need the African BioGenome Project. So strengthen the national connection, strengthen the regional connection, and of course, create infrastructure capacity, especially in terms of data storage and also data analysis. So if we meet this, I think we can minimize the challenge we have, and this will help help us to minimize the brain drain and probably, I mean, enhance brain gain. It's not in terms of, I mean, bringing back the Africans, but the Africans in various labs in Western world could also be part of this initiative and support the initiative from their home institutions in Western world. So those kind of things we really need to be focused and I mean, exploit so that under the umbrella of African BioGenome Project, I believe some of these gaps can be addressed well. Thank you.
Thank you, Dr. Tesfaye.
I turn to Dr. Fatu, and there's a new question that has talked about bioprospecting and how Africa has lost a lot of its genetic material.
So I think that's also, again, a very good question. With the work that we are doing for the Science for Africa Foundation, you know, we are really supporting African researchers on the continent. So building those infrastructures and supporting those projects that would keep the data, the materials, and all of those things here. So if you look at our mission, our vision, our values, that's really the main goal of our organization. So I guess to answer that question, that is a challenge that we're trying to solve, and to understand how is it that we can get, you know, more researchers, more infrastructure built on the continent so that we don't have that loss of data.
And what about the comment that Africans are poor authors and poor communicators? Do you agree?
I don't agree. I would say, well, first of all, I would say one who is making that judgment. And secondly, I would also say, you know, no one is born a perfect communicator. We understand, especially in the sciences, you know, we're very good at communicating to our peers and those who are also in the same field. But when it comes to speaking to maybe individuals in the government or those who aren't directly involved with our research, I don't think any scientist does a very good job of that. And we also support a lot of training and, other initiatives that can really help scientists be more effective communicators, whether that is to individuals who are outside of our field, government officials, community members who are directly impacted by our work. We have a fellowship that started this year, the Clistus Juma Fellows, and that is for researchers who are in a more advanced stage of their career, but also really giving them the training for, media contacts, writing articles, interacting and advocating, for their work at the government level, and just really understanding how to communicate with many different audiences so that they can really get their message across.
Professor Ann?
Yes, Dr. Thangod.
Yeah, so can I just add to that comment? So I think just to again support what Fatou is saying, I don't believe in the Africans are poor authors or poor, basically, because we go to Europe, we go to North America, we go to elsewhere, we see Africans doing great work, leading research labs. For instance, I don't mean to flag this, but I brought together several African scientists, published this paper in Nature. I went to the University of Cambridge. I did my work in Oxford, So I don't think I believe that the problem here is the problem we're trying to solve. And this is a problem I've thought about for nearly 10 years when I arrived in Cambridge for my PhD. And if we are able to solve that problem through the African BioGenome Project, then this thinking of Africa being poor authors will disappear, because we are here in, you're in Europe, you're in North America, you go to hospitals, you see African doctors, African lawyers, doing great work, engineers, So for me, it's all about the ecosystem, which is what AfricaBP is targeting. Let us first of all, bring people together. This year alone, we brought 4,000 African scientists together. As Professor Apollinaire mentioned, we don't know how many of this will go on to do good things. And this year alone, we've trained through hands-on practicals up to, by the end of this week, up to 360, 350 African scientists. So we need to continue to do this. We need to continue to bring people together through this sort of workshop. We need to provide more opportunities to African scientists, basically. So I think my video wasn't turned on. So we need to provide more opportunities to African scientists, and we need to offer more fellowships, and connect this heavily to local institutions. For instance, I totally agree with Dr. Tesfaye that we don't, and this is also something I also agree, I have discussed, extensively with Professor Apollinaire. Genome sequencing should not happen on its own. It should be connected to a national institution. If you are sequencing something, your institution needs to know at the top leadership level, at the higher rank level. That way it can trickle down, essentially. So I believe that if we continue to do this over and over again for a long period of time, then that perception that Africa is a poor communicator or poor authors will begin to disappear, because several Africans are doing great things in North America, in Europe, in Southeast Asia, and all over the world. Thank you.
So thank you very much. I think it's about the environment, creating the right environment and creating the right facilities for us to be able to publish and write more. And I'd like at this point, because of time, we need to move on, but let's give a round of applause to our early morning speakers, Dr. Tesfaye all the way in Ethiopia, and Dr. Fatou. Thank you very much for coming.
Thank you. Thank you very much.
And please stay online with us. I would be happy to hear your contributions as the sessions go on. So we move on with our program. The next talk, which will be on LC, and Dr. Sally will, Miss Sally will tell us a little bit more about it. So our next speaker is Sally Mweni Katie. She's going to come and talk about ethical social policy considerations for purposeful and inclusive biodiversity genomic endeavors, and she'll be giving ILRI perspectives. Immediately after we hear from her, we'll be able to have a panel session, so we can now talk about the greater topic about inclusivity in science. But Sally is currently an ABS research associate here at the International Livestock Research Institute. She's a lawyer by training, and she's very experienced with the ABS Nagoya Protocol. She's a legal specialist and is skilled in giving legal assistance, writing research, policy, advocacy, biodiversity, and policy advisories, including those on sustainable food systems, ABS and DSI compliance in agricultural research. And she's also very keen on capacity building initiatives. She currently occupies the role of chair of the Ethics, Legal, and Social Issues Committee of the African BioGenome Project. She's also a member of the Earth BioGenome Project, where she's an executive governance member. And she has worked very, very closely with international group of scientists, and she has diverse interests, especially those leading in policy issues. You realize that we as geneticists, as scientists, as bioinformaticians, we cannot just talk to ourselves. We have to broaden the conversation to include what laws and what are the governance frameworks for doing our research. And we're really, really looking forward to your talk, Sally. Welcome. A round of applause.
Thank you for that introduction, Anne. Quite a mouthful, don't you think? So for those I've not had the pleasure of meeting, my name is Sally, and I work at ILRI as an ABS research associate, as Anne has said. And I'm happy to be here because it's very exciting whenever we convene with scientists, because you get to see so many multi-layered, multifaceted insights on many different things. And I'm so happy that the last session had some ethical issues coming in, so we're thinking in the right direction. Usually whenever people hear ethics, legal, scientists, they want to run away because they think we're just talking about laws and think that maybe we're gonna bore you with the legal stuff. But I promise, I might speak about some legal things, but that's not all I'm gonna do today. So I'm gonna try and move the presentation. I don't know if I'm able to move it. Can we please go to the next slide? So I'm just gonna do a pulse check in the room. Now, the theme for the workshop we're having today is Sustainable Future for Biodiversity, Genomics, and Bioinformatics. And I'm gonna split the room. I'm gonna expect one response from this side just to get us a bit active, and this side. So when you think about a sustainable future for biodiversity, genomics, and bioinformatics, what exactly comes to mind? There are a few familiar faces in the room, so if there are no volunteers, just know if I know you on a personal level, I might pick you. So yeah, just 1 minute, just, after the conversations we've been having, when you think about a sustainable future for biodiversity and genomics, what comes to mind? Anyone? No volunteers? Okay. So, okay, I had put up, I'm not gonna pick anyone, but I'll pick you guys later. I have a few questions later, but yeah, so I'd put up a few options. So for me, as someone who's experienced in policy, when I think about a sustainable future, some of the things I think about is easier access and movement of genetic material. Another thing I think about is clear, environmentally sound and non-restrictive laws. Another thing I also think about is sustainable use of the wealth of genetic material in the region. As we've been going on today, everyone has been talking about how Africa is so rich in biodiversity. That has come up in all the presentations. So when I think about a sustainable future, I also think about the sustainable use of those genetic resources. Please, let's move to the next slide. Within the African context, now to make it relevant to what we're discussing today, Africa is home to a lot of numerous animal plant varieties and animal varieties. So there are a lot of things that are considered endemic species here. So for example, we have the Goliath frog, which is endemic to Cameroon and Guinea. And then we have the dwarf crocodile, which is endemic to Cameroon as well and Guinea. And then you have white ginger root, which is from Kakamega. I cannot pronounce for the life in me what it's actually called in Kiswahili. But these are just some of the species that we hear about when we talk about endemic species within, the East and Central Africa. So when we think about the East and Central Africa context, some of the things that come into mind is how East and Central Africa is actually a biodiversity hotspot. We have a lot of biodiversity and genetic material within the space. But the unfortunate reality of that is, next slide, as we have so much wealth within, it continues to deteriorate at an unprecedented rate. Guys, can we please move to the next slide? I don't know. Okay, yeah. So it continues to deteriorate at an unprecedented rate. So what does that mean for us? It means that there are a lot of negative impacts, right? So one of the things we need to be able to do is to come together as agri-food allied sciences and systems and try and figure out various solutions for the same. So there's a need to address this ongoing crisis. Now, there are a lot of ventures that have gone around to talk about, collaborative efforts. So AfricaBP exists as one of these collaborative efforts. Here in ILRI, we're also trying to do a lot of that kind of work. We have CTLGH, there's AfricaBio BioGenome Project. Then there are a lot of laws and policies that are also going towards this. So you have, for example, the 17 Sustainable Development Goals. There's Aichi targets. There's the post-2020 Global Biodiversity Framework, Nagoya Protocol, and so on. A lot of great policies that come in towards these conservative efforts. Now, the relevance of all of this. So everyone is working towards technologies and everyone is working towards technologies for conservation and improvement in the sustainable use of biodiversity for food and food security and nutrition. Now, the ILRI colleagues are going to agree with me. We've had the phrase, get the science right, fit for purpose, so many times, right? Right. So that's where LC considerations come in. You cannot talk about getting the science right and doing things fit for purpose without having ethics, legal and social issues coming into play. Now, for us to have a sustainable future in biodiversity and genomics, we have to talk about LC issues. So what are these LC issues? When you talk about LC issues, what exactly are we talking about? So LC issues is ethics, legal, social issues, right? Now, if you think back, before we never used to have these policies in place. If you wanted to go collect a sample, you just go where you're going to collect the sample, take the sample from the animal or the plant, put it in your suitcase, go to your lab, get your data, publish, no repercussions whatsoever. But as we've evolved, the cost of sequencing has reduced. The challenges that we're dealing with, they've also advanced. So right now you can't just go, for example, to Uganda, take samples, and then just come back to Kenya and sequence. There are a lot of things you have to consider. There's the legal side of things. Even, for example, you could be dealing with endangered species. There are some areas you can go and collect samples. Maybe they're really religiously revered. There's traditional knowledge associated to this animal, or it's spiritually revered. Women cannot go to that forest. There's a lot of stuff that comes into play. So that's what LC ideally considers. And at the helm of it is compliance. So how do we achieve this compliance? We identify the ethical, social, and legal issues in the research activities. And then we recommend strategies that can help address these issues and the research that we're actually doing and ensure that we're conducting this research in a responsible way. So how do we also do this? We do this through collaborations. So collaborations is somehow where we collaborate with our national partners. You ask questions, you get to understand what sort of policies do you have in this various country? What sort of laws, what sort of requirements do I need to consider when I'm trying to access various samples? Capacity building. For capacity building, it's an initiative like this one, where you come in and you get to exchange with different people and get to understand different perspectives. Consultations. For example, in AfricaBP, in the LC committee, we've had roundtable meetings with different focal points for the Nagoya Protocol so that you can understand the various expectations in various countries, the legal temperatures and atmospheres, and you're able to move into that country with the correct mindset. Communications. You have to publish. Thank God has talked about publishing. For example, in the LC committee, we are currently working on a manuscript that is going to be able to help people understand some of these things at a better scope. Now, in as much as it's all exciting, that doesn't mean that we don't encounter various challenges, LC-related challenges, which some of you may see and you may look at them and they may be something that you've probably experienced in the course of your work. So some of the challenges we've experienced in regards to LC is delays in documentation. And let me tell you, I used to not consider this a particular challenge when I just used to sit like from a legal policy aspect. But when I went to sit with the scientists, I got to understand how much of a problem this can be. For example, if you have delayed sample collection permits, like they've not been processed early enough, how this occasions such delays on your research. Or maybe you've collected the material, you got the permits, but now you need to send the material somewhere else for sequencing. It poses such an interesting challenge when the sample collection permits and other documentations have been delayed. Now, the application of laws and treaties. So different countries have different laws and different treaties because as per the Convention on Biodiversity, every country has the autonomy to create the laws that are going to govern exchange and access of material in the various countries. Then understanding biotechnology and biosecurity and biopiracy issues. So earlier this year, we were able to attend the Africa Biosciences conference in Windsor. And one of the things that came out when we were discussing on biosafety and biotechnology were some of the challenges that are experienced generally. And one thing that kept coming out is misinformation and miscommunication among people involved in the space. So you can imagine how much of an issue this is when you're trying to move maybe some emerging technologies or advocate for a different kind of, a product. Maybe it's cotton that's been worked on, and maybe it's a different yield. It's a bit of a challenge when there's miscommunication and misinformation. Now, from the ethical and social aspects, the one issue on this list I'd like to focus on, for example, that is really challenging is intellectual property and data sharing to third parties. So as we mentioned, we are trying to sequence 105,000 eukaryotic species. This means there's a very robust database. Now, when you talk about access to this data, and even in your own institutions, some of the issues about access to data become very sensitive, because then you have to ask yourself, if you're giving data access to third parties, what exactly are they accessing this data for? What are they going to do with it? How do you track and trace? And then how do you also involve the original provider who gave you that data? It's a very sensitive issue because you also have to think about data minimization, because you have to give just the essential data that needs to be used. You can't give someone access to the entire database for ethical and legal reasons. So there's some of the challenges we have to deal with. And even in terms of tracking and tracing of benefits, it becomes a big challenge when people are not forthcoming towards saying what exactly it is they want to do. Now, in the ILRI situation, in the ILRI perspective, one of the things that we deal with here is different applications of laws in different countries. So some of the things we've tried to do is have regular discussion platforms with stakeholders to understand perceptions and expectations, and this happens through our national collaborators. Another thing we've been able to do is have capacity building and awareness creation through webinars and workshops. So we've had biobanking workshops, and then of course we'd come in and now discuss on the legal aspect and understand like what is the situation and atmosphere on that side, and it gives a lot of insight. But then generally, when we think about it in terms of sustainability, how many workshops can you have? How many, conferences and interactions can you have? So ideally, the idea is to continue having these capacity building workshops and webinars and meetings with partners, and eventually have a toolkit that's simplified and it has mechanisms for access and data sharing, as this will now help people understand the African context and have a harmonized sort of setting where people understand the laws and people can, of course, engage on the best practices and, be able to give more people access to all of this information without holding it. Because if you go, for example, if you go to the ABS clearinghouse and then you just have a look at the laws, you might find some countries have not uploaded their laws, but that doesn't in entirety mean that there are no laws for genetic access to material in those countries. It just means that they've not been uploaded. So you see, when we have these interactions and these meetings, it gives us an opportunity to also come and now put all of this down in a document that everyone can access. And then of course, that way there's more, there's more promotion towards compliance. Now, of course, I cannot leave without talking about ABS. So I don't know how many of you are familiar with the Nagoya Protocol. So what I'm going to do is just give a basic rundown of my simplified interpretation of what exactly the Nagoya Protocol is, what it exists to do, so that we don't have to go into clause 1, 2, and then you guys get bored. It's a simplified simplified approach to it. So the access and benefit sharing, which is ABS, it refers to the framework that was established under international law to govern fair distribution of benefits that are arising from utilization of genetic resources. So as I said before, there were no laws existing on this. People would go at their own wish, collect the samples, go and sequence, publish, and as we've seen even from the examples that Dr. Tesfaye gave, there's no, acknowledgement, no publication recognition from African authors, and that was something that was really happening and still continues to happen, but at least now there's sort of more grasp over it. So as a result, the access and benefit sharing was introduced, and it's primarily catered for by the Nagoya Protocol, which exists as an extension of the third objective of the Convention on Biodiversity. So ideally, ABS and the Nagoya Protocol, it's a consultation process, according to me, between scientists and local that allows them to come together and align before access. So what does this mean? It means if you're trying to access genetic material, there has to be a consultation process between the provider of the material and the user of the genetic resource. So that's exactly what ABS was trying to do. And summarized to 3 points, what exactly it tries to achieve is to ensure that we have appropriate access to the genetic material, appropriate transfer of technology and know-how, and appropriate funding or compensation in regards to monetary benefits. But I'd also like to politely point out that monetary benefits are not the only benefits that come into mind or that should be considered when you're discussing benefits arising from the Nagoya Protocol. Now, regarding the ILVI context, there's a poster there that hopefully we'll be able to share this with you at some point. This poster basically has a rundown of the process of compliance. So I'd just like to point out in ILRI here, our compliance is led by the Environmental Occupational Health and Safety Office, and it's supported by the Legal Office. And for me, who's assigned to the Livestock Genetics team and CTLGH, I support the scientists by trying to push these documents to EOHS and support them as they also just manage and lead the compliance aspect of research. And I'd like to say that for us, it's been a bit more easier, especially now, because these processes have been digitized. For example, for us here, we have compliance forms that you apply for projects, and then you get the detailed processes on what exactly it is you're trying to do and how to move. The EOHS office has been very helpful with providing us with that information. But for your own consumption, when you're trying to access genetic resources, the first thing you need to do is plan your research. When you're planning your research, you need to do your due diligence, which is what I've said. Don't be afraid to ask questions. Go to your relevant offices. If you have access to, the internet and you want to send a sample somewhere, go and check the ABS clearinghouse, get the information on the national focal point of that various country, get their details, email them and ask them, we want to probably access material here. What are the laws? Can you direct us to the relevant people we need to talk to actually access this sample? So then you get to find out what the provider country laws are. Once you do that, you obtain the required documentation, which is the prior informed consent, your mutually agreed terms, your material transfer agreement, and your permits. These are the documents that ideally allow you to go in and collect your samples and then move your samples. Now, once you've gotten your documentation, it's important for you to ensure that you conduct your research in compliance with what you said you are going to do, because you'll get a research permit. You should endeavor to stay within the intended purpose. Don't go and research on something else or use the sample for something else other than what you originally stated it for. And try and find out if there are any other additional obligations, because like I said, in the LC perspective, there are also the ethical and social context. So you have to also respect the laws and the environment of that particular place. Now, for you to be fully compliant, you have to get an internationally recognized certificate of compliance. And this can only be gotten once the competent national authority has uploaded all your documents onto the ABS clearinghouse. You'll be able to see why this is important later. And after you've gotten your IRCC, one of the next things you need to do is seek, keep, and transfer. So if there's anyone else who's going to be working on that sample after, you need to seek, keep, and transfer everything so that even them, they're also compliant. Now, you guys had refused to answer my first questions, but we're going to now do a bit of a myth-busting activity. So I have a few myths on the screen. And if you will indulge me, I'm going to ask someone please volunteer to tell me which myth you want to bust. So we can do the third one, which says, my research material is stored at my institution. I can just use it without worrying about regulations. Is that true or false? That's false. Don't know why people are murmuring. So we can try another one. Benefit sharing refers to money. I'm doing non-commercial research, so I don't have any benefits to share. Is that true or false? Right, so everything here is false. There's nothing that is true. Benefit sharing does not refer to only money. There's also non-monetary benefits. A lot of people tend to think that benefits is just monetary benefits. It's not. There's transfer of technology, it's publication and acknowledgement. There's a lot of other things. Then it is sufficient if your MTA states that your research material is Nagoya Protocol compliant. That's not true. So we can agree that there are a lot of myths around Nagoya Protocol, myths and misconceptions. So it's important for us to keep asking ourselves these questions, because sometimes what you think is not really serious might end up being a bit serious. Now, I'm going to talk briefly about the digital sequence information. So I don't want to dwell on this so much because DSI, even up to this year, is still a controversial issue. Even after we've attended the CBD meetings this year in Nairobi and in Geneva, there's still no consensus. But what I want us to keep in mind is that no one is exclusively a provider or a user of genetic material. We're all providers and users. And this map gives a perfect example of Malaysia, for example. In Malaysia, 59 countries are using data from Malaysia, but 68 countries' data is used by Malaysia, right? So no one is exclusively a provider or a user. So you can't just say, I'm just a provider. We're all using each other's data. But how do we make sure that we are compliant and, ethically right, legally right? As we continue to navigate this DSI space, we need to make a habit of listing the country of origin. So in your publications, list the country of origin, try and collaborate with people. Don't just take information from places and not acknowledge where you've gotten it from. Now, this last topic I'm going to be talking about is helicopter research. So if you can see the screens, there are scientists hanging on parachutes, microscopes falling down. That is basically the annotation of helicopter research, which is also known as parachute research. This is when genetic resources, when we conduct exploration activities or users conduct exploration activities, collect samples from provider countries, disregard the local communities and researchers, or access laws and regulations, leave, publish the results and the findings of their research as their own without acknowledging and recognizing the providers. I'm so excited that we've already had an example of this with the Ethiopian publications where data from Ethiopia was used and there was no acknowledgement. So why is this a problem? It's unethical and it contributes to biopiracy. Then that makes you wonder, what are the risks of non-compliance? So it contributes to biopiracy and that makes it very illegal. Then you have the opportunity to sever your relationships with your institutional partners, research donors, etc. Fines. For example, in the EU, the fines are up to $50,000. Now, and that's a fine that your institution is going to pay. On top of other things, your publications could be withdrawn or you're not allowed to publish. There's loss of reputation, suspension, and you could even be banned from accessing genetic resources. And then there's blacklisting. I don't mean to scare anyone, but very small things is what contributes to all of this. So I'm just gonna give a case study here. So in Kenya earlier this year, we had 3 individuals who were caught trying to smuggle ants worth 300,000 shillings without authority from KWS. Now the ants were to be released to the National Museum of Kenya for research. Why they were exporting the ants, the reason is still unknown. Now, I'm gonna give a second example, which is more relevant to us who are here today, because the first one is outright biopiracy, because they were taking the material without permission. But this one is a situation that anyone can find themselves in without even intending. So in 2019, in February, there was a group of 3 researchers. They were actually doing some exploration and they had species of this very beautiful tarantula donated to them. So the journal of the British Tarantula Society published this paper. It's nothing new. Samples are always donated. Publications and different species are always discovered every day. Now, this tarantula sample was discovered in a national park in Malaysia. So after the publication, because they got the sample, it was donated, they even named the species, got a lot of accolades, and they published. So after this publication happened, there was a lot of backlash. A lot of people and researchers came about claiming that these researchers had received their specimen secondhand from collectors who had poached it from Malaysia. And it was very messy. It was very messy, so much so that the institution they were affiliated with actually said that the people who had discovered this species were not employed by the institution. Like, they literally disowned them. So what am I trying to say here? That it's important, even in your institutions, when you're donated for samples, or just any samples or any genetic material you get access to, try and find out if it was ethically collected, what were the permits, if it was pre-Nagoya, did you have the right documentation for it? So that we don't find ourselves in this situation. Because there are consequences of non-compliance like these, where firms are actually fined a lot of money. And right now people are getting more aware of these kind of situations, and you have the institution that you work for, you're affiliated with, having to pay that fine. Now, as I wind up, what are the things that we should think about as we're doing our own research? So there are things that have been talked about today, which is like establishing win-win collaborations and partnerships, joint collaborations, where people actually recognize everyone who's been involved in the work that they're doing, abiding by local and unwritten rules. You have to ensure that as you're doing your work, whatever it is you're doing, that you abide by all the rules and regulations, written and unwritten, so that you're fully compliant. Then you have to recognize and embrace the different working cultures of different places. So as you go, you might go to Cameroon, you might go to Uganda, the working culture is different and you have to respect that. Then you have to use local infrastructures. You can't go to, okay, you can, but you shouldn't go to a different country or a different environment and work there and not use the people around you and the local infrastructures to do your work. You might find that there's a lot of associated traditional knowledge these people have that may help you advance the work that you're doing. We also have to incorporate a capacity building component. It's important for us to continue having sustainability in the work that we're doing and be ethical and fair about publications and authorships. If someone has contributed in a major way to your work, give them like the authorship and the publication credit that they're entitled to. And as I wind up, I just want us to think about what exactly warrants authorship. Is it applying for permits? Is it having knowledge about remote field sites or microhabitats? Is it arranging the logistics? What exactly amounts to authorship? Thank you.
Thank you very, very much, Dr. Sally. Please, a round of applause. And especially for those of us who thought that poachers are those guys who roam national parks with guns on their shoulders, shooting elephants and rhinos. You and I can be a poacher. Yeah, you can be accused of poaching samples if those samples have not been obtained ethically. And this is a dimension, especially for us working in national institutions who receive donations. People just find, oh, there was this beautiful flower. I brought it to your lab because I know you collect, you know, I don't know, orchids, or you work on orchids, and yet that could actually have been poached. We will be able to have a brief question and answer session, but right now I would like Dr. Sally to come here and help me navigate a panel. Just in case you think that we are adverse to Europeans and Americans and we are only talking to Africans, I'd like to tell you that as African BioGenome Project will attest to, that many of us as Africans have been trained in institutions outside of Africa. So we're not adverse to this, but we're just saying, how can we bring the science closer home? So with us online, we have Professor Lars Chatrot, who is a professor from Ghent University in the Netherlands. He has an MSc in plant ecology and a PhD in plant systematics. He has worked in the Royal Botanic Garden Kew and Utrecht University. He was an assistant professor in Wageningen in the Netherlands. before moving on to Ghent University as a professor of systematics and evolutionary biology. His interest is in plant families Anonaceae and Convolvulaceae, and he has worked and done field work in several Asian, African, and Central and South American countries, and now he's inspiring botanists, and he's supervised many MSc students, 42 actually, with 13 PhD students, including 4 PhD students from Africa. And I think you've seen Paul. Paul standing over there is a PhD student of Ghent University, studying under the tutelage of Professor Lars. We have also online Dr. Anna Rita Simoes, who is a taxonomist at the Royal Botanic Gardens, Kew, UK. She's a specialist on Convolvulaceae, the family of sweet potatoes and morning glory. She's also a visiting scientist in the University of Ghent and a associate researcher at the East African Herbarium in Kenya. She holds a PhD in plant systematics from the University of Reading and has done postdocs in the Singapore Botanic Garden and Sao Paulo Botanic Garden in Brazil. She founded the Convolvulaceae Africa Network with Dr. Esserman in the US, which has grown to over 300 members worldwide. Her research focuses on systematics of sweet potato and relatives. So this particular session, we would like us to have more of a question and answer session. Number one, Sally here has told us about justice, equity, and the legal framework surrounding that. And I want to bring in Dr. Lars and Dr. Anna, and Sally here will also contribute to talk about what does justice, equity, diversity, and inclusion mean, not only in terms of the Africans involved, but also in terms of the research publications and the grant organizations. And I would like to start with Dr. Lars, Professor Lars. Professor Lars, what does the question of justice, equity, diversity, inclusion mean from your perspectives? I can see you online. Are you muted?
I cannot. Yes, sorry.
Yes, we can hear you now. Go ahead.
Excellent. So thank you, Anne, and thank you for inviting me to be part of this panel discussion. And thank you for the introduction. So what does the justice, inclusivity, diversity mean to me? What it means to me actually that I'm very aware that I'm privileged, and you know, because my field is systematic and evolutionary botany. I've been working on tropical plants, mainly in South America and Africa. And so if I want to do my research, I need to go to the tropics, or I need to use herbarium collections for my research, as does anyone in my field. And the thing is, access to data, access to collections, even access to finance is highly biased, which is exactly a legacy from the past. So I think and as I said, I realized that I'm here in Europe. You know, I'm a white male born and bred in Europe who I think even entered this field about 30 years ago, not being too aware of these issues at the time, and increasingly throughout my career, having become much more aware of our privileged position with regard to access to, as I said, to data, to collections, to expertise. So over the years, I think I've developed an attitude where I want to work as hard as possible to make people in Africa, for example. So at the moment, I've two PhD students from Kenya, one of them being Paul Kagame, present in your room, to maximize possibilities and potential for their project, for their research, and in doing so, increase the potential for, in this case, Kenya, you know, to be more autonomous in terms of doing research on biodiversity.
Thank you. And I would like now to move on to Dr. Anna. I know, Dr. Anna, you're working now at the Kew Botanical Gardens, which is this huge resource available there in the UK. We're aware that, you know, many of the materials that are there might not be native to the UK, must have come from elsewhere. And that's one perspective we'd like to hear from you. But the other perspective is that I know you're not a native of the UK. How did you get there? Why are you there? Was there an issue with you getting access to what you have in the UK back home where you come from? And thank you. Dr. Anna?
Thank you. I muted myself and I couldn't unmute myself, which is, I think, very wise of you. Again, just to start thanking for the opportunity to speak here today. I think this is a fantastic initiative, and I just would like to say that it is a privilege to be part of it with my humble contribution. But thank you, Anne, for the question. So maybe start with the aspect of resources, which I think will follow from what Professor Lars has just said. Being based at Kew, being based in the UK, I do feel it's a privilege that just outside my office, I have a wonderful collection of 7 million specimens, just the dried specimens, not mentioning even the living collections that have been collected all around the world from a range of countries. And many of them have duplicates in their home countries. So in the East African Herbarium, for example, in Kenya, but around the world there will be duplicates, but many of them are not, they're just unique specimens. So it is still a richer collection in many respects. And it's, of course, a fantastic resource. It's very useful when you work with, in my case, in my field, in plant taxonomy, if you want to know where a species occurs, if you want to study the morphology, it's fantastic to have all of these specimens from all of these countries in one location. But I think the aspect here is one, we're moving towards opening up these resources to people who are from these countries. And I think we need to continue that either through digitizing the specimens, making them available online, continue to bring students and visitors in, allowing them to come here and study the collections. But for me, it's also about continuing to collaborate and allowing more collections to be done in country, where collections can stay in the country and help local taxonomists to grow as scientists and to do their own research and not always depend on these very rich collections that are based elsewhere. So it's unfortunately a reality. It can be a benefit in the sense, as I said, we have a very rich collection in one place, and if we give it access to the right people, to everyone who studies the plants, that's fantastic. But it cannot be the only solution. I think we are already moving in that correct direction, from having one or two very big collections that have everything to having local herbarium, local institutions have their own resources in developing them to make things a bit more balanced. And I think we definitely have a role to play. So speaking for myself, being based in the UK, that is like Lars, I try to be as conscious as possible of this and promote more research in the countries that I work in and collaborate more rather than seeing some countries as a source of specimens or source of samples. Unfortunately, this is how it has been for many years, where people would go to a country to collect and bring back the samples. But I think luckily many people are not doing it like that anymore. And I honestly think it's not even, it's not the right way to do it. It's also not the most fun way to do it. I love to collaborate. I think it's fantastic that we can move forward in that direction. Is there anything in particular you'd like to say more about this in terms of the resources?
Just a question that might perhaps jog our memories. You're not from the UK. I think you're from Brazil, if I'm correct. And now you're working in the UK in this. What made you move? And I think that's some experience that most of us have had in terms of access to opportunities back home and the attraction to having to leave. What was the motivation behind it? And can we see whether this is something that we can start discussing a little bit? Thank you.
Okay, fantastic. So I'm actually originally from Portugal. So Portugal is a small country in Europe. It has been considered in terms of the ranking within Europe as a low-income country for many years. We've joined the European Union back in the 80s. That helped our country boost a lot our economy. And this is about the time when I was young, when I was growing up, but still it was not soon enough for me to have the right opportunities. So when I was at university, our country was still not very well developed. We still did not have the needed infrastructure, and I wanted to be a scientist. And what helped me was that there was this program from the government with full scholarships for MSc and PhD students, and that was fairly new. And they supported me to go spend some time abroad. So I did not have too many opportunities in the country, so I just took it straight away, and I managed to do my PhD in the UK. And from then onwards, I had the skills, I had access to fantastic infrastructure, many labs, molecular training that I didn't have in Portugal. So genetics was not a thing. I could not get training in genetics in my home country at all. But what happened is, I think something that could be similar to what is happening now in some African countries. I got the training in those fantastic techniques, but my country did not have the science at the same level, did not have the infrastructure for me to go back. And so I ended up just not going back to my country. Up until today, I just went on. And it's improved a little bit, but this is always the issue. That's it's great for us to spend time abroad and to have skills, but we need to find out a way for these students to go back, and how are they going to implement those skills. They can be training new students. I think that would be great. So I'd love to go back to my country and share what I've learned, and pass that on and invest. But we need specific programs as well to bring that talent back and to help that talent. There are some grants from my country now to try to bring Portuguese people that are abroad, to bring them back and to start their own research labs. So that's something also new. So maybe that is the future that will help bring people back. But it has been quite a journey for me, starting from such a small and not very rich country, and having to go through this process of learning. It was a very steep learning curve for me. Sorry, let me think of it. The other aspect, very quickly, I don't know if I'm allowed to touch the gender issues, but also as a woman, it has been very, it has been an awakening call to realize that there are actually not that many women in our field in plant taxonomy, and I never thought of that. But I've realized also that I've become a role model for some younger women scientists, and I did not have that. I realize, or have very few, but I think we are more and more women in STEM, and I think that's a way forward, that we can be positive role models for the next generation, and I think those inequalities will also get shifted very soon.
Thank you, and I think that speaks to us as African students and scientists working in Africa, having to look for further education in your country, not finding it, having to leave to go study in another country. And when you're fully educated and you cannot go back because there are no institutions that need you in terms of that capacity. You're too advanced or too fully grown. But I'd like to turn over to my co-panelist here, Sally, for your intervention in this area. Yes, in terms of, somebody has asked, in terms of samples which have, what about the resources that were taken away before the ABS and Nagoya protocols were, how can those benefits be brought back to the people where these samples were collected from?
You know, the thing is regarding the access and benefit sharing context, there's a lot of different perspectives from everyone. But when we look at the samples that were accessed pre-Nagoya, in my thinking, instead of having punitive measures for people who have taken these samples or accessed these samples before the laws are there, we need to create a room where we are advocating for more of restorative measures. Because if we talk about it in terms of how can we take back the benefits, there's already, in terms of even a Jedi perspective, there's already so much that's been taken from us without even trying to like quantify it even in terms of a monetary benefit. So you can't look at it like that, because if we're talking about it from that perspective, we're gonna go back to pre-colonial days when people came on their ships, they discovered things when there was already populations existing. Because you see, we had people from the global north coming and discovering species and things that were already here and naming them and getting like the credit for naming them. But that doesn't mean that there weren't people living in that particular, you know, environment or that particular society. The only difference is that the names they had for those things was in their traditional language. So if we want to try and quantify or talk about how the benefits can be brought back home, it might be a bit hard to do. But what we can do is maybe have restorative measures in place where people can declare these samples were taken before ABS came into place. And then after that, we can now talk about how do we move forward? How do we stop this from happening? And on top of that, now we can look at it now case by case basis, where there was commercialized benefit and then where there was the non-commercial. Because if there's non-commercial, then you can plug in the providers and then you can collaborate with them and then there's an exchange of knowledge. But if it's commercialized, then we now have different sanctions and different procedures that need to come into play. But you can't look at it in terms of just quantifying it. It has to be looked at from different perspectives.
And here I'd like to turn to Professor Lars, who has collected samples from Asia, from Africa, from Europe. Some have been left behind, some you have moved with them to institutions in Europe. How has that worked and what is the experience and what is the benefit, and your comments on that?
He needs to be unmuted.
I think you're muted.
He needs to be unmuted by the host.
Please unmute the Professor Lars.
Yes, thank you. I've seen, the first year, I mean, I went to the tropics to collect samples for my for my research was in 1994. So that's what, 29, well, almost 30 years ago. And I've seen policies change over the years, and I think that's a good thing. I remember going as a PhD student into the field with very experienced botanists from Europe, who would actually, you know, like while collecting, for example, find a fruit, and they would say, you know, that's a nice species to have in our greenhouses, and you know, and they would simply put some seeds in a dirty sock in their suitcase, you know, and take it out at home and plant it, which I would now say is well, let's call it a colonial attitude, isn't it? And you could also argue that's from the love of plants, which undoubtedly these people had. You know, they adored these plants, they wanted to have them in their home botanic gardens, for example, but of course it was totally without any respect for the local country, the local people where these seeds were taken from, and that kind of behavior, I think, well, at least from my perspective, has been effectively eradicated. Where you know, any country in the tropics that I would go to now to collect. You know, I have to have local collaborations. I have to take the Nagoya Protocol into account. I have to apply for collecting permits. I have to apply for export permits, etc., etc. And some colleagues, sometimes myself even, you know, complain about that, but because yes, it does involve some paperwork, but I think in the end it's all for the better. Now, another thing I wanted to say about collections, Anne, is that we were together last year in Kenya on fieldwork. So we collected specimens, we collected duplicates. Of course, duplicates and preferably the best duplicates will be left behind in Kenyan institutions such as Herbarium EA. And then duplicates are also taken home. And of course, as was said earlier, also by Anna, this has happened in the past. So since, let's say, 17th, 18th century, European botanists have been collecting a lot, and as a result, institutions like you, for example, have gathered 7 million of specimens. Now, adhering to protocols for collections that we collect these days, that's one thing. But I think another part of making research for African young students more effectively is a change in attitude in these European institutions, such as Kew or such as Naturalis in Leiden in the Netherlands. Because what I feel is that these institutions are simply, let's say, throwing away the responsibility they have for the collections. To give you an example, I was at Naturalis last week, which is a herbarium with almost 6 million specimens, so a bit smaller than Kew, but still one of the key players in terms of biodiversity research. And this herbarium is just hugely understaffed, which has an effect on lots of things. For example, if you want, also from Africa, if you would want to have a loan of specimens, or if you want to go there and have access to the collections, already there's an impediment there simply for the fact that, these herbaria are understaffed and making these collections therefore less accessible. Or another aspect is the fact that many of these herbaria have digitized the collections, which in itself is good. Digitized collections through the internet makes collections accessible for anyone, anywhere in the world who has an internet connection. But I would say digitization is only the start, because we are in the field of systematic botany, and we keep on improving our classifications. We keep on describing biodiversity, especially from tropical areas. So in other words, there are many of these millions of collections in the big herbaria in Europe and the United States, which the information for which will continue to be updated. And if you don't have staff and you digitize your collections, this information on the internet will be outdated. And in fact, I know many cases where this is already the case. And I think this is an important responsibility for institutes in the West and in Europe and North America especially, which is not realized well enough. And it would be good if also from Africa, people would point these institutes at their responsibility. I mean, I'm doing this myself from within Europe, but I think this would greatly add also to data quality and make these institutes responsible, which they really should be.
Thank you very much, Professor. I'm just stuck at the point where people would put seeds in a dirty sock and ship them out of the country, and this was a practice 30 years ago. But my question is, maybe many of us are still doing it, and maybe we still have sort of biopiracy happening. And that's a question I'd like Sally to mention, that maybe the few are the ones who are caught. Maybe our people at the borders don't know what to look for, and therefore some of our material is slipping by. But I'd also like to hear the perspective from Dr. Anna on the role of a taxonomist in a project like African BioGenome Project, because we want to sequence 100,000 species, and we want to know what they are. What are the roles of systematicists and taxonomists in a project like this? Thank you.
As I said, okay, sorry. As I said earlier, I think the realities and the practicalities of policy and actually doing the science are very different, because when I first started out in my career, I would hear about situations where people put samples, seed samples in dirty socks or vials in their travel bags, and it would blow my mind. But then I got to understand the thinking behind it and how scientists at the heart of it want to fast track the results process. They want to accelerate having results and making discoveries and making publications. So in terms of, is biopiracy still happening? Yes, very much so. Even the sad thing is, even amongst us as Africans, we still have people who are orchestrating biopiracy, because you sometimes read on the internet different stories about samples that were shipped somewhere, and you begin to wonder how it happened and the regulatory offices involved. So ideally, how we can make this stop is the same way Professor Laz is saying, Dr. Laz is saying, is highlighting and pinpointing out these situations. Also within institutions, one of the things I came to realize is, you talk about Nagoya, but the people who know about Nagoya are in fact the people at the top level. So it has to also have a grassroots sort of situation happening where people at the very bottom, the technicians who are operating and sequencing the samples, they understand if Prof Muigai brings for me a sample, I can ask her, hey, this is the checklist I have from the health and safety office. Where is the MTA? Where is the PIC? Where is the MAT? Because ordinarily the situation that would happen is, a technician will get a sample and he'll be asked to work on it. He will not ask any questions. So it's an issue that will be determined later at point of publication or point of declaration of results that you understand the biopiracy has happened. So that happens within the institutions. So we have a responsibility to educate people from the grassroots level to make them understand this is wrong. Because as you've said, biopiracy is not the guys with the guns. It literally happens just on a whim of day-to-day science. So we have a responsibility to hold people accountable when they commit such actions. And even when it's done, we also need to have, yes, punitive measures, but restorative measures, even at the institutional level, because sometimes you have collaborations that are close between institutions, and someone can send a sample really quickly between the interactions you're having differently. So once you find out that, you have a sample and maybe it doesn't have the right documentation, start to look at the restorative measures. Don't just continue the work. Talk to your legal, talk to health and safety. Try and get out of that situation before it gets to the very grave levels, because that's really what's lacking.
Dr. Anna, on taxonomy and systematicists.
Sure. Thank you, Anne. So I would like to start by saying that plant taxonomy is usually seen as the science of just saying what the plant is. So going into the field and say, this is this species, this is that species. But to clarify, plant taxonomy actually covers, among many things, identifying the plants, naming the plants, describing species, and characterizing the species. So these three things are, all three of them, very important parts of our work. The identification, because you get a plant that you don't know what it is, and someone who knows plants, who has that knowledge, can help tell you if that plant has already been described and characterized, or if it's new to science. It can give the name, it can tell you which plant family it belongs. Then if it is a new species, and if it needs a new name, then we're also able to put the right name to it. And if you think of how many thousands of species there are in the world, this aspect of the ambiguity is not small. So the ambiguity in the name. So people complain that taxonomies change the name of plants all the time, or that you have to look at the historical literature to find out the correct name and follow rules of the code of nomenclature. It seems very heavy, like a big burden, but it's necessary, because you need to make sure that when you say the name of a plant, that you know what biological characteristics, what geographic characteristics are assigned to that name. It cannot be ambiguous. And the importance of that also relates to the local names. So local names are very important. I really like the talk by Sally about this, but we also need the plant taxonomists to come in and help again, take down the ambiguity, because unfortunately, some local names refer to different species that are very similar. We know that that is the case. So we do need a scientific name, and we do need a scientific framework for the sampling, because unfortunately, local names can't always be fully relied on when things very similar are just given the same name. And then the third aspect of our work, which is the characterization of species, is something people don't always realize that it is part of our work, and it's so important. So providing a description of a species and that we publish in floras or in journals, when we do a revision of a genus, when we do a monograph, that information is going to have a lot of, there's going to be a lot of biological information in that description that can help with further studies. So it can help evolutionary studies, it can help character evolution studies, it can help understand phenotypes, it can help understand the morphological variation within the species. And all of that comes from the work of a taxonomist that spends hours in the field, in herbarium collections, in living collections, looking at all possible plants of that species to make sure that the description encompasses everything you can think of. How does the leaf look like? What color is the flower? And that's essential information for any project moving forward. So taxonomy can be the basis of many projects. For a project like this, and I think it's a fantastic initiative, I think it will be very important. It is very important to collaborate with plant taxonomists in the projects and to train as well. So if there are people in Africa interested in collaborating on this, it would be fantastic to train more people to do this part of the work, to help certify the samples, to help give a better biological context to the genomic sequencing, and to make sure that what you're sequencing really is what you think you are sequencing. So I think in the future, if I would be very happy myself to collaborate in whichever way, through my own research or through enhancing training. And just as a side note, I've gathered some preliminary data from surveys we've collected around the world in terms of taxonomic skills availability in courses of taxonomy. And we have evidence that African continent has less availability of plant taxonomy training opportunities. So there's clearly here what I would say a challenge as well as an opportunity. So a project like this, the Africa BioGenome Project, could make a fantastic time and momentum to enhance these courses and to get to train more people and get to African continent at a similar level or to other continents when it comes to local taxonomy skills. So, and I'm here to help, and I'm sure many other colleagues in Africa and outside of Africa would be happy to collaborate with that, within boosting those skills within Africa.
Thank you very much. Dr. Anna, you've raised a significant point, because at the point where we're sequencing species, we don't want to sequence a species and just to realize that you collected, something that has already been sequenced before, or you collected the wrong species, or that species is not, is not as useful as you thought it was because it was not properly identified. And this points to the role of taxonomists. And I'd like now to open the floor to questions online and questions here for Professor Lars, Dr. Anna, and Sally, who is here with us. Anyone? Dr. Christian will start. Yes, go ahead.
Yeah, thank you very much, Prof. Ann, and thanks, Sally, and all other participants here. Yeah, we heard a lot, Sally mentioning the restorative measures regarding sample collected before the application of the Nagoya Protocol. Yeah, that is something very important, and that is something that we all need to understand. And the practice is that even if you have samples which were collected before the Nagoya Protocol are now sitting somewhere in your biorepository, you no more have authorization to share it or to use it as you want. You have to regularize the situation of those samples. And if the samples were moved, let's say, from Uganda to Tanzania and now sitting in Tanzania, if it is livestock, the Department of Veterinary Services from Tanzania is having authority on that. wherever it was coming from. If it is wildlife, it should be Taliri having authority on that for you to use and to share the samples. But now the issue locally, you can use locally after the authorization from the Taliri, and Taliri will have responsibility to know where the sample were coming from and also to seek authorization from the original providing country. So this is the process of restorative measures to ensure that those samples are not just useless, we cannot discard them, but if we need to use it to contribute to science, to knowledge, to discovery, this should be the process and how we use it. And on the sharing of the case of biodiversity, we also know that most of the time locals or local scientists are also contributing a lot. Sometimes because someone is giving me $1,000 for flight to go somewhere, etc., then I quickly or have a grant, few $1,000, a scholarship. I just think that I can quickly sample a few things, put in my suitcase, and go to another country and do the work without compliance. Even when we are local, national, we still have to seek for authorization from our national authorities before we move samples out of the country. It's not because I'm a student, I have a scholarship, that I'm authorized to fly out with the material as we want. And I saw also a question coming online about open access. Someone was requesting, or asked the question about most donors requesting open access to data. But it is also clear, it's very important to know that open access doesn't mean always free access. And open access doesn't mean authorization to do biopiracy. Wherever the sample are coming from, whatever context or is the grant contract, whatever is the grant contract, you have to comply to the national and international regulation in matter of access and benefit sharing. It is after that, in the contract, they pick and mark the MTA. Now the country will decide which aspects of the material, DSI, for example, or associated traditional knowledge should be accessible from the different partners. Thank you.
Thank you very much, Dr. Christian. And you've just raised a question about samples that are in Africa. I tend to have this perception, and Sally, you and Dr. Christian, you can let me know that Nagoya protocol, the framework was sort of like to prevent samples from leaving Africa and going to non-African institutions out of the country. But it didn't consider, or very, very much, the possibility of sharing within Africa. So even moving a material from Kenya to Uganda or Kenya to South Africa might be more complicated than me shipping it to Ghent, University to Lars, and then he ships it now for me to wherever. Is that a belief, or is that the actual truth?
No, the ABS normal is not to prevent sample from being shipped outside. It's just to make sure that research is what is done in full compliance of the national and international regulation. But the role of ABX, in fact, is to facilitate access first, to facilitate access in full compliance, and to make sure that science is still going on and discovery is still going on to support first the national, who have been the custodians of the genetic resources from generations. And another aspect, for example, what we have done at URI, because there are also been some grants where, let's say, University of Nairobi is having a grant and sourcing material from different parts of Kenya or from other countries, for example. And in those cases, you have bilateral agreements between the user or the grant holder and the different partners, with no mechanism for partners to collaborate among themselves. Imagine if you are working on we mentioned sorghum this morning. You can be picking sorghum from Tanzania, from, let's say, Ethiopia, from Mali, or I don't know where. And if that work is just to be doing some genomic works and discovery development from ICRISAT, for example, what is the mechanism to ensure that the partnering countries also are using the information efficiently to improve. That's why we came out with a kind of local multilateral agreement. How do we call it again? Yeah, it was the multilateral, just a kind of community of practice among ourselves, among partners, local partners, to make sure that that same sorghum, which is developed within the region, can first serve us before it is the information is also used globally.
Sally, there's a question on DSI. Can you tell us what it is and how this all applies to a project like Africa BioGenome Project?
I'd just like to add on to something regarding your question. Generally on the notions of ABS and access and benefit sharing in Nagoya. Ideally also, Nagoya is also giving countries the autonomy to decide the means and access of genetic material in their country. And I'd like to point out a very sensitive fact, which is in the inclusion.
I think there was either internet or loss of power or something. So just give them a few. Okay.
Dr. Thank God, are we back online?
Yeah, I think we're back because maybe there was a. I'm not sure what it is.
It was power.
Yeah, power. Yeah. All right.
Okay, so I'll just repeat. What I was saying is Nagoya also exists to allow countries to be involved in matters concerning their genetic resources, and it's a very sensitive issue, because I'd imagine a situation where you're doing research on, let's say milk, and then or produce, and you find there's aflatoxin in it. Kenya would not want to find out that there's aflatoxin in their genetic material on a publication. That's why it's important to involve them. It's really, at the helm of it is a consultative process whereby people need to exchange and consult and also determine like the best way forward regarding certain situations. That's just something I wanted to point out. Now, regarding DSI, so digital sequence information, that is what DSI is. As I mentioned earlier, is a very controversial issue. So digital sequence information ideally deals with once the materials have been sequenced and the data is being transferred, there's come a lot of issues regarding benefit sharing on how to track and trace. Once a sample has left, for example, Kenya, and then it's been sequenced, and then these days we have forgive me for lack of being a scientist, there's ways to manipulate sequences and change. You don't need the genetic material or the sample to do your work. So there's a lot of controversy around that. So the biggest issue we face with DSI is how to track and trace the benefits once the sample has moved and the sequences have been shared, because as I've come to now understand that you can actually do anything when you just have the digital sequence information. And I can let Christian further expound on other controversies from a scientist's perspective, because mine is purely from a legal and policy side. So a lot of countries are having different positions on this. And as I said, when we've had the CBD meetings, like for example, we had CBD meetings here in Nairobi, there were those that were happening in Geneva last month. We're still yet to find consensus on the issue, but we have groups coming in to discuss how that it cannot be considered under the harmonized, it can be considered under the whole scope of benefit sharing. It needs to be looked at from a different angle. So it's still a continuing topic.
Yeah, just to add on that, I think she was mentioning about genetic engineering and all the potential of artificial intelligence, what we can use. It means sometimes you don't need to go to the field to source the material to be able to do your work. You can have the sequences, you can download from anywhere, start doing all the engineering you want, etc. And at the end, you can be able to come out with a specific sequence, whatever, which is used later. But now the issue is, how do we track and trace the original source of data that you access online to do your work effectively? And how do we make sure that the original providers of those data are really having also benefit from whatever should be coming from it. So the discussion is on, and a lot of discussion. I'm sure a lot of things will still be done, but now the African group of negotiators, they're having their positions. They have the way forward. It is a negotiation, as Salim said, but we need to have science moving on. We don't have to stop and wait for regulators to take the decision, but we need to have a kind of control measures to make sure that we continue discovery, we continue supporting our populations, whether it is in the domain of health or in the domain of agriculture, and we need to harness the potential of genetic resource diversity that we have in Africa to feed our population. Thank you.
Thank you very much. We're coming to the end of this particular panel session, and you'll agree with me, it's been very, very exciting. Last words from Professor Lars, Dr. Anna, Dr. Christian, now that you've joined our panel, and Dr. Ms. Sally here. Last words. We'll start with Professor Lars, and then we go to Anna, and then Sally and Dr. Christian.
Thank you, Anne. Last words. I look forward to the future. That would be the most important. Actually right now, I get a view on the room where all the participants are, and it's just very exciting, that to see that so many people are embracing this project, are engaging in it. And all I can say, I'm just very much looking forward to continue to collaborate. I mean, in the first place with you, Anne, and the two the students that we co-supervise, also with Dr. Anna at Q. And I'm always available to for further collaborations. Perhaps it's good to say that so the students from Kenya that we are supervising are supported by a grant from Ghent University, which is these are called sandwich grants. So the idea is to support students from the global south and to both have them be trained in this case in Ghent, but as well at the same time immediately during their PhD project apply and use their knowledge which they are gaining in their home country. And I know there are several more European institutes with similar grants. So yeah, my final word would be just anyone looking for help, for collaboration, for anything, just contact me. Thank you.
And Dr. Anna, as you give us your parting shot, how can we encourage African students studying in Q to come back and transfer knowledge and be based in Africa?
I think it will have to come from a change of mindset, of also understanding how exciting it is to go back to your own country and to build something from your knowledge. And so I think that could be encouraged more, for students to understand that they can go abroad and then come back and have the excitement to go back and build something, but that needs to be matched with local institutions welcoming these students as much as possible, supporting them to stay in the country. The financial aspect is not to be overlooked. Students come back and they're going to need to pay their bills. So try to find ways to support them, to give them a little bit of employment when they're starting, or grants. And so it needs to be from both sides, from the students wanting to come back and feeling it's exciting to come back, and for everyone on sides to welcome and embrace the students and say, okay, share what you've learned and let's do fantastic and exciting things from it. And I think it's great that this is going to be African-led. This is my last comment from the session as well. It's fantastic to see there's such an initiative to be African-led, and it's time for Africa to tell the global north, what do you need from us to move forward? Because I think a lot has been taken away, and it's the time to say, well, how can we help? How can we support? How can we give back? So this is the moment to tell us, as well as supervisors, as mentors, as people who have access to resources, to labs, to infrastructure, how can we support students? How can we help train more Africans to go back and take more back home?
For me, I guess my comment would generally be to everyone who's tuned in and everyone who's in this room. I feel like there's a lot of uptake and opportunity for people in this space. And I feel like going forward, we need to have more collaborative spaces. So as you go into your individual organizations and individual spaces, I just want to encourage us to build a habit of collaboration and discussing even with the regulators, the compliance offices within our institutions, because it's very important for us to keep having multifaceted insights on these laws and, on these procedures. And there's no way for the scientist to understand the policy man if there's no conversation. And for me, like, I've somehow started to understand at a grand scale the science, and it's helped me be able to push for documents to come out faster because you understand the urgency. And also it's helped the scientists like Dr. Christian here, understand the policy and even be able to go and talk to other people. So I think it's important for us to continue having that exchange, that interdisciplinary exchange, because it's the only way we'll be able to get the science right. Thank you.
Yeah, thank you. And Sally finished by saying getting the science right. And that is very, very important to understand that we are doing science to support our communities, and all the regulations which are coming is not to prevent us doing science. So we should not be afraid by being compliant to the regulations. We just need to make sure that, as she said, we plan and anticipate on a few things, apply for the research permit, and approach at your institution level who is in charge of that, and at the national level, particularly the national focal point for ABS or the National Competent Authority, we should be able to advise on the way to fast track compliance document. And it will also be very good for us as AfricaBP and particularly the LC committee to try to mobilize resource and continue this education, because ABS is mostly about educating people on how to do things right. And I saw the case of focal point ABS Cameroon, for example, who is having some specific programs in university to train peers. She's also a scientist, but she trained people on how to go about permit, doing research, etc. No research should be stopped because we are afraid of compliance. Let's move ahead together. And I'm sure that AfricaBP has huge potential to continue being that Pan-African leader in terms of compliance and LC. Thank you.
Thank you very much. I want to thank our panelists, Professor Lars from University of Ghent, Dr. Anna from Kew Botanical Gardens, Sally from ILRI, Dr. Christian from ILRI, for that very, very exciting and interactive panel session. I think it was very, very insightful. We have learned quite a bit, and this is just the beginning of a conversation that we should have. I think my take home is interdisciplinary research. Don't stick to your corner as a bioinformatician and decide that you're enough. You need to bring in a taxonomist, a lawyer, another scientist from another area, so that you can be able to plan better the research, as Dr. Christian has informed us. So we will take a 45 minutes lunch break. We will revert here at 1:45, and in-house we will have an announcement of where we're going to have our lunch. The online participants, I wish you a very, very good lunch, and we shall meet you 1:45. And thank you once again. Let's give all our panelists a resounding round of applause.
Thank you to all the speakers this morning. We're going to break for lunch, and lunch will be served at the poolside, which is to my right this way. To those who have not been here before, we just follow each other and go to the poolside, and we're back here 1:45.
And let me invite you all to visit our stands, our exhibitor stands, who are our partners, our sponsors for this particular event. They're just outside this room. Please pay a visit to them. And during the lunch break, we will also be able to screen videos that our exhibitors have shared with us. And do take a minute to watch that. And thank you.
Yeah, Professor Ann, just to confirm, lunch is 1 hour, right? Because 1:45 might be different across multiple regions.
So from now, we are counting 45 minutes.
Okay, 45 minutes. Okay.
45 minutes from now. So in the local time, it's 1. So we're going to convert here at 1:45 in 45 minutes.
All right. Thank you.
Thank you. Thank you all. And please watch our videos from our exhibitors, which will be screened right now. And those of you who are here physically, please take a minute to visit our stands. Thank you.
Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology
Excuse me.
to lead life science through intelligent innovation.
Excuse me, you can leave your stuff here. The security will lock the doors once we all leave. It will be secure.
MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DMB-Seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of Ingaba Biotech, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of Ingaba Biotech emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When Ingaba Biotech officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, Ingaba Biotech became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At Ingaba Biotech, we use a variety of Zymo kits for DNA or RNA isolation, as they are not only simple and reliable, but effective and efficient, making your experiments hassle-free.
Ingaba Biotech has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. Ingaba Biotech has promoted research in the region by providing quality products to researchers. To many more years, Ingaba Biotech, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At Ingaba Biotech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have 0 DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Mackleneck, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of AfricaBP emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When AfricaBP officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, AfricaBP became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At AfricaBP, we use a variety of Zymo kits for DNA or RNA isolation, as they're not only simple and reliable, but effective and efficient, making your experiments hassle-free.
AfricaBP has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. AfricaBP has promoted research in the region by providing quality products to researchers. To many more years in AfricaBP, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At AfricaBP, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have 0 DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea, and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of Ingaba Biotech, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of Ingaba Biotech emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When Ingaba Biotech officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, Ingaba Biotech became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At Ingaba Biotech, we use a variety of Zymo kits for DNA or RNA isolation, as they are not only simple and reliable, but effective and efficient, making your experiments hassle-free.
Ingaba Biotech has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. Ingaba Biotech has promoted research in the region by providing quality products to researchers. To many more years, Ingaba Biotech, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At Ingaba Biotech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea, and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Makelneck, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of AfricaBP emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When AfricaBP officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, AfricaBP became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At AfricaBP, we use a variety of Zymo kits for DNA or RNA isolation, as they are not only simple and reliable, but effective and efficient, making your experiments hassle-free.
AfricaBP has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. AfricaBP has promoted research in the region by providing quality products to researchers. To many more years in AfricaBP, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At AfricaBP, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of Ingaba Biotech emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When Ingaba Biotech officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, Ingaba Biotech became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At Ingaba Biotech, we use a variety of Zymo kits for DNA or RNA isolation, as they're not only simple and reliable, but effective and efficient, making your experiments hassle-free.
Ingaba Biotech has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. Ingaba Biotech has promoted research in the region by providing quality products to researchers. To many more years, Ingaba Biotech, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At Ingaba Biotech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DMB-Seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have zero DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a
Welcome to the 20-year anniversary video of AfricaBP, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of AfricaBP emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so.
When Ingaba Biotech officially opened its door for business in August of 2002, we primarily offered primer synthesis as well as single DNA sequencing services. In 2007, Ingaba Biotech became the first company in Africa to offer NGS services based on the 454 sequencing platform, the GSFLX. This allowed our customers across the continent to be able to do whole genome sequencing for bacteria and many other microscopic organisms.
Many experiments require high-quality DNA or RNA, especially for downstream analysis. For example, SNP genotyping on the mass array system requires high-quality DNA. At Ingaba Biotech, we use a variety of Zymo kits for DNA or RNA isolation, as they are not only simple and reliable, but effective and efficient, making your experiments hassle-free.
Ingaba Biotech has a footprint all throughout sub-Saharan Africa, and the way a company makes it happen is by having a very good logistical department. We have a dedicated team of staff members that does imports from all around the world and exports into sub-Saharan Africa.
The service department started in 2016. We service, maintain and repair all the instruments that we do supply. We have field service engineers that can go on site and do our services, and we've been growing ever since.
I joined the company 9 years ago, and as we celebrate 20 years of existence, I'm glad that I chose the best path for my career. Ingaba Biotech has promoted research in the region by providing quality products to researchers. To many more years, Ingaba Biotech, your African genomics.
Science is our passion and business, and so we strive for perfection. But it does not end there. At Ingaba Biotech, we also care about our communities. And for some years, we've been supporting the Mukondeni pottery in Limpopo. And also in the same village, we've been supporting a young entrepreneur to advance his business services. And recently, we've acquired this farm in Hammanskraal to develop.
Yeah, welcome back. And we can just allow us 2 minutes for those who are still outside to take their seat. Then we proceed.
Come and load for us the presentation.
Yes, good afternoon, everyone, and welcome back. I know generally after lunch, there is a tendency to doze a bit, but I promise you this afternoon will be very active and very interesting as well. And we have this afternoon 2 sessions, one on sample collection and sequencing, and the second one which will be on the ethical and policy and ethics and policy, yeah. And we have very nice presenters today, this afternoon. The first one being Priscilla. Priscilla? Yes, please. Priscilla is from the Kenyan Wildlife Research and Training Institute. She's based in Naivasha. And she's an experienced scientist with expertise in microbial bioprospecting for applications in agriculture and industrial enzyme in academics, research, and development. And she's very skilled microbial biotechnologist. She's done a lot of work on the biocontrol, etc., and of course, supporting others on compliance. So she has a vast training and hands-on experience on negotiating access and benefit sharing as we discussed this morning, and she's our regulator from WRTI from Naivasha. And in terms of contract, multilateral agreement, she has a lot of things to share with us and experience in policy development, community engagement, etc. And this afternoon, Priscilla will be presenting to us biodiversity access and utilization, regulatory frameworks, opportunity and challenges. Please, Priscilla, you have the floor.
Good afternoon. I hope we'll remain awake and follow what we will be saying. So kindly let's listen and work together. It's not an easy route, but we will work together. I will try. So as he has said, my name is Priscilla Mutungi. I work with the Wildlife Research and Training Institute. It's a relatively young institution, almost 2 years old. It started in 2021, carved off from Kenya Wildlife Service. And our mandate is to coordinate and undertake wildlife research in the country, in Kenya. So the institute stands a better chance to collaborate with these projects on matters wildlife genomics, which we've not done quite well as a country. We don't have so much information about our wildlife genomics. And therefore, if we collaborate with the project, we'll do a lot and a great deal for our wildlife. So I will just be brief. And we will talk about, first I was told to talk about the regulatory bottlenecks. But from my point of view and my point of understanding is that we do not have bottlenecks. What we have are opportunities and some challenges in undertaking the work. So I will not talk about bottlenecks, I will talk about opportunities and challenges. My outline will be like this. I will do some brief of introduction, then an overview of the regulatory framework. Some of it has been done by Sally. The access and utilization of biological research procedures in Kenya, what we have in place, the existing infrastructure in biodiversity genomics, most of it has been said, the opportunities and the challenges that exist in this work, and then some bit of recommendations. We'll talk about it. So this term biological diversity, or in brief biodiversity, was defined by the CBD way back in between 1988 and 1993, when the convention entered into force, as the variability among living organisms from all sources and ecosystems. It is not only the living organisms, but also ecosystems, to include species diversity, genetic diversity, and also ecosystem diversity, because you have different ecosystems. And from a Christian point of view, I'm a Christian, and those who are not Christians, I think the Muslims also have the same theory, that all biodiversity was created by man, by God, including man. We are part of the biodiversity on Earth. And man was the last creation, the last biodiversity to be created. And this last born was given a lot of powers to control all the other biodiversity. But then that power, how it is being used and how it has been used, has become kind of dangerous to the rest of the biodiversity which was created before man. And therefore, biodiversity richness varies from country to country, and even from ecosystem to ecosystem. For example, in Kenya, we have a lot of biodiversity. We are a mega biodiversity country. We have the marine ecosystems, which have different biodiversities. We have the forest ecosystems, the mountain ecosystems, our unique Rift Valley lakes, which have a very unique biodiversity. We also have a desert ecosystem, freshwater lakes and rivers, and arid and semi-arid regions, which also have their own unique biodiversity. And this is distributed across the whole country, all the way from the coast to northeastern. So some of the challenges facing biodiversity, the most important one is the population increase. The more we increase, the more we need industrialization, the more we need infrastructure and development, roads and all the way. Agriculture must be increased, and this agricultural production is becoming another threat. We are moving from mixed agriculture to monocultures, which is also becoming another threat to even the production of agriculture. Technological advancements, like including lighting. We need lights at night to light our paths, to light our streets, and that has a great impact on nocturnal biodiversity. At night, they are supposed to be awake and doing their business, but then at night is when now these bright lights are shining everywhere. What happens to them? During the day, they are supposed to be asleep. At night, you bring them the light again. So what has been happening? That is one of the impacts of our technological advancements. Then introduction of alien invasive species, which take over the native biodiversity. And not forgetting anthropogenic effects, which are also affecting the existing biodiversity. And therefore understanding the status and ecological roles, and of particular is the ecological role of the different species in an ecosystem, how the species interact. Every species has an ecological role it plays. But have we understood all this? And an example is some insects which are detrimental to agricultural production, like sassaflies. People would think wherever there are sassaflies, we would need to eradicate them. But have you understood before you eradicate what ecological roles the sassaflies play? The ecological connectivity of biodiversity and the ecosystems. These are all challenges to biodiversity, and a lack of critical mass of experts to understand and map out all these challenges is what is actually stressing our biodiversity, and we are seeing a lot of losses in biodiversity. So to address some of these challenges, legal frameworks have been put in place all the way from the global to the local level. And at the global level, we have the regulatory frameworks. And the most important one for biodiversity is the Convention on Biological Diversity and its two protocols, the Nagoya Protocol on access and benefit sharing, the Cartagena Protocol on living modified organisms, how to use them and what happens. And now we have the protocol on redress. We have the plant genetic resources, International Treaty on Plant Genetic Resources for Food and Agriculture, and the FAO. that also governs and regulates the transfer and the utilization of plant genetic resources for food and agriculture. We have CITES that regulates trade on endangered species, and so many others. The WIPO treaties, which also govern the utilization of intellectual property assets and related rights. At the regional level in Africa, we have the AU Agenda 2063, which is a blueprint for sustainable development and utilization, including benefit sharing and inclusivity of communities. We also have a RIPO, which guides on utilization and protection of intellectual property. At the national level, and these are not the only ones, we have quite a number of them, regulatory frameworks. At the national level, in Kenya, we have the national legislations. The first one is our constitution, which talks at chapter 2, article 2 of the constitution, not chapter 2, article 2. That gives effect to all international treaties and conventions that the country has ratified to form part of the law. So when we are saying the CBD is part of our law, it has already been enshrined in our constitution. It is part of our law. We also have other legislations like the Wildlife Conservation and Management Act that talks about the protection, utilization, and transfer of wildlife resources. And wildlife is not only animals, it includes plants, microorganisms, and all others. As long as that particular biological resource has not been domesticated, it becomes wildlife. What is not wildlife is only what is not domesticated, and an exception of the human genetic resources. But we have an exception on that, where the resources within you, the associated resources, the worms in you, the microbiota in you, as per the Kenyan law, it is not part of human genetics resources. Kenya has developed systems, so we have, and devolution, resources are devolved. So whenever you are accessing resources at a particular county, you are liable to the policies of that county, because counties have the mandate to develop laws that govern access and utilization of their resources. Down at the community level, we have community bylaws. Some communities have developed community biocultural protocols that govern how access and grant of the rights, user rights, are to be developed. So, and this system is found in most of the African countries because all of us are parties to the CBD. Some of the key issues for legislative policy and administrative procedures, the main issue on these procedures is to provide legal certainty and clarity, such that you as a user, as a researcher, when you plan to access genetic resources from a country, from a region, you have clarity in terms of law, you are not risking, and you are not afraid, and also the certainty that whatever you are accessing, you've been granted officially. And the legal frameworks provide for definition of terms, such that whenever you are going to access, you understand what it is. Like in Kenya, when you talk of wildlife, you want to access wildlife. The Wildlife Conservation and Management Act provides for what wildlife is. When you talk of wildlife, what do you mean? What is the scope? When you are accessing, when it is gene trade, how far does it stretch? When it is biotrade, what are the limitations? What is happening, including emerging issues like the digital sequence information, synthetic biology, which are now the key areas of research. And what I talked about, exceptions on human genetic resources, but now the challenge of associated biological resources. We have cases where people access through health, accessing human stool, and now they isolate microorganisms, which now end up at a commercial scale. So how do you approach such? The law provides clearly for that. What the person is using and commercializing is microbiota, which is not human, so it came from human beings. So the law provides for that clarity. It also provides for the utilization pathway from access when it involves both commercial and non-commercial steps. It is very clear. What are you supposed to do? And where do you go? And who grants access rights to what? It also provides domestic measures that link the provider and the user to understand clearly what you are supposed to do. Also, who has the right to grant you the instruments of business, that is the prior informed consent, mutually agreed terms, and material transfer agreements. Because if you negotiate these contracts with the wrong party, the contract becomes useless. Sally can attest to that. It is not enforceable, and so there is no contract at the end of the day. In the event there is any legal query, you will have no contract simply because you entered your contract with the wrong party. And so as a researcher or as a user of biological resources, you need to understand clearly who has the rights to grant you the user rights and to negotiate these contracts before you start your research. It also provides for post-access measures, the in situ, from in situ, when you collect your materials, to the ex situ processes. What was discussed just before lunch on Kew Gardens, they have our materials ex situ. So the law is very clear. It will guide you when you need to deposit your samples in a repository. You need to clearly define where in the ex situ repository will you deposit, and it has to be agreed and put in the contract, clearly stated, and who has the mandate to do what. It also provides for the databases, the generated sequences, the generated data. When do you deposit? And this is a challenge, as we discussed. The information that has been generated, it is deposited in banks which are not ex situ repositories, which are not in the country, which are not most of them in Africa. How do we develop modalities in line with the Nagoya Protocol that would take care of ownership rights on the use of such data, the retrieval, traceability, and the link to the country of origin? I'm so elated and happy the project is looking into that, because this has been a challenge to Africa in general. When data is deposited in databases that are not in the country, that are not in Africa, and we don't have any modalities, any procedures on how to access and to link back to the country of origin, and after their utilization, how do you share the benefits? That has been a challenge. I'm happy the project is looking into that. So Kenya has put into place procedures, very clear procedures on access and utilization, where we have, I don't know if this is clear, but I can briefly explain. Whenever a researcher wants to access resources from Kenya, you first need to log in, and the first point of entry is the National Commission for Science, Technology and Innovation, NACOSTI, where you get your license, your research license, then grant you the authority. It is the institution that is mandated to grant authority to any researcher. Once now the application has been received and you are given the go-ahead to proceed, then they will evaluate that application to see if it is a biological resource or not. If it is not a biological resource, you are directed to the right ministry. If it is a biological resource, then there are two categories. One, if that particular application applies to the Annex 1 FAO treaty, all the resources that are listed under Annex 1 are handled under CALRO. If it is not, then you are directed to the right institution that will grant you the access and benefit sharing agreements, the PIC, the MAT, and the MTA. And for wildlife resources, you are directed automatically to the Wildlife Research and Training Institute. When it comes to forest and genetic resources, you are directed to Kenya Forest Service. When it comes to livestock resources, you are directed to DVS, the Directorate of Veterinary Services. And therefore, once you are granted those agreements, you are supposed to now get a permit, and that permit plus the NACOSTI permit, now you make an application to the National Environment and Management Authority, that is NEMA, for the grant of an access permit. It is at that point, once you get the access permit, that you are now allowed to proceed with your research, because you have an access permit and a grant of rights to access the country's resources. This access permit granted by NEMA is what is transformed to the internationally recognized Certificate of Compliance, the IRCC, that is posted to the ABS clearinghouse for the international monitoring on utilization of the resources. So the procedures are very clear. We, in this chat, we have not included WRTI because we developed it before WRTI came into effect, but we have already corrected that because that function moved from Kenya Wildlife Service to the Wildlife Research and Training Institute. So what opportunities exist and the challenges? One, we have the opportunity because the law under the CBD Article 9, 15 to 19 on access, generation of resource, biotechnology, the share of the benefits, transfer of technology, all of them, the Nagoya Protocol and the WIPO treaties, all these international regimes, all provide for what you are supposed to do. That is a big opportunity because the law is very clear. It gives you the roadmap of what you are supposed to do. In institutional IP regimes that provide for coordination and how to use the resource and the IP that results from the use of the resource. The Kunming-Montreal Biodiversity Framework that was negotiated and agreed upon last year, it provides also for all those processes, what you are supposed to do. The UABS guidelines on the coordinated implementation of the Nagoya Protocol, very clear for all the African countries. So everybody should be aware of this, what the UABS guidelines provide for. The national regulatory frameworks, all of them. The infrastructure we have, both in human capacity, though it is not so much, and the facilities, but we have the basic to undertake research. And also we have a minimum critical mass of people who are trained, and the project continues to train more people. And when it comes to infrastructure in capacity, in Kenya, as of 2022, we had 68 universities registered and operating in Kenya, 35 of them public and 33 private. Several other research institutions also exist, including the CGIR centers and TVET institutions. These are the polytechnics. And all these undertake biodiversity and genomics programs. So we have quite a mass of people who are trained. We also have some varied infrastructure. It may not be sufficient, or some of it may not be up to date, but at least we have some basic infrastructure. So when it comes to challenges, the first challenge is when I started doing this work way back in 2012, when I joined Kenya Wildlife Service, I've discovered that most of the researchers, unfortunately, do not understand the policy environment in the provider countries where they want to access resources. And this poses challenges because you don't know how you are supposed to plan your work and how you are supposed to move from one step to the other. Also, the emerging issues on biotechnology, including DSI and synthetic biology, the lack of infrastructure for biodiversity repositories. This is a challenge that also was highlighted by Ethiopia. low capacity in biotechnological applications of the generated sequences. Now, currently, the world is looking at the utilization of sequence information to generate products. Where are we in Africa? What have we done? How are we moving? And this is a big challenge. Compliance and enforcement, and then dynamism in science, which keeps evolving from time to time. So as we look at these challenges, we need to ask ourselves one big question. Are we able to use biological resources to generate data, information, develop commercializable products, and then at the same time, achieve inclusivity of all, from the local community person who has never gone to school, achieve conservation goals while enhancing environmental integrity, ensure communities benefit from the intellectual property that is accessed from the resources they have been managing all through their lives, and ensure access and utilization does not lead to biopiracy. We've had Sally talk about biopiracy. Are we able to do that, to achieve that? And if not, where are the gaps? Are they in science, in the legislative processes and policy processes? Is it in enforcement? Or is it with the users and providers? Or someone else talked about communication. Is it that policymakers and researchers are not communicating well? Where is the challenge? Those are the big questions we need to ask ourselves. And ask then, which way do we go? And for this, I want to leave you with this. This saying from Martin Luther King: we must live together. And I add another one: work together as brothers, or we perish together as fools. This is what Martin Luther King said. And so these recommendations, I see I am out of time for the project, and I think they have highlighted them. We would want to see a coordinated approach from the project on compliance, and what they are doing on building critical mass is very important and applauded. Also, collaborating institutions need to consider reviewing their policies to include emerging issues of DSI. Thank you.
Yes, please, another round of applause for. Yeah, as I told you, this afternoon we are going to fly very high, and she's trying to show you that we go higher. And just a summary of what she's saying: let's work together, and make sure that we are really compliant. She mentioned the fact that regulators, those who try to train us, to take us through the ABS, are not against us. That's why she refused to see the bottleneck, but we need to just look at it as opportunities, but what are the challenges associated to it? So it is very important. And she mentioned some of those challenges facing biodiversity and the tools that exist in different countries, both at national and international level, to allow us to really dive deeper into this aspect and make sure that we do the science right. So it is very important really then to follow this, and to be able also at the national level to understand who are the stakeholders that we need to approach, and what is the process for us to make sure that we are fully compliant. So thank you very much, Priscilla. And the second presenter is Acclaim. Acclaim is around? Yes, please. Welcome. We need to load the presentation. It's being loaded. Yes, thank you. So Acclaim is from South Africa, and very good expert in biotechnology, extensive experience from genomic industry. I think he graduated from the Johannesburg, and he began working at Inkaba. That was in 2013. And from there, I think he found the necessity to extend. He came back to Inkaba, And now he's really trying to push. And now he's technical expert and supporting customers in terms of service and really providing top-notch support to clients across the region that is in sub-Saharan Africa. And today he's going to present to us the PacBio SMRT technology overview. So this is another presentation we are going to enjoy and see how they are really supporting us in Africa BP. So please, you have the floor.
Right, thank you. Thank you. Good afternoon, everyone. Thank you. As mentioned, my name is Clay Mwila, and I'm the application specialist for the genomic services, as well as the PacBio portfolio in sub-Saharan Africa. When AfricaBP first sat down with us to discuss how we could actually be partner with them, we knew from the first go that we have to be part of this initiative for what it means and what it is. And then at the time, we were the only company that has had the technology, the PacBio technology in Africa that was accessible. And of course, together with PacBio, we are able to contribute immensely to this initiative, whether through sequencing, providing workshops as we usually do. We're going to do even the next Wednesday, Thursday, and Friday. I want to take this moment and say how pleased we are to be part of the initiative. And to illustrate our further support, as a company, we usually run the annual sequencing competitions where participants from all over Africa can submit motivational letters and videos of the species of interest that they would like to sequence. And then we provide the sequencing free for them. So we have dedicated to the latest competition, not in our name, but just provide all the resources to the AfricaBP community to engage with the AfricaBP committees, and then those that will have the opportunity to sequence for free will be selected by the AfricaBP, and then they will get their stuff sequenced for free. So I want to give you an overview today of the technology behind the smart sequencing, which is PacBio technology. And I hope at the end of the session, you will be able to fully understand how the smart sequencing works, describe key performances of smart technology and its advantages in the market, understand the sequencing flow, which is something for those that have been lucky enough to be selected for hands-on training. They will be taken through the entire workflow in the next coming days. And of course, just dive into a little bit more of the applications that you can use the smart technology for. So now let's look at the smart technology. So what does the smart means? It means single molecule real-time sequencing, which actually observe the single molecules in real time. And then a key innovation in this smart technology is this tiny wells, the tiny wells on the chip. We call the zero-mode waveguides. Those walls are very, very tiny, that even a visible light doesn't penetrate through those walls. When illuminated from the bottom of the well, only a tiny detection volume is created. The orange area there of the ZMW. And this is where we observe these reactions, this incorporation, this DNA synthesis during sequencing. Anything that happens in the blue area, we're not able to see, because why? The light, the walls are so tiny that the light doesn't kind of pass through, barely create a small detection volume. I don't know who's working on that thing. Okay. So you can see the structure basically at the bottom of that wall, we have a polymerase DNA, the DNA polymerase template complex that is covalently bound to the glass substrate at the bottom of the ZMW, and you can see the illumination there. That is where we can see in real time all these molecules be incorporated, and we record that in real time. And then another key innovation is the phospholink fluoroside nucleotide analogs. So we give these nucleotides 4 different colors to easily discriminate them from each other during incorporation. So when as the polymerase takes up those analogs and incorporate them, we get the light emitted, and we capture that light. And based on the color of that, we are able to say as to which nucleotide is that. This is the structure of our nucleotide analogs. In most cases, some technologies, they have this fluorophore that is bound to the base of the nucleotide. Our case, the fluorophore, for ease of cleavage, it is attached to the phosphate end of the molecule. And then for every cycle, obviously, if you get the polymerase, the right base is incorporated, the light is captured, the fluorophore is cleaved off to allow the next base to be incorporated. And like I said, this happens in real time. We're able to observe in real time. And then, of course, you have all of this capturing and everything happens on what we call the smart cell. The smart cell has millions of these tiny wells we call the ZMW, where we are able to, in a parallel fashion, see right into the ZMW as each and every light is captured across the smart cell in a parallel fashion. So basically, as I've mentioned, step 1, get a base incorporation. Step 2, the light is emitted, we capture that light, and then we release the fluorophore to allow the next base to be incorporated and captured, and so on and so on. So of course, now there is another system from PacBio, and then of course you will have different consumables, but the core technology is pretty much still the same. And then you can see there on your far right there, this is basically what you observe from the top of the smart cell, and each and every bit, it's where we get the data, the sequences. So you can imagine the massive amount of reads that are coming out of that. Now let's look at what the smart technology, the performance criteria, what makes this technology so different. Obviously, it's a long read. PacBio smart sequencing is a long read based. So we are with anything from literally 250 bases to 25 kb we can sequence, and then the level of accuracy, it's really extraordinary with the smart or Hi-Fi sequencing, and I'll explain that in a bit in details. As I've mentioned, we sequence these. We are able to observe single molecules in real time, and then with the accuracy of the single molecules, Q30, and then look at the accuracy of the entire consensus read or the Hi-Fi read. And as a service provider ourselves, this is something that we observe in our laboratory, the data that we produced, that we are able to even reach Q50s. And then uniform coverage, we do not have. The smart technology does not kind of have any difficulties when it comes to complexity of the genome or of the fragment. We just sequence uniformly across the region. And of course, something that is really fantastic is the ability of the technology to be able to pick up methylations in real time. So that means there's no bisulfite treatment, different projects, different costs that's required. So as we sequence the genome, the polymerase and the kinetics that involves, we are able to pick up those methylation in real time. Something you do not pay for. So when we send you the Hi-Fi data, you also get a file with all methylation calls across the genome. So what are Hi-Fi reads? I've mentioned a few times the word Hi-Fi. This is high fidelity reads that we produce with PacBio technology. How do we do that? Basically, we start with the genome that we share to the fragments that we probably between 15 and 25 kb long fragments. In that, we basically ligate these hairpin barcoded adapters so that we can distinguish each fragment or sample from the rest. And then the next step will be to add a sequencing primer and bind a polymerase. This all happens outside the system. What goes into the system is a bound complex, a polymerase that is already on the fragment. And right next to it, there is a sequencing primer. And we just load this into SMRT Cell. And then through what we call the adaptive loading, the flat cell, the SMRT Cell is kind of filled with all these fragments. And during sequencing, this is basically what happens. And this is the huge difference, difference maker of this technology. So when we sequence, this molecules kind of turns into a round that allows polymerase to sequence these molecules over and over and over, basically a wheel running through the polymerase, running through the same fragments, producing multiple sub-reads. And what happens is that, and which still happens in the machine. Of course, the nature of polymerase, it's not perfect, right? It incorporates errors there and there and there, which is something that you can see in the dots there. But the difference is those errors are random. And when you can sequence the same molecules over and over and over again, and you take that amount of sub-reads, you collapse them and create a consensus sequence, you are able to flush out all the random errors, and you will be left with one Hi-Fi read that is near perfect. This is the difference with the Hi-Fi difference. And this is the level of what we are able to generate in terms. The more polymerase go over that molecules, the better. But with 1, 2, 3 passes already, we are on Q99. Imagine if you sequence that molecules 20 times, 30 times. The quality is really something that is extraordinary. And of course, the higher the quality of the data, kind of reduces your cost of sequencing, basically. And this is the fun part for me. I love this part. It's just, yeah, I always imagine it in my mind when we do the sequencing. So basically, how do we detect these methylations in real time? So there is a set time that polymerase, when it encounters a normal base, it takes like that millisecond to move on from that base. Like the time is quicker. But when it encounters a base that is methylated, the time it takes for the polymerase to move away from that base, it's extended. And then we look at those kinetics, interpulse durations. By looking at the polymerase performance, we are able to locate the methylation and the type of methylation. So when we send you the data, we send you a file of methylation codes that you can use it whenever time it becomes relevant for your project. So this is really, really fantastic. So that means there's no another project designed for you for bisulfite treatment, cost and all that. You get this stuff free. Whether you say, I don't want methylation, we're going to give you, because it's part of the essay. So let's just look. This is some of the things that those that will be taking part in the workshop will be going through. So I just want to touch base with just a little bit of that part in there. So basically, we're going to do extraction. I know I've heard we've been able to acquire fish. So it's a good sample for Hi-Fi sequencing. So we're going to do extraction, start from extraction, do the library prep, which we call the Smart Bell library, and then do the whole process. But because we don't have the platform in East Africa, which I really believe at some point it will be, and this will also help the efforts of AfricaBP, because at the moment, as I've mentioned, we are the one that provide this sequencing technology to AfricaBP. So the samples that are collected in this region, I hope that one day they will be able to sequence in this region. So we'll definitely that will be helpful, and will facilitate and increase the number of samples that are sequenced in that way. So you can see there, do all the library prep. We'll go through the software. Some of the software we call the Smart Link. The Smart Link allows us to kind of tell the machine what to do. We get the libraries, we tell the machine the type of the library or the fragment size that we have able to generate it, how much the concentration, how much to load, and where to get that information once we have saved it on the system. So we'll go through that software bit. And then, like I said, there's no platform here, so we're going to send that library down to South Africa for sequencing. And then when the data is generated, we will also again make a call to the team so that we organize an online data analysis kind of session. Yeah, again, this is the workflow. DNA, we do quality control, we have to do sample prep, and then all these things that I've mentioned. And then as you can see, at the end of the day, this is what we are aiming for, to have that library so that we can load it into the platform. And then you have seen this already. I'm just going to skip over it. So this just, yeah, these are the workflow continuation. Of course, we have one sample, we're not going to barcode. And then just to touch on the system. So this is the new system that we'll be getting. We have the older one, that is the SQL2E, but this one is the high throughput review system that we probably in the next 2 weeks. And then you can see the difference there. So I'm going to skip this, and for the interest of time, we will go through the analysis once we've generated the data as well. So there's just the one slide that is missing, where I wanted to show you guys the genomes that we've already sequenced for AfricaBP. I think there are 10 of them. Yeah, but I think if permitted, then I can share these slides, including the genomes that we have sequenced, so that people can see what has been sequenced. Just quickly, yeah, this is my last slide. So basically, this is a type of applications that you can run with Hi-Fi. It's basically everything, basically. And then that's it. Thank you.
So thank you very much, Aklen. Wonderful presentation, and a good appetizer for what will be happening in the lab in the next few days. So that is wonderful, and thank you. And also giving us an overview of what this technology, how this technology will be supporting AfricaBP and African scientists in general to do their work smart way. Yes, so thank you very much. I think the next presenter should be online. We are dealing with Peter Asselman. Peter, are you online? We can't hear you.
Yes, I'm here. I just got permission to be unmuted.
Can you unmute, please? Please, can you unmute Peter? Timothy?
Yes, can you hear me?
We can hear you, Peter. Go ahead, please.
Are you okay? Are you getting us? Good.
Can I share my screen? My screen?
Yeah, I think you should be able to share your screen.
Okay. While you are sharing your screen, and introduce yourself, I'll introduce you. So Peter is dedicated research technicians and from Belgium, from Ghent University, and he plays a multifaceted role within the Mycology and Botany Lab research group. This is in the Department of Biology, and his endeavors revolves around conducting a pilot experiment utilizing cutting-edge nanopore sequencing, among other technologies, to address specific needs of researchers from his institution and supporting a lot of fellows, students, etc. And today he's going to share with us his experience on the sample preparation for export nanopore sequencing. Please, you can share your presentations and go ahead.
So, Peter, you can now share your screen, please.
Maybe muted.
Yeah, Peter, you are now co-host. Can you please unmute and share your screen?
Doesn't seem to be. Can you now see my screen?
Yes, please put it on presentation mode.
It doesn't seem to want to share. Oh, okay. Does it share now?
Yes, perfect. Go ahead,
Okay.
please.
Yeah, sorry for the delay here. Good afternoon, everybody. My name is Peter Asselman, and I work as a research technician at Ghent University. So in the university, in the Department of Biology, I work for two research groups. The Systematic Evolutionary Botany, headed by Lars Chatroux. You all met him this afternoon. Secondly, I work also for the research group Mycology, headed by Professor Annemieke Verbeke. So today in my presentation, I'm going to discuss some of the aspects we are doing in the lab. So I'm going to introduce you to give a small introduction to nanopore sequencing. So I'll then give a technical overview of the sample preparation concerning genomic DNA, amplicon DNA, and multiplexing samples. And I briefly also will show you some of our sequence results and applications, covering nanopore versus Sanger sequencing and meta-barcoding. So let's start with a short introduction on nanopore sequencing. So in the previous presentation, we saw PacBio sequencing, which is also a long fragment sequencing technique. So here I'm going to show you how nanopore sequencing works. So at Oxford Nanopore sequencing, so here you see the device. They use flow cells, which is shown here in the middle, and they all contain an array of tiny holes, and they are called nanopores. They are all embedded in an electro-resistant membrane, where each nanopore corresponds to its own electrode, which is connected to a channel and sensor chip. So this sensor chip can measure the electric current which is flowing through these nanopores, which is shown here in this picture. So whenever a molecule passes through a nanopore, the current flow is disrupted and it produces a characteristic squiggle. So in real time, this squiggle is then decoded using base call algorithms, and the base call algorithms determine the DNA or RNA sequence in real time. So here we see a small picture of a tiny nanopore. So here you have the nanopore. On top sits a motor protein, which guides the DNA molecules or the individual DNA molecules through the nanopore where they get sequenced. So important to note here is the difference between, for instance, Sanger sequencing. So in Sanger sequencing, the signal detection is based on a population of DNA molecules, whereas nanopore sequencing, there you sequence individual molecules per nanopore. And those nanopores are spread over an array. So this brings us to the next slide. This makes that the nanopore sequencing technique is actually highly scalable. So the most popular device is the MK1B. So the MK1B holds a flow cell which can produce up to 30 gigabases of data. So then you have the bigger version, the Gridiron, which is 5 times the MK1B, and then for very high throughput projects, they have the P24 and P48. They go to up to 7 terabytes of terabases of data. But also for those who are interested in a smaller experiments or setup, you can choose for the Flungle, which can produce up to 1.8 gigabases of data. So this is a very short introduction to the nanopore sequencing platform. Those who follow the course the next few days will get a more elaborate insight in how it works, I'm sure of it. So this brings us to the sample preparation. DNA quality in preparing your sample for library preparation in nanopore sequencing is very important. So some of you might recognize this picture where you load a sample on an agarose gel. And here you see sample 1, very high molecular weight, sample 2, very degraded sample. So this is important to distinguish before you start your library preparation. So in this regard, firstly, when we extract our DNA, we are looking to the size and the concentration of our samples, and we do this on the fragment analyzer. So we measure both fluorescent and we do this by fluorescence and electrophoresis. So the fragment analyzer produces graphs where you, on the y-axis, you see the size of your sample, and here on this axis, you see the concentration. So the higher the intensity of the fluorescence, the more concentrated your DNA is. So here on top, you have a sample which is heavily degraded, maximum size 1 kilobases, base pairs, sorry, and goes as low as 125 base pairs, so a very degraded sample. Compared to this sample here, or an overlay of samples where the maximum size is ranging from 10 kb to 45 kb. Probably this is one of the causes here is that this sample is extracted from poorly dried material or herbarium samples, and this is originating from very fresh material. So choose your material wise when you want to do, for instance, genome analysis, which in this case, working with this type of samples would not be possible. Then a second important thing to take a closer look at is the contaminants in your DNA samples. So this is done by spectrophotometer analysis using the nanodrop device. So basically we measure the absorbance at different wavelengths. So here we see an overlay plot of two samples. At 260 nanometers, you measure the DNA concentration, and at, for instance, 230 and 280, we are looking at contaminants ranging from proteins, RNA, to chemical components, secondary components in the leaves. So here we see that the blue sample has an elevated value at 230, which might indicate that there are still chemicals or sugars, for instance, salts, which remain after DNA extraction. So in this regard, this sample would not be suited for library preparation. So once you establish the quality of your DNA and you're good to go, then we can move forward to the Nanopore library prep. And Oxford Nanopore offers a different array of library preparation methods depending on what your research questions are and depending on the starting material. Usually they start here with double-stranded DNA, can be genomic DNA, can be amplicon DNA or copy DNA. So the first step is always an entry pair where adenosine base is added to the 5' and 3' sites of your DNA molecules. And those adenosine sites act as a landing sites to attach sequencing adapters. So remember that the sequence adapters hold the motor protein, which is necessary to guide your molecules through the nanopores. The second aspect of nanopore library preparation can be multiplexing. So to make use or to make fully use of the full capacity of the throughput of your flow cell, you can decide to multiplex or to pool samples. This is usually done in 2 stages. So if you're working with amplicons, you can locus specific amplify different sites in your genome and use tailed primers. After amplification, you can pool all the samples into one tube where they get prepared to receive a barcode later on. Or you can decide to work with genomic DNA, and you prep the DNA here for receiving a barcode in stage 2 for the multiplexing part of your library prep. So Nanopore offers kits where you can use 96 unique barcodes, so which means in theory you could pool 96 different samples onto one flow cell, so one sequencing event. So then we can move forward. So I can illustrate a little bit some of our sequencing results we had in our lab and some of the applications. So first, I want to show you an experiment we did on Nanopore versus Sanger data. And the second one is metabarcoding, fungal metabarcoding. So one of our ongoing projects in the mycology lab is a study of ectomycorrhizal fungi in tropical and subtropical African forest ecosystems. So ectomycorrhizal fungi, or ECM, is a form of symbiotic relationship that occurs between fungal symbiont and or microbiont and the roots of various plant species. So we are actually interested in the association between these ECMs and tree diversity. As a backbone for this study, we are barcoding herbarium collections of African species. So at the Mycology Research Group, we also recently started a second ECM project, which is actually a capacity building project located in Benin. And this project is focused on training students in field biology and in-field sequencing for plus data analysis. So in one of the experiments we did to prove that the nanopore sequences were as good as quality as the Sanger counterparts. We selected 28 genera and 660 specimens in our herbarium, and we are performing ITS amplicon sequencing on those samples. So we also assessed the amplification success rates of our samples. So we saw a bias between dried and fresh samples. So it's also very important to, if you're working with herbarium samples, that you assess the quality and that you know that the herbarium specimen is of good quality. So to be able to pool all those samples in one sequence run, we opted for dual unique indexing of all the amplicons. So here we see a detailed overview of this. So each specimen receives a dual index tag. In the lab we have, we can make 96 combinations like this and pool them each individually in a different pool. Subsequently, they receive a nanopore barcode, which enables us to pool all those 660 samples in one library ready for sequencing. So this makes the technique already very scalable for us compared to Sanger sequencing. But of course, we wanted to know how good the sequencing data performed compared to Sanger sequencing. So we compared the pairwise identity of those sequences by using amplicon sorter or NGS species ID, which are consensus building tools. And we found that in most of the cases, the pairwise identity compared to the Sanger counterpart was 99% or higher. Except here, for these samples, we found that there was a barcoding issue. So it was an issue in the sampling in the lab. But overall, we were quite happy with the nanopore data and the multiplexability of the technique. So a second application is fungal meta barcoding. So in Glendirix, one of our PhD students is working on fungal meta barcoding using nanopore sequencing. And in the paper we are preparing, we are focusing again on ectomycorrhizal community, but in this project, it's the ECM in decaying beechwood. So here you see a schematic example showing a decaying beechwood that houses little saplings. And these, the presence or the ECMs which are present in the beechwoods, they serve as a substrate. So they help the young saplings to grow in this nutrient-poor substrate. So in this regard, it is a meta-barcoding approach because there are several ECMs present in this beechwood sample. So for this experiment, we barcoded around 40 samples, and here you have an overview of the number of reads we gained from this sequence experiment. So in total for this run, we had 12.74 million reads, and we see that for some reason barcode 45 ran away with a lot of reads, but we still could recover enough reads for the other barcodes. To test the efficiency of nanopore for our meta barcoding project, we constructed a mock community, which includes 16 species, including both major ectomycorrhizal lineages and are phylogenetically diverse. So they are shown here in the blue dots. So we also included some closely related species to assess the sensitivity of the run. So here you can see two Ricula species which are could be identified next to one each other. So DNA extracts were sourced from previous collections and pooled without prior quality control. So besides the blue samples or the blue species we added to the mock community, we also picked up contaminants which were present in either in the DNA or occurred during the library prep. Another interesting aspect of this figure is that if we filter on the quality threshold, so ranging from 10 to 35, and remember that the quality threshold of 30 is 99.9% accurate. That we see if you filter up to 25, so meaning 10% of the filtering away 90% of the reads, we still were able to pick up all 16 species which were present in the mock community. So this is for us another proof of concept where we can use nanopore sequencing in a metabarcoding context. So thank you for your attention. If you want to reach out, collaborate, please contact us and visit our websites. And also you can have a look at our Mycomatics GitHub repository where we share some of our pipelines and scripts to make this data analysis possible. Thank you for your attention.
Thank you very much, Peter. Another technology, another tool available to us to fast track our activities. And from Ghent, we stay at Ghent to have Paul. Yes, Paul, you are welcome. And Paul is a student also from Ghent University and graduate intern at the Royal Botanic Garden and also at Jomo Kenyatta. That's it? Yeah, and he has been in different parts of Africa, of course, and Asia, working on different activities, and now he's focusing on sweet potato wild relatives. And today he's going to share with us his contribution, the contribution of African wild taxa in addressing food insecurity with a case study using sweet potato crop wild relatives. So yes, so the presentation is loaded. Paul, you have the floor.
Thank you. Yeah, so my name is Paul Kagame, and I'm a PhD student at Ghent University. Sorry. My name is Paul Kagame, and I'm a PhD student at Ghent University, under sandwich program with Jomo Kenyatta University. So today I'm going to present the contribution of African wild taxa in addressing food insecurity, and I'm going to use the sweet potato crop wild relatives as a case study. So every time I usually have this presentation, I like to present, to show the audience how much as an African continent, we are not that badly off when it comes to the biodiversity hotspots that we have. And actually in just the continental Africa, out of the 8 biodiversity hotspots that we have, almost half of it is in Eastern Africa, the larger Eastern Africa. And in addition to that, Africa itself has different vegetations, 5 of them: tropic, montane, savanna, arid, tropic, alpine, and the Austro-alpine vegetation down in Southern Africa, which share some of the flora and fauna with the Australian continent. And out of this, actually East Africa, or Kenya in particular, we are honored or privileged to almost have all the vegetations that occur in Africa, except the Austro-alpine vegetation. But now to the real issue. We know that there's global climate change that is happening, and almost on average, there's an increase of 1 degree Celsius in every century. And in addition to that, it has led to the cause of some of the arable land that we have in Africa to dry up. And this has really led to a problem when it comes to food insecurity. The population is still increasing as much as the arable land is decreasing and the effect of global change. And therefore, there's a need to focus on the crops that are resilient to the ever-changing climatic conditions. So what do we need to do? There's a need now to focus on the crop wild relatives, the one that we have, growing in the wild, the one that have not been documented, maybe consumed locally by the locals, understanding the evolution and the useful traits, the evolution of the useful traits in these particular crop wild relatives that can help us maybe get some novel genes and introduce them to the normal cultivated crops. And also understanding their diversification rates and what led to those, the diversification rates that we have in these plants. And also developing models to understand their prediction when it comes to future climatic prediction models that we are using. Are these plants still going to survive? What will change? Will the area of suitability change? And so forth. So one of the models that I'm working on, the plant group model that I'm working on is Hypomea, and it's native in tropical and subtropical areas across the world. But someone would ask me, why the focus on Hypomea? I believe some of us in the morning here, we took the breakfast, the tea, and some of us took the sweet potato, right? Yes. So sweet potato, its scientific name is Hypomea batatas, and it's in that genus of Hypomea, the one I'm currently using as a model to study the crop wild relatives. And it is important for its storage routes. And the storage routes are not just important to us as consumers, as human beings, but as well to the plants, because they act as storage organ for the plant, where the plant can utilize the carbohydrates that is in the storage routes during maybe famine or wildfire events. And it's one of the 6 main crops that is being consumed by human beings worldwide. So research have been done on this particular genus, but I must say most of the research that has been done on this particular genus has really focused on the New World areas, that is in South America and North America. And out of the 65 recorded species that have these edible storage routes of Hypomea, almost half of it is in Africa, tropical Africa in general, and they are endemic here. But little has been focused on them because, as we know, Hypomea, people know it, a lot of people know it as weeds, because they just grow even along the roads. And also studies have been done on the parallel evolution of the storage routes. So a majority of these species that also have storage routes in Hypomea, they all use the same set of genes when it comes to storage route development, but not all have the edible storage routes, the big ones. Some have small, some don't even have at all, but still they have the same set of genes when it comes to formation of these roots. So far what I've done is from the literature review, we found that 64 species of Hypomea have these storage routes, 35 being native in Africa. But the number can be big because for some of us, when we go to fieldwork, we don't have that time to sit down and start digging up the roots and uprooting these plants. So the number might be even higher. So more sampling also needs to be done. And when it comes to phylogenetic sampling, out of the 128 Hypomea in East Africa alone, 79 have been sampled, 49 not yet, and we still believe there might even be more because we know East Africa itself is a biodiversity hotspot. So there are a lot of chances of us even getting new species and novel species. And then there's that need of now complementing the already data that is there and also try to do whole genome analysis of these species with edible storage routes. So why Eastern Africa? 25% of the recorded hypomea worldwide are in Africa. So that can tell us something. We really need to focus on Eastern Africa in general, just to try to sample some of these wild tags that we have that can address food insecurity. And as I mentioned earlier, Eastern Africa has all the different vegetation that we have all over the world, except the Austro-Alpine vegetation. So we did a field work last year, the way Professor Lass had mentioned, and we did some collection. However, the collection are still at the museum. We're still working on the permits and everything. But we came across one of the species, the Hypomea longituba, which we believe it's one of the close relative of sweet potato. And the good thing with this species is that we found it had very enormous big storage roots. And upon asking the locals, they said that they used to consume this particular species, but that was during the colonial times. Immediately they had left, there was famine. So they used to consume this particular species, and it used to act as their main source of food during that time. And apart from the edible storage roots, we also found out the scent, the sweet smelling scent from these species, which makes it well adapted or had co-evolution with some of the moth around the region to help them with the pollination and everything. And actually, we are still also looking for funds to try and understand the chemical composition of the sweet scent that comes from this species. And also from the leaves, from the foliage, we could see some of the pests that usually attacked the normal kales. Kumawiki was also on this particular species. So chances are maybe even the leaves might be edible to the human beings, not only to the livestock. But of course, more research still need to be done to understand the toxicity level of this particular foliage. So apart from the field work that we did, I also managed to visit different herbarium. And just to reiterate on what Anna said, some of the collections that we have, some of the plants that we have here in Kenya, here in Africa, they're all, deposited. There's a lot of duplicates that are still out there. And from those duplicates, you can do a lot, because even the analysis that I'm about to show you, it was all from the duplicates that were collected here in Eastern Africa almost 70, 80 years ago. And we could still extract DNA from this material. We could still get some coordinates from the morphological reports that were taken by the scientists back at then. And from those coordinates, we can really do a lot when it comes to even species distribution modeling, which I'll show you later. Also, I managed to visit the living plant connection in Paris, still just to sample and to understand this particular group of plants. As I mentioned earlier, from different herbaria, we managed to database some of the hypomea that were collected from Africa. And from that particular data, just from databasing and getting the coordinates from these morphological reports, we had a master student who was working on species distribution modeling, focusing on specifically on hypomea and try to see some of the trend, the future trend of this particular genus. So I also did some molecular data, tried to do some Sanger sequencing to get specific gene regions, just to do some phylogenetic analysis from it. And from a data set of 1,200 taxa tips, I managed just to crop the ones that I was particularly interested in. And this is a subclade of strictly endemic tropical African hypomea species, which have storage routes. And these storage routes have been documented in one way or another as being edible to the locals. And we can see even from here, the Hypomea longituba that I sampled, it's part of this clade. And this clade, this subclade is also a sister clade to the Hypomea batatas clade that is endemic in the New World, the South America and North America. And you can see one of the defining factor of this particular clade is that the huge storage routes. So more research still needs to be done. Of course, I cannot exhaust all the research on this particular genus. That's why we also need some African scientists to start working on these plants from wherever they are. So from the distribution, just to use that one, it's much more visible. And this is Hypomea marmorata, which also has very big storage routes and it's edible. And it's distributed in the northern part of Kenya and a majority part of Ethiopia. So if you are from Ethiopia and you're attending this conference, this is another challenge for you. Maybe you can try and focus on this particular species, and maybe we can get something out of it. So when it comes to the area of suitability, and this was as a result of the database that was collected in Europe. So you don't have to go there. You can always get your data from wherever you are by visiting the local herbarium in your country. And from there, you can get something that you can work on and you can even publish. So from the area of suitability, and this is for the Hypomea longituba, the species that we saw or we collected in Kenya, you could see that the area of suitability increases. If you check at the current, which is the far right or left, the area of suitability as you go even to the next century keeps on increasing. But this doesn't mean anything because the area of suitability can increase, but now the plant maybe will not survive during that time because of urbanization and all other anthropogenic activities. So this is just to show you that if everything is kept constant, the area of suitability of this particular species will keep on increasing. And maybe it's high time we can start focusing on this particular crop wild relatives, try to understand it, try to get some novel gene, maybe gene responsible for pest resistant, famine resistance, and try to use it in a cultivated sweet potato. Or we can try as well just improving this particular wild crop into a mainstream crop to be consumed by the society. Also, from the short read data that we collected in Illumina data, we could establish that the species is diploid and homogeneous. And also, from the short read data, we managed to target 86 gene sequences, which we compiled with other sequences that were already deposited in the NCBI, just to see the location of this particular species in the broader perspective, broader phylogenetic tree. And you could see it still forms a sister to the clade of Hypomea batatas. The Hypomea batatas is on the upper end, and that's the sweet potato. And this one is just a sister clade to the above sweet potato. And remember, sweet potato is hexaploid. So it's as a result of different species due to domestication. Due to domestication, maybe some of the species that were collected or used in developing that particular species might have come from Africa. But that's just an hypothesis because most of the work that have been done has just been focusing on the New World. And as per now, the close relative of sweet potato is understood to be Hypomea trifida, which is also an American taxa. So to conclude, I would like to leave with this remark that I saw in one of the papers that was published recently. Despite the scientific advances made possible by the analysis of large dataset networks, the diversity of tropical species remain critically understudied. So we still have ways to get data, like just walking in a normal herbarium and taking morphological notes and taking all the coordinates to do even species distribution modeling that you don't even need to travel. But still, given all this, when it comes to understanding and studying the tropical species that we have, there's still low inputs. And that's why we have such a forum to try to encourage, to try to train students. You know, you don't have to go out there. You can get this training from here. We can utilize the resources that we have. And at the end of the day, we can put Africa on a bigger map. So thank you so much. And yeah, thank you.
Yeah, this is wonderful. Thank you, Paul. And that is also reminding us that we have a huge diversity still to be exploited in Africa. I remember where I grew up, we were having some of those plants and we're using it for dogs and for pigs only. But today we are even fighting to find them, and it's a delicacy. So, and we still have a lot to discover. That's why I believe with AfricaBP, we should be able to harness the potential of genomics and discover more, try to characterize them and see even what is usable beyond food. We mentioned some of the flowers with better scent maybe can be used, etc. So thank you very much to all the presenters, and it's now time for questions. Because we have few of us, I propose we can remain where you are, but should be available to answer to few of the questions. I don't know if there are questions online, but while waiting for look for questions online, let me ask my first question to Priscilla. We have some of the, we have noticed that scientists sometimes complain about most of the time scientists will be complaining about the number of stakeholders or regulators that we have to that we need to pass through to be compliant, etc. And maybe that's what sometimes also is keeping them away from the regular process. What is the approach taken by WRTI to ensure that you attract people to comply to the process? Is there any approach from WRTI?
Thank you. Yeah, there are quite a number of initiatives, and the first initiative was to come up with a coordinated approach. The coordination of institutions, because you have several institutions that deal with the permitting processes, and that was one of the first initiatives, such that it is made very clear. This is where you start, this is how you move, and how you end up with the process. And we are supposed to have it online, such that you don't need to move. You just log in into a portal, submit your documents, and then you get feedback from each of the stakeholders. That one has not yet been completed because of the legal processes. Each institution is very independent. And also the institutions are different ministries, but we are working on it. Currently, WRTI is working on making the whole system of application online, wholly online. And there are also some discussions, so they've not been completed at the ministry level, to bring all the stakeholders together and see how we can amend the laws to make one, so that we have one umbrella that coordinates the whole process. So we are really thinking about your complaints. We've heard you. Many researchers have complained, and we are working on it.
Yeah, thank you very much, Priscilla. Thank God Online, you have a question before we move to the room?
I have a question. Thank you very much, Dr. Christian. I think it's not a question per se. It's a comment. Mainly a comment, and perhaps I'm hoping it will provoke one or two interactions, but it's fine if it doesn't. So I don't know if Aklem is still in the room. Based on his presentation, Aklem, I know you went through the PacBio Hi-Fi. One of the things that might be helpful is if you can maybe explain briefly how sequencing the first few genomes went. So why I wanted you to speak to that mainly is again, let people in the room know how the initial challenges were and how we were able to move past those challenges and get them, because I remember we had to try the library prep like 5 times. And I think it will also be helpful that if Oliver is in the room, Oliver can potentially speak to this. And why I want Aklem to speak to this is, when we say sequence in Africa, one of the things I've realized is while Africa does not have all the big equipment and all the whole technological resources, there are pockets of resources here and there on the continent, particularly. And one of the things we've done quite well in AfricaBP is using those little pockets of resources. And for instance, by the time we started, there was just one PacBio Hi-Fi on the continent. And we worked with Nkaba to do that, as well as with the University of South Africa. So it would be nice, Aklem, if you can speak to that, and Oliver, and how the library prep. I think we took quite several months to do that. And one of the reasons why I want Aklem to speak about that is, if we had sent the samples out of Africa, we would not have been able to build the expertise we built, sequencing some of these things on the continent. It took several months to optimize the protocol, but at the end now, it only just takes 2 weeks, to get the data out. And I think this is an example of one of the things we are speaking about. And this reflects on things, not just in the sequencing, in the analysis, in the funding, in the stakeholder engagement, and so many other things. So, Aklem, can you just speak briefly to that over the next few minutes, please? And I would also like Oliver to comment as well, because I think this is very pivotal to the discussion today. It's also pivotal to what AfricaBP stands for. And that is a story that hopefully I aim to communicate maybe in a commentary or opinion piece one day.
Okay, thanks. Thank God. Unfortunately, Dr. Oliver has left. Yeah, so, but I'll be able to answer some of those questions. So the challenges at the start, optimizing the workflows, trying to get the right fragments, trying to load the system up to optimally, and trying to get maximum output out of a cell.
And also, Aklem, just to mention, I know there was the optimal protocol for humans already established, but this was like a new dimension, going out to sequence very samples that have been around for 10 years, or plants or animal or wherever. So I think that is, another dimension that might be helpful to come through in this conversation.
Okay, yes, definitely. I mean, from our side in the lab, in terms of the workflow, irrespective of the sample types we received, optimizing the workflow took quite a bit of time. Obviously, from PacBio side, the workflow is there, it's published, but it's what you do in your facility to be able to replicate that particular workflow. So that took us quite some time, but once we got the workflow going, like as thank God mentioned, everything seems to be production was more faster. But one of the huge challenges on the sample side was the quality of the samples. So we at some point got like samples that were 10 years old, and that is really with long read, you pretty much need as fresh sample as possible. And then at that start, we absorbed as a company quite a few costs because of the samples that had to be send back when you do the sequencing. They don't produce. So as a service provider, you cannot charge the customer for the data they did not receive. But we sat down and emphasized with the SANBI in Pretoria as to what type of samples we really need. And I think once they've started getting the hang of the samples, and then we were able to produce high quality data at faster rate. And then another challenge was obviously the cost entirely of sequencing. And this is what prompted us now to buy a high throughput review system to bring those costs down. And looking at the cost compared to the sequel, it's a huge difference. It's a huge difference that I think will be beneficial to the AfricaBP community. We'll be able to run more samples at the same time. So the sample challenge has been, it's been one of the blocking, one of the major hurdle in terms of getting as many samples. Otherwise, I think we would have sequenced like 10, 20 samples now compared to the 10 samples we had good quality samples. So if we can get as fresh as possible, and considering that those samples will be as well prepared for high-C sequencing, we really need good quality. So I think those now have been addressed. We're getting fresh from UNISA. Within a week, we're able to produce data. So like now, again, there's been, I think the last time we sequenced was in August. So ever since that time, we haven't received a sample. Of course, the sample ambassador have their own challenges in terms of getting the permits, getting those samples coming down to South Africa, which is also something that I think at some point, East Africa or West Africa, there has to be a system that will allow those samples that are collected in that region to be sequenced there instead of us being sent down to South Africa. And for us as a company, we are very much committed to make that a reality if it ever comes to that point, because it also adds up to that capacity building, which we want to do. I mean, yes, we're going to do a workshop on Wednesday, Thursday, Friday, and then when we go, that's it. So and then it's over down the line, that information will be lost. So we need to constantly to be able to refresh memory by doing the actual sequencing where the samples have been collected.
Yeah, thank you, Acclaim. Just to also add to what Acclaim just mentioned, so and also what I've probably talked about earlier is the sole aim of this project is to bring the genomic capacity and the capability to closer to the people. So, and the next step we're taking is how do we sequence in the region, particularly partly because we know not all regions have the full capacity, the full equipment and things. But our primary aim first is to sequence on the continent, and then we take it to the region, which is why this workshop has actually opened a lot of opportunities. And for instance, we're going to be starting one of the sequencing in North Africa through the fellowship, because apart from actual full sequencing effort, one thing we want to do is sequencing through fellowship. So what that means is very simple. We have a call and shortlist maybe 10 to 30 African scientists that spend a month in Morocco, in one of the very good labs in Bangui, and then they spend a month there. They sequence the genomes, it's perceived with very small genome, and also endemic to that region, and they get it published. So the aim is to publish the genome within a month, library prep, sequencing, assembly, and then get it published. Essentially. So we are going to be having those kind of blocks of fellowship. So that fits into the training, and that also helps move the sequencing to the region and allow the institution more control over things. And again, I also listened to what Acclaim talked about, as well as everyone here, in terms of how we started. And I think the story here is that I think Acclaim, it took around 5 tries. And I remember in the last try, either you or Oliver said, "Oh no, this we've done this multiple times and it's challenging." So if in the last try or along the line we've said no, let's ship this outside Africa, then we wouldn't have been able to try to dive deep into this complex things. And I think this speaks to some of the things we are talking about, that no matter the challenge, we need to sequence on the ground. And with time, we build that capacity. It's never built in 1 month or in 1 year. It's a consistent thing, but it has to happen progressively. Thank you so much. Over to you, Kristen, please.
Yeah, thank you, Tangot. Thank you for that contribution. And thank you, Acclaim. I can see another question online, maybe the last from online before we move to the room. From Roman to Peter. Nanopore looks appealing. However, how many repetitive sequence does the MinION make before giving a consensus sequence? What is the error rate of the sequence? What error rate is it of the sequence gives? Peter, are you there?
Yes, I'm here.
Yes, please.
Yeah, that's a very interesting question. I also replied shortly in the chat. So talking about error rate and nanopore sequencing, I think it deserves its own talk. It's not as straightforward as it seems. So Nanopore has a website, a specific page on their website where they address the accuracy of the sequencing. So the accuracy when they first started in around 2006, I think, was very poor. So the Nanopore sequencer made a lot of errors, but now since last year they are selling the new chemistry, which is called V14 chemistry, and this chemistry improves on sequencing accuracy. So using the new chemistry, the raw read accuracy is 99%. So one read should be 99% accurate, so Q20 score. So that means, given that the error rate is also not biased by gene region, for instance, if you sequence, for instance, an amplicon 10 to 15 times, then you should get 100% accurate read. So this is one thing, the chemistry. On the other side, you also have the base calling of your sequencing. So you can base call at different accuracy levels depending on the computational resources you have available. And there is also something which is called duplex base calling, where you actually base call the complementary strand of your DNA molecule, which also improves the accuracy. So there are different aspects on accuracy if you talk about nanopore sequencing. I hope this short explanation helps a little bit.
Okay, thank you very much, Peter. And 2 questions from the room. Yeah, here and there. Yeah, please.
Good afternoon. My name is Samuel Kariuki from University of Eldoret. And I think I'm one of the beneficiaries of the PacBio sequencing facility at Inkaba in South Africa, when you are optimizing our HIV sequencing. So Acclaim, there is I understand there is a new protocol that allows you to use less starting material. When we were sending these samples, the facility was requesting for at least 1 microgram and above for amplicons of less than 5 kb. But now I understand even 150 nanograms can work. Would you explain the change and how shed some more light on this new protocol, please?
Sure, thanks, Samuel. Yeah, I guess it has to do, this would be the manufacturing side of things from PacBio, but I get it has to do with the new reagent productions. We are now from Smart Bulk Prep Kit 2.0. We're using now Kit 3.0. So there is a lot of changes in the formulation of the kit, the formulations of the enzymes in there. And so that's why now we require very last year. Sometimes as a service provider, we say it's 150 nanogram required in terms of the paper, but to avoid having to replenish a sample all in the first try, we kind of say it's 300 nanograms, so that should something go wrong, you don't have to go back to maybe at some point you don't have that sample anymore. And then we can still repeat that protocol. But in terms of requirement, I think it has to do with the formulation of the new kit, which we really don't have as a service provider much information. We are glad the requirements have went down, and we see great improvement in terms of performance out of the smart cells. So yeah, I think that's pretty much it, the new kit formulations, basically.
Okay, thank you. My name is Wanjiru Mureithi from the Kenya Institute of Primate Research. My question is for Madam Priscilla. I'm seeking clarity on something that you said that was very interesting. And in context of so much research in microbiome, you said that according to the law, if any genetic resource is gotten from an individual, from their microbiome, that is considered different from you. So I wanted to know, how does that translate in terms of access to benefits? Like, for example, if you have a remote village somewhere in the northern of Kenya and they have a very specific species in their gut that produces metabolite that can be commercially viable or can be commercialized. And does that mean when it's commercialized that there's no benefit for that particular community? Does the government, take whatever, commercial benefits that is sourced from that, and you say, goodbye, thank you for your contribution, but you're not getting anything from this? Thank you.
Thank you. I think what you need to understand are the processes of access, because that goes back to how the sample was accessed. During access, you need to understand who the providers are. We have the national government, the county government, and the local communities. So all those are the provider levels of access. So you need to be granted access collaboratively. When you are getting access to the sample, you will need the national government representative, the county government from where that particular individual is, and then agreements with the people who are doing that. But sometimes some research is sensitive. You cannot tell me you are getting my samples to do ABCD. There's some research we may not go to the level of an individual. And that's why communities are supposed to be organized in form of a legal entity, the community biocultural protocol, so that it is not, you cannot enter into an agreement, a legally binding agreement with me as a person. There has to be that legal entity created. So that represents the community. So when the benefits come at the end of the day, you look at who the providers are, and it has to come through the national government. And the national government is the representative. For example, I said when you are working with the wildlife genetic resources, it is the wildlife, the Kenya Wildlife Service, but the activity is delegated to the Wildlife Research and Training Institute currently. Or if it is forest and genetic resources, the national government is represented by the Kenya Forest Service. And that's what I was saying. You need to understand the stakeholders. So when the benefits come, you as a user transfer the benefits to the national government. Then the national government now trickles it down all the way to the other respective stakeholders. So it will eventually get to that particular community that signed as the legal entity. There is no way they will be left out. This was the essence of the CBD, to benefit the communities. But then the structure has to be very clear. I hope I've answered you. That microbiome was collected from somewhere. Yeah, you belong to the county. You belong to the county and the national government.
Please, yeah, just to
legal clarity.
Yeah.
Yes.
And that's why it is very important when you are in Kenya, the first thing will start with NACOSTI. And NACOSTI now will be able to identify, after evaluating your proposal, who is the national competent authority to treat your document. If it is KWS, WRTI, Kenya Wildlife Forest, etc., even the Ministry of Health now is having is regulatory. But what she was trying to also say from the beginning is that human genetic resources is not part of the Nagoya Protocol, but these pathogens is not part of human genetic resources, right? It means you cannot have those pathogens or bacteria from the human stool and claim that we are not going to comply to the Nagoya Protocol. Yeah, so this is what she was explaining. Write down your questions, then we move to the next session because we are also running late of time. And so please, another big round of applause for Priscilla, Paul, Peter, and Acclaim. Thank you so much. Yes, good. Just for us to make sure that our blood is flowing normally from the brain to everywhere. Please, let's stand up a bit, relax. 10 minutes. A bit of exercise, movement, then we come back. Not more than 10 minutes. Yes, welcome back again. Let's start our last session of the day. So after the sample collection and sequencing, we should be starting the last session on the ethical and policy session, where we have two presenters. We have Mareki Bote, who is supposed to be there, and Sadi also. I hope they're all online. Mareki, are you there? Okay, while waiting for her to connect, we can see Sadi is online also. Hello, Sadi.
Hello, good afternoon to everybody.
Good afternoon. You are ready?
I am ready. Do you want to stay with the program and have Marichi go first, or would you like me to go ahead before her?
Maybe she's not yet online. Maybe you can start also while waiting for her.
I am happy to do what will work best. Just let me know.
Do you have your presentation? You will be able to share from your end?
Yes, I am ready.
Yes, please. That would be great.
Okay, perfect. Good morning. I just need to be able to screen share so that I can get started because I will be using my own slide deck today.
Okay. Good. So while she's loading her presentation, let me introduce her. So she is a research scholar at the Rockefeller University and the New York University, where she's studying neurobiology and genomics. She's also a member of various global genomic consortia with leading roles in justice, equity, diversity, and inclusion, or JD. And she focuses on the shifting how the community and scientists really support sequencing. So she has also a lot of activities. She works, her work addresses the challenges and opportunity for equitable inclusions in the participation of all interested parties with just sharing of the derived benefit of genomics. Additionally, she is director of the Science Communication and Public Relations for the Vertebrate Genome Project. And she is going to share with us a topic on justice, equity, diversity, and inclusion, building on collaborative network of researchers to sequence all life in Africa. Please, Sadi, you have the floor.
Thank you so much. Hola y buenos días. Hello and good afternoon. Thank you for that beautiful introduction. I appreciate it very much. And to begin my talk, I want to acknowledge the shoulders that I stand on today as a first-generation American Dominican born to immigrant parents from the Dominican Republic. Specifically, I want to acknowledge with immense gratitude my ancestors, the indigenous peoples of Quisqueya, who are the Taínos, as well as the peoples from the continent of Africa, and particularly the area known as Mali. And I want to thank you, Asante, for welcoming me today to present and extend my gratitude to Professors Apollinaire and Anne, as well as all of the speakers today for laying the groundwork to bring me into my topic today. I want to contextualize the role of the continent of Africa in sequencing our life on Africa from this perspective of justice, equity, diversity, and inclusion. And my desire is to invite you into a challenging conversation of integrating social justice as co-equal technical components, especially when we think about everything that is happening in the world today. When we speak of social justice, we must also speak of colonization and of decolonizing science. And this can be really difficult for many people because of the historical injustices and the lived experiences of continuing inequities today that suggest that science is a space where some belong, some are represented, and some benefit, but not all. So to ground our time together, I want to suggest these convening principles to you and ask you to recognize that not everyone feels safe in science, but they're here bravely. I also want us to recognize that leading with curiosity And with trust, will lead us to progress, but that mistakes are part of that progress. We're all learners and we're all teachers. And discomfort is also part of this progress and this process, but we are capable of sitting through the discomfort to learn together. The second thing I want us to consider today is approaching with cultural humility, which is really about having an ongoing attitude of self-exploration and self-critique. And in a few moments, and again towards the end of my talk, I'm going to ask you to consider your thoughts, your emotions, and your behaviors about integrating social justice into the practical aspects of genomic research, such as sample collection, bioinformatics, and wet lab. This is the cognitive behavioral triangle, and it suggests that what we think, how we feel, and what we do are all interrelated. And as people in science, we tend to be really comfortable with the thinking part of this triangle. And we're trained to consider certain pieces of information as evidence, particularly data that we can quantify. Feelings or emotions as defined here are not just, I feel happy or I feel angry. It's really about what's happening in your body. For example, perhaps when you're feeling angry, you feel your fists or your hands becoming fists and you feel a lot of energy there. Or when you're feeling perhaps nervous to present, feeling butterflies in your stomach or your face getting red. It's these changes that are going on that we are speaking about as data that I want to suggest to you for emotions. And then behavior are the things that we do or do not do. And before we can change the world, we must understand who we are. So I'm going to give you 20 seconds in a moment to just have a baseline for yourself. This is not something you're going to share, and it's meant simply for you to understand where are you today in understanding what social justice is and the role it plays in science. And it's okay if your answer to yourself is, I don't really know what this is about, or I'm confused, or it kind of makes me really uncomfortable. Any of those are okay. It's just an opportunity for you to assess your own learning and what has shifted by the end of our time together. So please take 20 seconds now to assess for yourself how you feel about social justice and science working together. Thank you so much for doing that. To begin our talk, like I said, part of this conversation must include colonization. So let's briefly define it. One definition is that it is a practice by which one group of people, a social construct, or a nation state controls, directs, or imposes on other peoples or areas. This is an animation showing European colonization from 1492 to 2008. Now, I want to recognize that this is a 2015 map, and it may have geographical inaccuracies that don't reflect our current social-political realities. I only want us to use this map to reflect upon the history of colonization and the resulting impact of colonizers on colonized lands, as well as implications for not only the lands, but for culture, epistemology, narratives, things that are given off as quote unquote truths. What are the narratives that we tell, and who is telling these narratives? And which narratives have been erased, diminished, or minimized? I bring up colonization because it has impacted our science in a number of ways. And the paradox of Western science is that it's a belief that Western science is able to produce universals, and it elevates them to this rank of being the absolute truth to the exclusion of other narratives being erased, diminished, or minimized. And often this looks like parachute science, biopiracy, eugenics, resource extraction, forced displacement, and commodification. More simply, let's define it today when we think about decolonizing science as these questions here: who belongs, who is represented, and who benefits? Earlier today, you heard about the African BioGenome Project and its role as part of this larger endeavor, the Earth BioGenome Project, to sequence all life for the future of life. The Earth BioGenome Project is a network of networks with a shared mission of sequencing all life on Earth, and it extends to over 51 projects with over 5,000 participants in over 100 countries. As part of the Earth BioGenome Project, the African BioGenome Project is contributing to the global status of eukaryotic genome sequencing. And this data is shown as of April 2023 that about 12,000 taxa have a whole genome sequence available. And that's less than 1% of known species that have a sequence available, with only 17% of those being of reference quality. We're aiming to change that together. And clearly, we can all agree that our understanding in protecting, conserving, and restoring biodiversity is severely limited simply because we haven't gotten there yet. There's many species that remain unnamed, unknown, and without a genome sequence. For example, of the 1.8 million named eukaryotic species, that only represents 20% of the estimated 7 to 10 million. And of bacteria and archaea, the known and named species are less than 1% of the possibly 4 million species. When we think more specifically of a subcategory of those species that are conservation dependent or worse, we have less than 3% that have any sort of genome available to them. And ultimately, these projects are working towards a much larger vision of living in harmony with nature by 2050. Parties to the UN Convention on Biological Diversity adopted the Kunming-Montreal Global Biodiversity Framework in December last year. And it's a landmark agreement on the next decade of global action on biodiversity, which states by 2050, biodiversity is valued, conserved, restored, and wisely used, maintaining ecosystem services and sustaining a healthy planet, delivering benefits essential for all people. And this framework, although non-legally binding, is a guide aiming to catalyze and enable urgent transformative action across all of governments and all of society to halt and reverse biodiversity loss. Now, it has 4 main goals. The first one shown in green, which is about conserving or halting loss and restoring nature. The second one in red is avoid, to use lands and seas sustainably. In yellow is safeguarding and sharing benefits and services. And the fourth category in purple, and the fourth large goal, is to act, to mobilize necessary resources. Those 4 main goals, each of those then have interim goals that are to be met by 2030. And those are the ones that are shown in the bars to the side. Here's an example, or here are the very specifics of these interim targets, which aim to reduce threats to biodiversity, to meet people's needs through sustainable use and benefit sharing, and to develop tools and solutions for implementation and mainstreaming. Emphasized throughout the documents are the needs to foster the full and effective, and I really want to highlight this because I think it's really important globally, but particularly for the continent of Africa, is that the documents really lay out the full and effective need for the contributions of women, persons of diverse identities, youth, indigenous peoples and local communities, civil society organizations, private and financial sectors, and stakeholders from all sectors. It really emphasizes a whole of government and whole of society approach. Now, while there's goals and targets that are listed here, so for example, 23 is about ensuring gender equality, 22 is about respecting rights and cultures of indigenous peoples and local communities. Even though we have these targets here, they don't give the very specifics about how we're going to implement these and the decisions that need to be made to safeguard our biodiversity. And this is where social justice intersects with science. Now, I want to invite you now, I'm going to come off of my slide deck in a moment to show a different screen for an anonymous polling because I want to bring your voices into the room. And so on your computers, you can type in pollev.com/SadiePius785, Or if you have a mobile device, you can click on that QR code and it should bring you to the presenter part of the presentation for the polling so that you can participate in it. And again, it's completely anonymous. I'm going to go ahead and I'll give 5 more seconds before logging off of this part so that you can join in the next one. Great. Oh, beautiful. Okay, people are already on it. Perfect. And so you can also, for this one, you can up-click instead of continuing to write. You can, if you are from Kenya, for example, just give a thumbs up on it so that we can see it come to the top. So we have Kenya. I'm going to scroll down in case we lost out Tanzania. Someone earlier, I see another thumbs up there. Many from Kenya. Beautiful. I'll give a few more moments here to allow everyone to participate. Great. I like the thumbs up. Ethiopia. I see also a couple people have put in the meeting chat, Rwanda, Uganda. Great. Let's go to the next question. And the next question is about your current career level. And so just whichever of these responses resonates best, I recognize I may not have all of them. We also have individuals joining in the chat, and that's beautiful. I'm going to call some of those out from earlier: Ethiopia, Nigeria, what did I miss? DRC, Côte d'Ivoire, Cameroon, Uganda, Sudan. Thank you so much, everyone joining us. Rwanda. I'll keep an eye on both so that if you're joining either on the polling or Nigeria, I see you, Tanzania. And so for current career level, we're seeing here a mix. It's dancing around, PhD student, I see in the chat, postdoctoral researcher, undergraduate, staff science, managers from industry as well as senior management teams, researcher, PhD students, lecturers, Ivory Coast, I see you, research officers. Great. Really beautiful. Continue to fill it out. It's great to see all of the responses and see everyone who's joining us, the United States, even master's student, PhD students. You can go ahead to the next question as well. And our next question is about the focus of your research. And again, whatever fits best. I recognize it's hard to put every single answer here, but from eukaryotic, we have some from plants, some from animals, other filling out, conservation genomics, comparative, even some bacteria and fungal people in science joining us today. I see applied genetics, bacterial genomics, crop disease. Thank you. Medical microbiology, plant breeding. So beautiful. Let's see. Biotech, genomics policies are with us here today. Sequencing providers, thank you for being here. Cancer genomics and epigenetics. I see that. Thank you. Biotech, animal genomics. Beautiful. You can continue filling out. I'm going to jump just to our last one to be mindful of time. This question is a little different, and this is asking, as people in science, what is another way that you would describe yourself? This is going to populate as a word cloud. You can also continue to fill out. Thank you for the first person joining us, Forrester. You can also put it in the meeting chat. I'm just going to call out some of the other ones from earlier, which was policy and strategy researcher, animal breeding and genetic reproduction, bioinformatics, medical lab scientist, plant biotech. Perfect. And so for here, people in science, I'm asking you to describe some of the other ways that you think about yourself. And so I see here lifeist, someone who's identifying in that way. Ooh, we're dancing around. This is so fun. curious, entrepreneur, scientist, I see that in the meeting chat, biotech, surgeon, forester I saw earlier. Sometimes, so you're aware, sometimes the words will separate, and that's a result of the platform, but you can see here how many different ways we describe ourselves. Food scientists. Great. So I'll just invite you to take a few more moments to see the different ways that as a community here, we're showing up, we're suggesting and describing ourselves. Great. Great. You can continue filling that out at your leisure. I'm going to take us out of this for a moment and go back to my presentation to take us to the second part in thinking about the intersection of social justice with our science and thinking about this framework of living in harmony with nature by 2050. And as you just saw on the polling, just from those that are joining us today in the room, virtually like me, over YouTube, there's a number of geographical places, career levels, areas of interest, and even ways that we identify as people in science. And this matters because social justice, or as it's defined here, fairness as it manifests in society, is a theoretical concept and a practical ideal. And I describe it in that way because it's an attempt towards reaching this ideal of fairness as it manifests in society. Ideal because it can never be static. Social justice, or this idea of fairness, is going to change based on the political and socio-cultural circumstances. And that's influenced by our individual identities and our collective identities, and therefore our approach to research at every level of the decision-making process. Formal definitions vary in wording, but they often have in common for social justice being about equal rights and equitable opportunities. What do we mean by that? I want to define for you some principles of social justice, equity, diversity, inclusion, and plus, as an approach or a way of thinking about how we might achieve fairness in society. Now, you might have heard the terms equality, equity, and maybe justice used interchangeably, but these are really different. And I want to break them down a little bit more for you so that we can all be on the same page. Here we have a scenario where there's 3 individuals trying to watch a football match. And the difference between them is in height. We have a tall individual, a middle or medium-sized individual, and a smaller individual. Equality suggests that when these 3 individuals are trying to access or have an opportunity to access watching the football match, and they come across this wooden fence, equality suggests that everyone benefits from the same support, which here is shown as a box. When we do that, we can see that the tall and middle individual, by receiving this support, are able to access or have an opportunity to access the match. But the smallest individual, when receiving the same support, doesn't have the same opportunity. And so we don't aim for equality when we're trying to achieve fairness because it doesn't correct for the systems that limit opportunities or that prevent opportunities. We want to instead think about equity, which is when everyone gets the support they need. It factors in individual differences of people. In this scenario, the tall individual already has the opportunity to access and participate. They do not need any support. The individual in the middle needs some support, and the individual at the end, the smallest one, needs more support. By giving every individual the support that they need, everyone has the same opportunity to access and participate. And I'm really emphasizing that because even when we provide support, every individual still has to make the decision to participate. And so there's still individual choice here, but again, by giving every individual the unique support they need, they have that opportunity. Justice goes beyond thinking about individuals, and instead we start thinking about the systemic barriers that limit opportunity to begin with. In this example, the barrier in place is this wooden fence. If we replace the wooden fence with a chain link fence, we've addressed the system that was preventing access. And now, regardless of height, every individual has an opportunity to choose to participate. So equity is about mitigating or reducing the barriers by giving every individual the support they need. And justice is about eliminating those barriers altogether. Diversity, inclusion, and plus establish ethical principles for a just society. So diversity is all the ways in which people differ. You can think back again to the polling, and in just those 4 questions, the way we chose to answer them, all the diversity in this room. But it's not a strategy by itself. It's like having these puzzle pieces scattered all throughout, let's say, a building, a university. All the diversity is there, but it's all over the place. Inclusion is about actively and authentically bringing all these individuals or groups into the processes, activities, and decision and policy making in a way that shares power. It would be like taking all those puzzles that are scattered throughout a building and bringing them to a room like we've done today so that everyone can be a part of the conversation, be a part of the decision making, and be a part of the progress together. And plus is another factor that we're introducing, my colleague and I, in an upcoming paper, to capture aspects of social justice that are not yet understood or studied. It's acknowledging that these issues are far-reaching and broad, and that we don't possess an encompassing and comprehensive understanding yet. So together, these principles work towards having justice as the anchor, which is essentially asking for fairness in an unfair world. Equity, diversity, inclusion, and plus are important, but they cannot get to fairness alone. We still want to think and really underscore justice being about the systems. What are the systemic barriers in place? And together, then we have justice being when we are able to bring together diversity of people and perspectives who are included equitably. That means we're accounting for all of their individual needs in their voice, their power, and their ability to be a part of the organizational culture, to be able to be a part of the decision-making in the processes and the practices and the policies. To connect that to the African BioGenome Project, I want to bring here what is the typical project life cycle and suggest to you that embedding social justice principles is about thinking about being intentional in thinking about these as co-equal technical components, the same way that we think about the practical aspects of biodiversity genomics. We want to be thinking about how do we create fairness in an unfair world at all stages, from proactive engagement to access and benefit sharing, sample collection and processing, ex situ samples, data, and communications. All throughout this cycle, we want to be thinking about these principles and continuing to reflect, to improve, and to reorient. In the same way that we think of a genome sequence pipeline and we continue to refine it and revisit it and make it better and better, we want to use that same approach here to create an intentionally just and equitable culture. So when we think about the practical aspects, again, things like sample prep, sequencing, bioinformatics, we can pause and think to ourselves, what do we consider knowledge? Whose knowledge do we include in our decision-making? Who has the position and power in this decision-making? It brings us back to what we started when I briefly gave us a new way to think about decolonizing science, which is who belongs, who is represented, and who benefits. And in realizing the ambitious missions of sequencing all life on Earth and in the role of the continent of Africa and its people in sequencing all life on Africa, it's important to think about working together to co-design a just, inclusive, and equitable future. There's many realities that we'll need to contend with in our decision-making, and I list here just a few of the challenges that we have. Things like large consortia in general are very centralizing. How will we bring these different voices in? Another challenge that we'll have to think about is countries and territories have vastly different responsibilities towards conservation. This figure here is showing the top 45 countries with the highest and lowest conservation challenges. And in red, we see the continent of Africa, different countries listed here. We need to be really mindful as a global community in biodiversity genomics that some of our most species-rich areas occur in regions with high poverty rates. And placing heavy conservation burdens in these regions could actually exacerbate poverty and social injustice. And so we need to think about the responsibilities towards conservation differently and think about how do we work in a way that's equitable and just so that we can fulfill the scientific potential of biodiversity genomics, respecting all these perspectives and knowledges as we build capacity and foster development. I'll bring you back to this, and I told you this at the beginning that I was going to give you another opportunity at the end to assess for yourself what has shifted for you. So I'm going to give you 20 seconds again to think about where you were in the beginning, your baseline for today, and what has shifted for you when you think about your thoughts, your emotions, and your behaviors, what you think, how you feel, and what you do when you think about the role of social justice and our responsibility in bringing that into our science. I'll give you 20 seconds to do that now. Thank you so much for joining me in that. I hope that that's been helpful for yourself just to have a moment to reflect with this brief introduction to social justice. Gracias, Asante. Really, my sincerest thanks and gratitude for welcoming me into this space and for allowing me to share my work with you. Here, I just want to acknowledge some of my funders, supporters, as well as some of my teachers and mentors below. I'll highlight Natanga Nazadni, below Mapoli, who's a dear friend and colleague that I work closely with in this topic. Thank you also to thank God Ebenezer for welcoming me so warmly to this space, as well as Dr. Ann Ngui for having me be a part of this. Thank you to all of you.
Thank you very much, Sadia, and wonderful presentation, and of course, a lot of brain working also. That's wonderful. And please stay online, and we move to the second presenter before we have the questions and answer. So we are supposed to have Marichi. Marichi, are you there? I think she's. Please, can you unmute? The host? Thank God, if you are the host, please unmute.
Excellent. Thank you very much. Yes, I'm here and I'm unmuted and I'm ready to start.
Wonderful. Thank you and welcome.
Thank you.
Yes. So while you will be loading your presentation, I can introduce you to participant. So Marichi has transitioned from 20 years, more than 20 years career as a practicing attorney in health and in health law and biotechnology to academia, focusing on interdisciplinary research at the intersection of science, technology, law, and ethics. She holds a degree in intellectual property law and a PhD in biotechnology law. Her research interests include the regulations and ethics involved in advanced medical products such as gene therapies, stem cells, use of big data in the context of health emergencies and pandemic, digital health technologies, and their impact on the fundamental right. So including online behavioral manipulation and how it shapes debate around digital ethics and its push toward digital constitutionalism. And today, we are going to listen to her sharing with us the benefit sharing in the areas of data intensive research. So she's from University of Stellenbosch, from the Stellenbosch University. Please, Dr. Mariki, you are welcome, and the floor is yours.
Thank you so much. Thank you for the kind introduction. So today, as you heard, my background is a bit more in human genomic research, but I think benefit sharing, and if you think about benefit sharing in the era of data-intensive research, I think there's lots that we can learn from one another. So just a little bit of background, how from the context of South Africa, how data specifically, the term is used and defined in both our material transfer agreement as well as our data transfer agreement. We're going to have a look at that and compare the two, and then see what the Nagoya Protocol is telling us about benefit sharing and what that means in the era of data-intensive research. So in South Africa, in terms of the National Health Act, a standardized material transfer agreement, or a template for a material transfer agreement, has been published in the Government Gazette in 2018. So in that specific agreement, data means any information, including personal information, in any form derived directly or indirectly during the conduct of research or clinical care. This is the only reference or the only definition you will find of data and what data means in a research context in a formal document in South Africa, for example. This material transfer agreement further states that benefit sharing entails the sharing of benefits, and that it should be discussed and negotiated between the provider and the recipient before materials are transferred to the recipient. And the parties agree to benefit sharing as detailed in an annexure to this material transfer agreement. So it's clear that you need to, as either a provider or a recipient of materials or data associated with such materials, you need to negotiate already before the conclusion of these contracts how you will exercise, approach, and deal with benefit sharing at a stage in a research project when you cannot be more unsure about benefit sharing. This is why I started considering that data can be utilized differently to overcome this problem. And these obligations are put on the provider and the recipient, but in the material transfer agreement, it only deals with material. So there's a clear need for data transfer agreements separate from material transfer agreements. And the reason is that the transferring or sharing of data is far more complex a process than merely the sharing of material and data associated with that material. And as we sequence genomes in the future, we will get to a point that we will only share data as opposed to the material with the data, and hence the need for a separate, properly considered data transfer agreement. So in South Africa, we also have not an official, but a properly, legally, and ethically vetted data transfer agreement, which is available freely, free of access, open access on Zenodo. And in terms of this data transfer agreement, data is defined much more broadly as in our material transfer agreement. In terms of the data transfer agreement, it means any information, either electronic or otherwise, including personal information. Project data means the data transferred from the provider to the recipient as stipulated in detail in an annexure to this data transfer agreement, as well as any data actually transferred from the provider to the recipient as part of the project. So almost collateral data, so to speak. So you can see that the scope of data as defined in a data transfer agreement as opposed to a material transfer agreement is far broader, far more extensive. Data transfer agreements in addition to the terms and conditions of material transfer agreements, also contain detailed clauses about data privacy, data breaches, and secure data transfers, which speaks to the more technical issues of how to secure data and how to securely transfer data. It also deals with the contested issue of data ownership. In South Africa, the data transfer agreement specifically states that the provider of the data remains the owner of the project data and all copies made thereof. Nothing in such an agreement shall be deemed to grant the recipient ownership of the project data or ownership of any copies thereof. Merely the use of the received data can be negotiated and transferred. With regards to benefit sharing, the data transfer agreement says that the benefits that the provider will receive from the recipient in exchange for transferring the project data to the recipient are described in an annexure to the data transfer agreement. So this again brings us to the conundrum of how do we know what we have to share with regards to benefit sharing, and how do we describe that? If we have a look at the Nagoya Protocol, it divides benefit sharing between monetary benefits and non-monetary benefits. Now, monetary benefits are usually very hard to determine, and very, very few research projects actually ends up with patents and whatnot, which can be commercialized and with monetary returns at the end of the day. But just in brief, the Nagoya Protocol lists monetary benefits or examples thereof. It's not an exclusive list, as access fees, fee per sample, upfront payments, milestone payments, payment of royalties, license fees in case of commercialization. But as I just said, commercialization is very, very hard. Special fees to be paid to trust funds supporting conservation and sustainable use of biodiversity, salaries, preferential terms being mutually agreed, research funding, and then 2 points where data can possibly help is joint ventures and joint ownership of relevant intellectual property rights. This includes joint ownerships in collaborative data sets, for example, which could be a possibility of a benefit sharing example under the monetary benefits of the Nagoya Protocol. Then looking at non-monetary benefits, this may include the sharing of research and development results. Now, earlier in the year at the African BP conference in Pretoria, South Africa, we spoke about sharing of research results, for example, right after the first collection stage, for example, of a project. If you can share your view or your excitement or your ideas about why you started this research project in the first place with communities and with stakeholders, that could form part of sharing of research results. And it's getting into a trust relationship with communities to enable you to form long-term relationships with the communities, mutual respect, which will benefit and promote the research that's being done in such communities. So non-monetary benefits also include collaboration, cooperation, contribution in scientific research, and development programs. In the context of data-intensive research, such development programs may be coding workshops or statistics workshops or workshops enabling people to make sense of data, analysis, thematic analysis workshops, or whatever the case may be, or what is appropriate for your specific research project. It also entails product development. Remember, product development can also entail the development of an app that makes access to the data or the research results from your project much easier for the community or stakeholders to use, to access, to actually implement in their daily lives. So maybe data in the data-intensive research era could be used to develop products such as those. And then it also entails education and training. And around data, there's a lot of education and training that needs to happen. Bioinformaticians can transfer their knowledge and their trade secrets, so to speak, and help train some of the people just to understand and gain or extract meaning from data sets, which can seem overwhelming at times. It also includes, and this is important, admittance to databases. Data, as so many people say, is the new oil, meaning that it's very, very valuable and it will increase in its value going forward. So even if you allow stakeholders or communities where you sourced or collected your samples from access to databases, that will be of tremendous value from them. But access aren't enough. Access needs to be coupled with education and training, possible product development, to really make the data meaningful, invaluable if you actually access that data. Then it continues with a lot of other examples and suggestions for non-monetary benefits. It includes, for example, institutional capacity building, which is needed for if you have access to the data sets we just spoke about, to actually utilize the data sets and the data you have access to. Training related to genetic resources, access to scientific information, and then contributions to the local economy, which is a very interesting concept for me. And I'll end off with a suggestion of how data or benefit sharing in the era of big data can contribute to the local economy. And it also say that research should be directed toward priority needs, such as health, food security, taking into account domestic uses of genetic resources in the party providing genetic resources. So your benefit sharing must be context specific with regards or reference to the community from whom you collected such data and samples, and what that community need in respect of health and food security and the domestic uses of their genetic resources. And it provides for collaborative activities and food and livelihood security benefits. So these all speak to the fundamental rights of the stakeholders, the community from whom you're sourcing resources. And then again, it ends up with joint ownership of relevant intellectual property rights. So after having looked at the monetary, non-monetary benefits and benefit sharing context from the Nagoya Protocol, I was wondering what the context could be, or the similarities between the debates that's going on in human genome data and data per se, and could they be similar? The human genome, because as you all know, most of you are geneticists or working in the field, 98, if not more, % of all people share the same genome. It is only that small, very small percentage that makes you unique. So the debates in human genomics go that the human genome is considered to be the common heritage of mankind because it's shared and it's so common in all of humanity or all of mankind. Hence, the benefits should be shared with all of humanity. So there should be an altruistic approach to donating human genomic data, etc., and it should be shared. Data per se is not necessarily a common good. From some sources, you can gain more data, more meaningful data. Some sources, you will merely gain duplicated data, maybe not that meaningful data. Depends on the quality of the data, whether it tells you something new. So data is not quite similar to human genomic data. But data can be utilized as a common good to everyone. But in order for us to do so, data needs to be aggregated. It needs to be compared, and it can then be applied to the benefit of all of mankind. And I think that is the hardest part, to get people to consent, to contribute, to donate, and to an aggregated pool of data and to make data transfer as easy as possible, considering the legal and ethical obligations, to get a big pool to allow comparison and extraction of meaningful data to the benefit of all of mankind. So back to my specific specialities of the human genome and human rights. Article 19A2 of the Declaration of Human Genome and Human Rights says, benefits from achievement of scientific and technological research must be shared to favor economical and social progress of all. Now, if I deduce from what I've just said that data, if aggregated, can be used to the benefit of all mankind, it can exactly comply with this requirement that it should be shared to favor economical and social progress of all. So what benefits can progress economic and social progress of communities? This is what wasn't so clear for me in the non-monetary benefit sharing suggestions in the Nagoya Protocol. If we look at what the benefits, the progress, economic and socially may be, through the lens of data sharing, you can help communities access quality internet services that will allow access to data. And internet or access to internet is considered as a human right. I'm not going to go into that further. That's a debate or a presentation for a whole nother day, but it is considered as a human right. And it's very important for inclusivity purposes to include everyone into a digital world. Otherwise, you risk the fact that you can create two parallel worlds with exclusion of certain people from the digital world, which is not tenable in a data-intensive era. So by accessing or allowing people access to quality internet services, materializing or realizing their human right in that regard, and including them into the digital world where they can access and richly engage with data, you are, through that, enabling economic activity. You're enabling farmers, for example, to gain access to geographical or weather pattern data, whatever the case may be. You can enable education, easy internet-based education, the value of which we've seen during COVID, where we couldn't go to educational institutions. The access to tele or digital healthcare, that includes care for your livestock, for your crops, etc. Agriculture information, weather patterns information, health emergency tracking and tracing, and much more. So I'm sure you can see the value of just entering this digital world. The Hugo statement on benefit sharing in 2000 says that benefits as determined by community needs should be provided. And as I've said earlier, benefit sharing should be considered from the context of the community from whom you are collecting your samples, not the other way around, or what you think you'll be able to give. You need to first consider the community needs and then match up those community needs with the possible benefits that could be generated from your research project. Such as providing access to the internet could put some of these communities on the digital map and solve the data deserts in Africa. In geospatial information tracking, it became so clear during health emergencies that there are certain data deserts in Africa where technology simply does not reach large communities. So we don't know how they travel, how infectious diseases spread among them, because the technology simply can't reach that far. Maybe one form of benefit sharing could be to populate, so to speak, those data deserts with technology to get those populations on the map and help them with emergency responses, be it from natural disasters of health pandemics. So the solutions to geospatial data mapping for purposes of health emergencies falls in developing technologies appropriate to healthcare. Now, the concept of community in the context of data must be interpreted much broader or bigger than in biomedical research terms, due to the nature and the scale and the scope of data technologies. A data community, because of the reach of the internet, can be so much larger as a mere community living in a certain geospatial area or limited to a certain country. That's the beauty of the digital world. It also causes all the risks of a digital world, but it requires of us to completely redefine what community in the context of data means. In South Africa, for example, the Biodiversity Act states specifically that the minister is required and he's responsible for the national environmental management, and he needs to approve benefit sharing agreements. So the proposition with whom I want to end off with and want to leave with you for some consideration is maybe it's time to provide for something similar in the context of data-intensive research and the sharing of data infrastructure as a possible benefit from research projects. And maybe it's a good idea that this needs to be approved by, for example, the Minister of Telecommunications, because this will not entirely fall within the realm of the Minister of Environmental Affairs, but it will definitely fall within the realm of the Minister of Telecommunications. So this is hinting at the larger national scale community, hence my remarks prior, that we need to rethink what community is if we talk about benefit sharing in the context of data-intensive research. So this is just a quick thought and a quick background of what benefit sharing could possibly look like if we approach it from a data-intensive research perspective. Thank you very much.
Wonderful. Thank you. Thank you, Dr. Bute, and wonderful presentation, very comprehensive and instructive, telling us clearly that there is a need to have a data sharing and data transfer agreement, which is also different from the material transfer agreement. Also clarifying to us that data is the new oil, but it's still a desert in Africa. But now it's our responsibility to make sure that we green that desert. So thank you very much. Now we move to the Q&A session. And the floor is yours. Participant online, if there is any question, you can check. If not, we can be taking also questions from the room. I'm sure there are many. Please don't be shy. Questions, please. Yes, Prof.
Thank you very much. It was very, very interesting to, first of all, from Sadie to internalize that self-perspective. It was the first time where I have had to stop and actually think of myself aside from that particular scientist. And it'll be interesting to hear from you, why is that important and how does that contribute to diversity? And my question for Mariette is, it was a first for me to think about internet, giving a community internet as a way of providing access and benefit sharing. Are there other examples of infrastructure or little things that we could do in communities that could actually provide this access and benefit? Thank you.
Thank you so much. Yes, I like the idea that you break down this whole concept into smaller practical steps. The whole idea of the internet, which is often governed by big tech companies or the government, is an idea. But I think in the meantime, getting up to that point, information is the oil that makes the wheel turns. So I think just to get people on the same page, something as simple as setting up a WhatsApp group or some email chain or a newsletter which you can regularly circulate to a community, just to get them up to speed of your excitement. As I alluded to earlier during a workshop earlier this year in Pretoria, we said, for example, that you zoom into or you go into a community, you collect samples, and then you leave. And very few researchers come back and then on a regular basis and actually develop a relationship with those community members. So if you keep the communication channels open, WhatsApp groups, community newsletters, email chains, stuff like that, you can, in the meantime, tell them that this is what we've seen after we've analyzed the data, and this is what makes us excited. We don't have answers. There's no research results yet. We don't have papers yet, but this is what excites us, and this is possible obstacles we ran into. Just so there's an open communication channel, it creates trust. It creates the idea with community members that we're not forgotten. The researcher didn't just come in and left and just forgot about us. So this is small practical steps leading up hopefully to a bigger concept where we can actually share bigger communication infrastructures in the big data era. I like the idea of breaking it down into practical steps. Thanks for the question.
Mm-hmm. And I'll add to what Marjorie was just saying in terms of the justice, equity, diversity, and inclusion question about why did I ask the collective room to self-reflect? And it's because of this. While ultimately with justice, we're trying to get at the systems, I think the example that was just given is a really beautiful one to think about our individual roles. At the end of the day, it is we, the people, who are creating the systems. Some of us have more power and more position to make the decisions. And so if we reflect wherever we are in the spectrum of power and position, we can empower and enable ourselves to make different decisions and to start thinking about these things, not about is it good or bad, but is it useful or not useful? And this example of creating what's up group chats is a really beautiful example of that. Is very useful. It maybe doesn't get to ultimately the best system, but it really helps us along the way as we strive to create a just and inclusive world where everyone is able to participate and everyone is able to benefit monetarily and otherwise in the ways that were described in the previous lecture. And so I think taking a moment for ourselves to pause, we may realize wherever we are as a student or as a senior advisor to a group, we have a lot more power to think about things differently and to influence changes that will be really useful towards this vision of sequencing all life on Africa. Thank you for that question.
Thank you, Sajid. Thank you, everyone. And just one last question from my end. Sajid, you mentioned about scientific colonizations or decolonization, where I believe it's not just from the north to the south, but also even within the south and from us to local communities, where most of the time scientists also think they know better what the farmer or the local community member wants. It means sometimes when we are designing our proposals also, we think what is the problem we want to solve. We don't ask community, what do they want to solve? So do you think there is a better approach of decolonizing research from the communities instead of us going to communities, bringing communities to science, or what could be done? And in terms of data sharing as well, Marichi, as you mentioned, how do we make sure that that desert from the local communities also is green, is totally green from our local perspective or African perspective?
You ask such a poignant question because it's very complex, as you're saying. It's not only top down and bottom up, but as scientists, as the people in science, it is our responsibility to go to the communities and engage in developing these relationships. Part of the challenge is that as individuals, we work within this system of science that in general says more, faster, quicker, and creates this sort of environment that's filled with pressure to get papers out immediately. And what tends to happen is that we're in this dilemma of trying to do really great research in an environment that doesn't allow for the time that is necessary to build those relationships. It's not something that we can just go one visit into a community and assume that automatically they're going to understand, want to participate, know what they want, how they want it. We have to allow communities the same grace of time to think through these things the way that we do ourselves, right? So when we go into community prepared with here's what we want to do, we can't assume that communities are able to respond immediately. And so we need to allow for that time to go in there. And I think also part of this is to be open to that communities might say no, but let's keep talking, and to recognize that that is also progress. The challenge, of course, is, as I'm saying, at a larger level administratively, and sometimes from funding agencies in particular, we don't have this, I'll say, luxury of time, but we need to be thinking systemically. And that's where I'm encouraging those with power and position to change some of these things, to start thinking broader in this way. How can we allow time, let's say with funding mechanisms, for researchers to go to communities and have time to co-develop questions, co-develop what benefits look like, co-develop how they want to be involved, to then submit to these funding agencies. That's just one example. I'll jump to you now, Marjorie.
Thank you.
Yes.
Yeah.
Thank you. If I may add to what Sadie was saying, is on a practical level, in each research proposal, there's room to tell the funder how you will disseminate your research. So building on what I've said before, the communication channels, and you need to go back to the community. There's already an entire field of science communication that is up and running with ideas and methodologies and tips and pointers. So maybe it's worthwhile incorporating into your dissemination portion of your proposal already a portion that says that with the help of science communicators or science communication methodologies, I will go back in a regular basis to the communities and tell them about my research as a form of benefit sharing, which could be one form. So this is just a practical pointer. There is, with regards to data sharing as a benefit sharing, or communication infrastructure as a benefit sharing form. I'm not aware that anything is happening in the African region or elsewhere. It's just on the conceptual stage or at this time. Thank you.
Thank you, Mariti. And we also have two questions from the online participants. The first is from Dale from Cameroon. He said, we have told about digitalizations of these communities where samples are collected. This provision is solely dependent on the government in most countries, but we have not been told how to work with the government. Could we look at this deeper? I don't know who is ready to take that.
Yes, maybe I can take a shot at it. It is very hard as a researcher or even as a consortium to negotiate with governments, and it's frankly not as a researcher's place to do that. That's more the realm of policymakers. That's why if we make people aware of other benefit sharing possibilities in the data intensive or big data era, policy makers can start that debate with governments. But as researchers, we can start small, as with the WhatsApp groups or the emails, trying to disseminate research and to to keep an open communication channel with communities without government involvement at this early stage.
Thank you.
And I'll just add one quick thing, that the Kunming Montreal Global Biodiversity Framework that's pushing 4 global goals and 23 interim targets towards living in harmony with nature by 2050 is involving all of society and all of government. Short term, I agree, it's still being really finessed about what does that look like, but there will be, pressure. Let's say we've all agreed, or many parties have agreed to this document, and it's outlining goals that we're all aiming towards. And so governments at some point will need to be involved more intensely. Now, what that looks like is being fleshed out, and that's going to differ government by government and then community by community. But it gives hope, I think, that we're all at least in agreement towards the goals that are in this framework and thinking broadly about what this looks like for us.
Thank you. Thank you. And there is another question from Johannes, I believe from Ethiopia. Are there any effort undergoing to mainstream data and benefit sharing at the regional, means Africa is Africa level? I believe this is an open question, which is, I don't know who should be the best to answer that. Sally, maybe if you have an idea, but while she should be coming, I would say there are different projects, even from the AU, for example, where they have different initiatives. We remember that at the African Union level, they have been putting the Pan-African Vaccine Institute at the global biorepository, not only for samples, but I believe the agenda for them is also to have a good server to be able to host not only the data, but information also. But at the African Union, they have been coordinating also access and benefit sharing for the whole focal point, ABS focal point in Africa. So this is the initial attempt to centralize and to coordinate aspects of benefit sharing in Africa. But also we believe the effort that is being coordinated by the GIZ ABS initiative, for example, is also to train and build the capacities and bring all the ABS focal point together to contribute to such initiative. I don't know if Sally has something to add to that.
I actually just have maybe one small thing to add, because even in the discussions we've had today, we had Priscilla also saying that there are things happening and there are meetings that they're organizing to try and also mainstream and do these things. But if we think about it on a grander scale, there's still a lot that needs to be done even internally in terms of institutions and just generally the researchers and the regulators, because at the end of the day, some of the conversations we need to be having is even what kind of benefits are being shared and what's, a reasonable benefit. So I can say that, yes, we do have efforts, undergoing to mainstream data and benefit sharing, but we still have a long way to go.
Yeah. Thank you very much. And a big applause for Sajay and Mariti. Thank you.
Thank you, everyone.
Thank you. Gracias.
Okay. Now I think I welcome Catherine for last note for today.
Thank you, Christian. Thank you all for being with us today. I think it has been a successful first day for this workshop. I'll just give a brief recap of the main points of the day, starting from the morning when we had our ILRI DG reiterate ILRI's support to the Africa BioGenome Project. And Prof. Ann came in and she said the Africa BioGenome Project is a movement, is a network that really rests on collaboration. So it is up to us to really, really build this community, build this momentum, and continue to do and work together and collaborate, and collaborate. The issues about data, ethics, and policies around data management As you saw from the PacBio presentation, huge data sets are being generated from the sequencing that we are doing, or from the work that is involved in this Africa BioGenome Project. How do we manage that in an ethical and very legal way as well? So in the afternoon, it was really about ethics, about policies, and also the legal framework that we can operate in as the Africa BioGenome Project. I do not want to take much of your time, but I just want to clap hands for ourselves, for the presenters, for the moderators, for this successful launch of day one. And tomorrow, let's be here at 8. We're going to start early at 8 for the registration, and I'll walk through the presentations tomorrow. So thank you very much for today, and thank you all for showing up and for being for very engaging discussions. Thank you.
And you're free to go home.
Yes, and to those online, see you tomorrow.
Develop an agricultural community project. We also extend our community support in sub-Saharan Africa, such as in Kenya, where we support the Gogo Boys Football Club in Kibera slums in Nairobi. We hope our support makes a difference.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of the few companies in the world that has the ability to mass-produce clinical high-throughput genetic sequencers. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, and BIT products. With a strong focus on the upstream of the industry, MGI operates in more than 80 countries and regions, serving more than 1,300 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
So the Greater Good initiative is really going to open us the door of the
genetic diversity of camels at the worldwide level, which really we cannot attain with our efforts alone. This will be a great opportunity to hopefully find new variants and variants that can be useful for the community, for livestock traits of economical interest.
We were doing work with sheep and goats. We had a relatively small sample that we genotyped initially, and the grant Illumina provides will allow for additional genotyping, so we almost tripled the number of animals. And awards like this allow us to do genetic and genomic discovery, and the discovery will hopefully lead to ways to feed people better.
Cowpea is a legume, so it produces a very protein-rich grain. So it's very important for food and nutritional security, especially in sub-Saharan Africa. We needed to improve the genetic knowledge of cowpea, and that's the essence of where the Illumina iSelect fit in, which was supported by the Agricultural Greater Good Initiative.
We're focusing on crops that are important in African diets. Sometimes you just need something to jumpstart you. For us, it's made a huge difference. We're creating sequence on species that have 0 DNA sequence in them, and we're able to do that quite efficiently.
The major emphasis of our research has been on enhancing the crop productivity in chickpea, pigeon pea and groundnut. The most satisfying thing for me is when we see that these technologies, they are being used in developing better varieties, which will be helpful to farming communities.
One of the things that should be said about the award is that it's really a big contribution in helping researchers both in plants and animals with reagents and activities that are associated with developing countries.
So my experience working with Illumina has been fantastic. Anyone working in a kind of omics-enabled capacity on a crop that has any relevance to the developing world should absolutely apply for a Greater Good Initiative award.